Oh yes, yes, yeah, for sure. That would be even better. I mean, yeah, no, no. I'm sure the photographer wants. Yes, for sure. Just in case I. On the stage. Yeah, yeah,
Quite a challenge to see this.
controllers in the back. Okay. Yes.
It's official.
Stand taller. Yes. Okay, thank you. Ah, with this light I cannot read it.
That's fine. Yes.
Yeah, that one was okay. I did it.
I'm from but what? You're a director, yeah. I've been there several times. I promise that I asked for. And it's your name? Yes, up and down. Okay, yes. Mm.
Dr. Erika or Erika,
Dr. Eric.
Dr. Erika. Okay.
One discussion. I got the.
The introductions
Yeah.
are quite long. I mean, you guys can work together to shorten them to be more consistent. So no, definitely no offense for me.
Okay, thanks.
I'm sure for all the others, just skipping things to write the, say the couple things that
Both
you
in
think
my
are
face.
most important.
Which one?
And the light is on. You see the numbers, then it's ready.
Can we start?
Yes. Say for Roger, say. Roger, if he wants to say.
Yes. We have here the back next.
That's what it's like.
If this works, yes.
And the microphone just.
Hello, good morning. Morning, everyone. Thank you for being here, and we welcome you to this session on enables for innovative nuclear, strengthening the EU strategy, competitiveness, and autonomy. It is a pleasure to have you all here. Yesterday, we discussed about achieving net zero by 2050 in Europe and the role nuclear energy shall play. Today, on this plenary session, we would like to explore the key enablers that can unlock the full potential of innovative nuclear technologies. We will look at three main pillars. First, technological enablers. Second, financial enablers. And finally, collaborative enablers. We will structure the session in these three pillars, and we would like to have interaction with you, and we will love to hear your questions also to our panelists. We are fortunate to have a distinguished panel with us today, bringing perspective from research, industry, policy, and international collaboration. I look forward to a dynamic discussion and to hearing how we can move from strategy to action. So let's get started.
So, good morning, everyone. I'm Benoît Bachet, and I will co-moderate this panel together with Marta. I'm president of IYNC, so the International Youth Nuclear Council, and I work for Framatome. At Framatome, I was in supplier quality management, then chief of staff to the CEO Bernard Fontana, and in Framatome, I now work for the integration of a new subsidiary called Gemont Electric. So let's start maybe with our first panelist, and I let Marta introduce our first panelist.
So let me introduce our first panelist, Thomas Reeve. He is coordinator in research and development in waffle engineering. Thomas holds a degree on mechanical engineering and material science and brings deep experience in structural mechanics. From 2015 to 2022, he worked as research assistant at Leibniz Institute for Composite Materials. Since 2022, he's coordinator on research and development projects at Waffle. Please join me in welcoming Thomas to the panel.
Thank you for the kind introduction, and thanks for having me. To be honest, 3 years ago, I would not have guessed to stand in front of a nuclear audience because I took an alternative entry route. Just in short, my personal information back ahead. So I'm quite new to the field, so why would you actually be able to contact me or ask questions, and why I'm sitting at the panel? It's more that Wölfel has a strong link to nuclear energy sector, because Wölfel is since the beginning of nuclear in Germany in the 1970s until today continuously involved in delivering services in the field of structural engineering for the nuclear industry, nationally and internationally. My personal goal is actually also to do some networking for R&D and for the future projects that lie ahead of us. So, what do we do at Wölfel since 50 years? It began in the 1970s actually with earthquake engineering for new nuclear power plants in Germany. The nuclear power plants were built in sites with a seismic hazard, and it was a question of how actually dealing with it. And we were able to design and proving structures and systems and components against earthquake, which was missing until then. It then led to the foundation of Wölfel Beratende Ingenieure, now Wölfel Engineering, and we had always a strong link to simulation. For example, the first FE tools were self-written for dynamics for structures. Then it all evolved, and by now we specialized in special load scenarios further to earthquake involving dynamics like hazardous events, as for example, pressure waves from explosions or also aircraft crashes. The expertise and scenarios are that we have structural verification and design of building systems and components for nuclear power plants and installations, for interim storage facilities and repositories, and also for machine foundations and components. Then the design for static and dynamic load cases, especially, of course, earthquake, operational vibrations, explosion, aircraft crash. We offer services for the full life cycle, so like new build, existing structures, seismic instrumentation and decommissioning. And regarding R&D, we had several projects, but at the moment we're still looking to dive into new projects. But one of them was actually the risk assessment and development of protection capacity for critical infrastructures. Further, we also had a look on scenario-oriented foundations and innovative methods for reducing risk of power supply failures, taking into account the impact on population. So we just saw the happening in Spain and in Portugal, and the studies we did within this project were actually also focusing on a power outage for like whole countries. And of course, we work according to international standards. So what brings me now to the panel here are like drivers for innovation and strengthening competitiveness. For me, one key aspect is the resilient low carbon energy supply. We have new nuclear power plants as well as SMRs. We have extended operation. We have the aspect of fuel efficiency and autonomy, and also the resistance against external hazards and external events. For example, of course, I would bring this up: seismic, flooding, high winds, severe weather, natural events, or also human-induced. And then the second aspect, which I think is a driver, is really the workforce qualification. As we saw yesterday, or we heard, there's a need of workforce within the upcoming years for 500,000 people being involved. And that's a huge challenge, so we need the next generation of nuclear expertise, and also, more importantly, even though, we need the knowledge transfer from all the experts we are having, and also knowledge management for the future. And finally, we have the point of policy and investment framework. So I think harmonizing regulations, which we saw already yesterday, is a key aspect, which is a driver for innovation, as of course also the secure funding possibilities. My expectations are that in the end we go out here with a common strategy on employing SMRs and new nuclear power plants, that we also know how to tackle the issue of lifetime extension, and in the end find European solutions, especially regarding regulations and standardization, and also use all European resources. We're from Germany. I mean, you all know that we don't have any nuclear power plants running anymore, but still we have the expertise and can contribute, so we are willing to do so. And finally, it's strengthening the challenging energy demand. AI is a good tool, but it's also challenging the energy which we are going to need in future. So, thank you.
I'm pleased to introduce now Ioana Davidescu. So Ioana is case manager at the Directorate General for Competition of the European Commission, specializing for state aid control in the energy sector. Ioana, the floor is yours.
Thank you very much. So the slides are up. Thank you very much for having me here. It's really an interesting topic and conference, and I'm genuinely happy to be here and to have the opportunity to learn more about the nuclear sector. So I want to also begin by extending congratulations to the organizers of this conference and to the hosts. I think they are really doing an excellent job in showcasing interesting research project in the nuclear field, and also kind of raising interest for the new generation to join the field, which, as we've heard in previous days, really a key challenge in the sector. It's really important to have them join this area. So a few words about myself. Yes, I am an economist by training. I work for the European Commission. For the last decade, I focused on state aid control, which is a specific instrument within the Commission's competition policy. And within this specific instrument, I had the opportunity in the last years to zoom into the energy sector. So I certainly am not an expert in nuclear technology, but I had the opportunity to learn a bit about this sector by working on stated cases in the nuclear field. So I'm here to share a different perspective to this field, to the nuclear sector and nuclear innovation, looking at it from a competition perspective, or say angle. So I hope my views will complement nicely the views of the other panelists. So maybe for the next slide, I want to say a few words about my perspective on the sector. So it's clear, and we have heard in the previous days, that governments across the EU, also across the world, are really increasingly working to keep the nuclear energy option open and to expand it, because it has a critical role in decarbonizing our energy systems, in replacing fossil fuels with a reliable low-carbon alternative. So I have seen this firsthand, as we are seeing more and more member states developing nuclear programs and also state aid support packages to increase their ambitions as regards power generation from nuclear. So it is clear that as renewables also grow, nuclear provides an essential backup power, and it's really important for strengthening the resilience of the grid, of the energy system, but also energy security in Europe by helping to get rid of the dependence on fossil fuel imports. At the same time, it is important to acknowledge that nuclear is not universally embraced across the EU. We've heard that a lot of work needs to take place to improve the public perceptions of nuclear, and this concerns obviously many issues: safety, waste management, but also the financial risks of projects that remain an important challenge. So reflecting then a little bit about the role of innovation in helping nuclear energy remain viable and competitive in today's very rapidly evolving energy landscape, I think first, there is a very significant contribution that innovation in the nuclear field can bring to reduce costs and to improve economic competitiveness. We have seen SMRs that use, or we expect SMRs to use simplified, standardized design that should reduce construction time, no capital cost, improve scalability. Also, we expect advances in construction techniques and project management that should also help reduce delays and budget overruns that have marred nuclear projects in the last years, and also have been maybe a driver of a bit of a negative public perception in the area. And of course, there are innovations in fuel and waste management technologies that should improve safety and also alleviate concerns of the public in this field. Then, importantly, from a market perspective, which is really a focus of competition, is that nuclear energy is really important to increase flexibility and integration with renewables. New reactor designs should have inbuilt load following capabilities. This would enable nuclear power plants to respond rapidly to fluctuations of renewables and increase the resilience of energy systems. and also reduces reliance on backup fossil fuels, contribution to the decarbonization of the energy system and of the economy in the end. It's also, nuclear is evolving as a multi-purpose energy source. It has applications, promising applications in various fields, and they are all important for decarbonization, for the competitiveness of European economy. It can contribute to the decarbonization of industry, to produce clean fuels, to enhance energy system resilience. So, and thirdly, I think nuclear innovation plays a vital role in improving safety, in building public acceptance, which are really essential for the future of nuclear energy. And there are contributions that, and I think projects financed by the Euratom Research Initiative also showcase a number of developments of really nice progress in safety, in advancing, let's say, waste minimization, in recycling technologies, in dealing with nuclear waste, and so on and so forth. So, lastly, I would like to highlight and tell you a little bit about an important element that I think enables innovation in the field, and it's an important tool that is used in competition policy. So these are important projects of common European interest. So many people think that this project or instruments are, stimulates various projects or ideas. But in fact, this is really a state aid framework that allows governments to support large strategic initiatives from R&D through to first industrial deployment, while minimizing market distortion. So the core idea is that the internal market must function on a level playing field. And in DG competition, we are concerned that if one government supports a national company with subsidies, it could give an unfair advantage to competitors, potentially fragmenting the level playing field, the internal market, but also reducing efficiency and being potentially an obstacle to innovation. So, but there are exceptions, and I think IPCI is one of them. It is designed to steer innovation towards EU priorities, like green and low carbon technologies, without creating these unfair barriers and protecting incumbents. So it's really an instrument that enables the Commission to approve public support provided by member states to important EU-wide large integrated projects. So far, the Commission approved IPCIs in about 10 IPCIs involving 23 member states, and which have mobilized important public resources. We are at about 37 billion in state support that managed also then to attract almost double that amount from the private sector. So, and interesting for this audience, I think, is that last month the Commission and the member states endorsed the design phase of a new potential IPCI for new innovative nuclear technologies. So it opens up, I think, opportunities in the field that you're interested in, and I am looking forward then to discuss more about it. Thank you.
Thank you very much, Joanna. Our next speaker is Massimiliano Taconelli, who is Vice President Nuclear and Big Science Director at Walter Toslo in Italy. With a degree in maintenance engineering and master in industrial marketing, Massimiliano brings deep experience in value management and benchmarking, project management, nuclear components. He has spent over 25 years at Walter Toslo, starting in technical and proposal departments to leading the nuclear business unit from 2009. Please join me in welcoming Massimiliano to the panel.
Thank you very much for the presentation, and thank you to invite me today, that I'm truly pleased to be here today alongside my colleagues to have the chance to contribute to this important panel and to have the chance to discuss about competitiveness and autonomy of the nuclear. And I will try to do it based on my expertise, so bringing the loud voice of the supply chain, which I'm proud to represent here today, and also based on one important belief that I have, that is AI, that is artisanal intelligence. Maybe you misunderstood my point. That is a kind of devotion to all the organization that in the last 20 years, resist to maintain the skills in the nuclear field, even in a very difficult moment. As I'm here today, let's say, serving a dual role. The first one is as representative of Walter Tosto and the Tosto Group, and another one as Vice Chair of the Technical Working Group 3 at the European Industrial Alliance. Technical Working Group 3 means supply chain again. A few words about Walter Tosto, that is a private-owned company and is an industrial company that is active in the manufacturing of large, heavy, and very critical items for energy and industry in general, that is based on a strong world culture, the use of strategic assets, and the state-of-the-art technology. We are 1,350. We are based in Italy, in Chieti, our headquarters, in the middle of Italy, in Mantova, in north of Italy, with the company Belleli, in Romania, Bucharest, the capital, and Oltenica on the Danube River, and in the Emirates Arab, in Amria, the free zone of Dubai. In nuclear, essentially, we are active in manufacturing of components for generation 3, for SMR, NMR, fusion components, and components for the decommissioning. Again, here to discuss and to contribute to this panel, and with a clear expectation, that is to, again, reassess and to put the supply chain at the middle of the discussion of nuclear, and doing by assessing its key dimension, so all the ones that you can see on the screen, that to us are the technological, the technical, the environmental, the engagement, the commitment, the readiness, and the innovation of the industry. Thank you.
Thank you, Maximilian. I'm pleased to introduce now Dr. Erika Holt. She is an expert in radioactive waste management for VTT, the research center of Finland. The floor is yours.
Thank you. Also, good morning on my behalf to everyone who's here, and also a pleasure to join the panelists. I joined this panel from the perspective of the waste management hat, and also from the research community. So a bit about myself is that I've been in the waste management field specifically for 20 years and doing R&D for about 30 years. Currently, or that whole time, mostly at VTT, the Technical Research Center of Finland. And these topics of innovation, of course, are very important to us from the research community, because that's what we strive for. And in research, it's not straightforward. We should have risks, we should have uncertainties. But it also means that then we're strong in our project management and engagement with the people from all different aspects, if that's the supply chain or from policy. And that's been part of what my career has also been in strategy topics and customer management types of roles. I think similar to many of us in the room, we also don't necessarily study nuclear energy. My background comes from civil engineering and tunneling and material science, and I thought, oh, I'll go to Finland for 1 year and have this great research project. And 30 years later, I'm very deep in nuclear waste management with a diversity of skills. And I hope that also brings inspiration to the younger generation or the next generation, that it's not that you have to be a a radiochemist or a nuclear physicist to make an impact in this field, also as a woman. So I'm proud to hear a lot of the comments yesterday from the younger generation and focused on STEM to get people into the nuclear sector. And that's also what I think really strives for innovation to bring the cross-sectoral topics. From the perspectives on the panel, also I hope to share a bit from what we have been doing in the European Euratom domain, especially on two very large kind of umbrella projects, which have changed the style of how we've done research in the last 5 years. Two of those big umbrellas of EURADWASTE, which is more focused on the waste disposal, and recently the PREDIS project, which was on the predisposal issues. One thing that came up in the last 5 years when we were getting ready to really focus on predisposal issues of waste management is the first comments were, why would the EU or industry spend another euro on this topic? There's plenty of countries who are already doing waste management in predisposal issues, but that doesn't mean we stop with innovation or technologies or new enablers. You don't stop developing a mobile phone from the dial phones that we had 30 years ago. So we also don't stop innovating in topics like predisposal waste management to support the directives for waste hierarchy, for recycling and reusing, or being prepared for new materials that come on the market that are cheaper or more efficient, but are still maintaining the safety. So that's, I think, also these drivers for innovation and some examples that I hope to bring to our panel discussions from those types of projects. A few moments about VTT, just as a research center, I think similar to many of the other research organizations across Europe, that we do cover kind of all aspects in nuclear, and that may be in innovation for extending the lifetimes of our fleet, understanding new topics, for instance, 3D printing of spare parts to make outages faster. Also in new build activities, especially focused on the SMRs and material science that we will need for these new types of reactors, the simulations that we have, and in cooperation with industry and with other research parties and also technical support organizations, really looking at what are the right types of codes and tools that we can maintain independence and diversity to accelerate digital technologies and simulations. Of course, many of us are facing decommissioning. Also for us in Finland, we decommissioned the first research reactor on the VTT campus, which is in the suburb of Helsinki, in the middle of a university campus. And so really using that also in the last years as a test bed for innovation, being able to use artificial intelligence and robotics and wireless sensing and new characterization tools. So using a decommissioning project from an R&D perspective to also enable companies to come in and test and build ecosystems around their products and services that will hopefully then let them deploy it at a larger scale, not just in Finland, but globally. In VTT, we're also covering waste management. As you might have noted yesterday in Ilkka Poikkalainen's presentation from Posiva, Finland will be likely the first in the world to put spent fuel underground in the Onkolo site, and VTT has been there with Posiva and our nuclear power plant utilities for decades to get that implemented. So we do have a long history of understanding the back end, and nowadays we're also applying that in the readiness for the deployment of SMRs and taking a very strong active role in understanding the new waste streams that are coming, what type of packaging, safeguards, interim storage, and actual can those waste streams be disposed of when we look at Gen 4 types of reactors. And of course, in all these activities, we're always trying to be innovative, not doing standardized things. There's plenty of other companies out there who have standardized services, and we're trying to help those companies, as well as industry, policymakers, and regulators stay one step ahead to look at the new technologies that are coming into the market, which we hope are game changers for you also. So regarding this panel, and what are some of my first thoughts and things we'll share about innovation and strengthening competitiveness. We do feel it's really critical to have these type of events, not just that you're listening to us lecture on a stage, but that you're asking us questions, that we're talking during the discussions in the coffee breaks, because it's important together that we understand what are the biggest challenges. Where should we focus our innovation that will make the greatest impact? So we need to understand the market together. We need to understand the competition from an R&D perspective in our Euratom projects. Is it worth focusing on that task, or is that already on the market? So we should really understand what are the needs for R&D. When we are doing R&D, it's critical that we hear the voice of those end users. That might be in the supply chain, that might be a large utility or a waste management organization, and a lot of times it's also the regulator. We need to understand what does the end user need, because when we develop something through R&D, we need to ensure that it's going to be uptaken by practice, by the member states. In technology readiness level, or TRL, there's this valley of death around TRL number 6, 7. We can spend all the money in the world to develop things and prototypes and laboratory scale or simulations, but getting it into practice in that last TRL or 8 or 9 is where there's the big hurdle and needs a very high investment, typically financially, for building prototypes. So if we're not doing the early stages of R&D together with the end users, we risk that it's being done in vain and it's not going to be taken up. And therefore it's very critical, I think, in R&D that we're also engaging with the end users, that they can provide real parameters, real materials, allow us to be in their facilities for doing the upscaling. And we shouldn't be doing these things alone. It's great that we're here together, that we have the avenues via the partnerships and the Euratom type of projects to collaborate so that we can bring complementary expertise and build up those ecosystems of various players. And then, as I noted at the beginning, it shouldn't be easy. There needs to be risks. That's also where the innovation comes from, and that we can adapt things from other sectors, but we should take risks, and we should fail, but we should fail fast, and we should talk about the things that didn't work and document those as well. So those are some of my first thoughts about how to get innovation farther from a research and a collaboration perspective. And from my views on this session, I really hope that we're also hearing from you. It's not just the experience or ideas of us on the panel, but also we hope that you bring engaging questions that will spur us to think a little bit deeper and think how we should work together better in the future. So thank you.
Thank you, Erika. Our final speaker is Frederick Reitsma. He's Section Head Nuclear Power Technology Development at the IAEA. Frederick is a reactor physicist with more than 20 years experience in high-temperature gas-cooled reactors. Since June 2024, he is the Section Head of Nuclear Power Technology Development at the International Atomic Energy Agency. After spending nearly 4 years as Director Analysis at Ultrasafe Nuclear Corporation, designing and licensing a microreactor for the US and Canadian markets. So please join me in welcoming Mr. Reitsma to the panel.
Good morning, everyone. Thanks for the opportunity. Thanks for organizers. I'm happy to represent IAEA at this meeting. A bit of my background, maybe just a bit more information. When I started, I was doing methods and code development. I'm a reactor physicist by training, and I'm very proud that we were able at NEXA, the National Lab in South Africa, to establish the OSCA code system that's today being used by many research reactors throughout the world. Also, maybe to mention, I've been at 4 startup companies. At PMOR Projects of Africa eventually was funded by the government, but I think in the first 6, 7 years, it was really on the last day of the month, we had a meeting and the CEO would tell us if there was money to pay salaries. So that was also really a startup company in the beginning. So for me, the technology is very important, but finance are very important. So I've been working for so many startup companies. Of course, if you don't have money, you can't make anything happen. So I was then 7 years at the IAEA as a team lead for small modular reactors and high-temperature gas-cooled reactors, and happy to be now back at the agency. Collaboration is very important, and that's really what the agency is about, this type of meeting. I was in Gemini 4 up until 2 years ago, also contributing to GIF and NEA, OECD. So I think many of you are also incorporated there, and I think it's important that we use that opportunities, but also that we focus and really do less talking but more action if it's possible. That's very important. So at the IAEA, I think it's well known, we have 6 different departments. The agency is probably best known for safeguards, and in the news about safeguards all the time. Nuclear safety is also very high profile, but we also have a lot of nuclear applications, so that's the medical applications, applications of nuclear techniques in different areas, agriculture, for example, and then nuclear energy, where I'm part of. And I'm in the division of nuclear power, and the section is nuclear power technology development. We look at advanced water-cooled reactors, so current generation, and enhancement to that, fast reactors, small modular reactors, including high-temperature gas-cooled reactors and molten salt. Then very important, and I saw it got a lot of interest at this meeting already, the conference, non-electric application. And recently, we also add fusion technology to our section. So when I thought what to put forward as maybe my expectations or the enablers, I thought the IAEA a few years ago, I think 2022, established the SMR platform. And this is bringing 18 different sections of the agency together and serve as a one-stop shop or a central area where all information on the activities of the agency and SMR can be shared. And I thought this is a good model not only for SMRs, but also basically what the agency is about and all the elements we discuss here, from technology, collaboration, financing. So for example, there's a section looking at energy planning and economics, the technology development where I'm in, and things like the RS database we have, and booklets and catalogs that we publish. But there's also safeguards, safety, the law, of course, is very important. The legal framework for member states need to be in place, and many other areas. So I will keep it short. I think it's important that we have some discussions, and looking forward to your questions. Thank you.
Okay, now that you know our panelists and know their background and their first thoughts about EU competitiveness in the nuclear field, we would like to start a discussion, not only with the panelists, but also with you. As mentioned, we will structure this discussion in 3 parts or pillars. We will start with the technological enablers, then we will go through financial and collaborative enablers. If you have any questions or any query or something you would like to ask our panelists from the different visions they have from industry, research, financial policy, please raise your hand or send it through the app, and we will be more than glad to ask this question, okay? So we have 45 minutes for the discussion, and we look forward to your incomes as well.
So let's start with the first pillar, with the technological enablers, and maybe we can start with a first question, looking across the different areas of nuclear R&D, like materials, digital tools, and so on. So where do you think we have made the most real progress over the next few years? And maybe we can start with you, Erika.
Sure. From our perspective in the waste management there has been huge efforts to make sure that we can implement the solutions, especially for the deep geological repositories. That doesn't say we disregard others' ideas, but from a progress in the last 3 to 5 years, really making sure that we understand the barriers, the types of canister or packaging materials that have a durability, the types of clays that would immobilize, the radionuclides, new types of concretes that can survive for thousands of years. So we cannot use off-the-shelf types of recipes that might come from the building materials sector. And we also have strong limitations in the types of materials we can use so that there isn't degradation in the repository. So we have to be more cautious on issues like corrosion, and that means we might have limitations, for instance, to the chemicals we use in concrete. I think also for ensuring safety, there's been great innovations in the types of digital solutions, especially in monitoring systems. You can imagine in a repository, you don't want a pathway for water. That means every single wire on a sensor needs to have high risks. We also have to have things extremely durable for these conditions because the public, the regulatory, for instance, during operation of a repository, which can be about 100 years, they want to make sure that it's safe before we close things. So definitely innovations that need to be off the shelf. We can adapt them from other sectors, for instance, from aerospace, which also has harsh conditions to send satellites to the moon. And that's why these kind of cross-disciplinary approaches are good, but we need to make sure that they are tailored for the nuclear industry. So for us, this materials science and also monitoring for harsh environments and preparing for future fuels, also in immobilization of wastes, for instance, use of geopolymers instead of cement, those type of topics have been very critical to help demonstrate to member states that we have new materials, we have understanding of their long-term performance, and that they can be safe in these interim storages and low and intermediate level repositories, but as well as very high level repositories. And that's definitely been a cooperative effort across Europe.
Thomas, would you like anything to add from the industry?
Yes, sure. Thank you. So, yeah, very interesting on the repository side. To be honest, in Germany, we are facing the point that intermediate storage is also being a long-term issue since we made the decision to have repositories in 2070. So maybe we can discuss a little bit later on. But for me, the advancements, so I'm going shortly on fuels. So I think SMRs, you have several new concepts. So that we are going to see which fuels are actually going to the market in a couple of years. Regarding materials, you already noted that we have new demands, so new reactor concepts, either SMRs or even fusion. We are developing new materials, and it's always about the long-term evidence of those materials. Also, they have to withstand different scenarios like higher temperatures. So it's always important to predict this part. And on the other hand, we have aging infrastructure. If we're looking into long-term operation, we have to make sure that the predictions we are doing are right and that we can actually work on this part. And finally, for us, I think the most aspect, since we have a strong link to simulation, are the digital tools. So, of course, we have artificial intelligence and machine learning, but for me, artificial intelligence in general, or at the moment, is really like a knowledge memory, if you want so. So we face the challenge that, for example, in our company, we have experts which are at the company for next year 50 years, and right now I can go to the office and just ask them. In a couple of years, this might not be the case. So we are very happy to have the situation, but it's a challenging task in the future. And the more we can actually use AI for these tasks, the better. It doesn't help with experience that comes with life, but it helps actually with managing the knowledge. Then regarding simulations, we have over the past decades also seen that the possible outputs have improved significantly thanks to increased computational power as well as advanced material models. So we are also able to acquire new material data, for example, stress-strain dependencies, stress-strain rate dependencies, and finally, building information modeling is also a key, which I think was an improvement within the past years, because it's helping to preserve and transfer nuclear know-how, and which is an essential task for the sector for the generational turnover within the next years.
Max.
So thank you to Thomas to advocate artisanal intelligence as well with me. So I will try to combine the two answers from Thomas and Erika, because I'm in agreement. So in the sense that we had a very good improvement in several different fields. And I'm in agreement that there are two words or two topics to very well address. The first one, to have off-the-shelf technologies available for the market. And the second one, to have and to maintain the experience. And to do that, we need something very, very clear. So if you allow me, I will try to make a comparison with fusion. And I'm sure that you have noted that we have plenty of new startup and initiative in fusion, and how good, how fast or quick are such startup in reproducing what has been already tested with a huge effort from ITER. Clearly, they had access to all the documentation, all the paper, all the experiment. This is very, very important, but more, they had ready a supply chain. So from the production of the material, knowledge, people with competencies, skill, everything was prepared. If we don't have mega projects, clearly we cannot spread such competencies or innovation. And there is the risk that only the main player working on a specific innovation will have access. Then I think that this is a very important point to be addressed. So we need mega project. I don't know if you...
Yes, I think maybe to add on, I think artificial intelligence are growing. I know most startup companies today look at having a digital twin, but I also think that the amount of resources required for these projects are massive. I'm not sure if the startups always have the capability. I remember when I was at USNC, we had a small team looking at digital twin. I mean, I'm being talk about less than 5 people. And then I learned that in EDF, there was 400 people working on it. So then I was wondering if the startups have any chance. But hopefully with information sharing, I think there is a possibility, and I think the fusion industry is a good example. I think many of the advanced modular reactors require additional experience and data, and I'm happy to see that some of the startup companies are building prototypes, even if it's non-nuclear prototypes, to really enhance the technology readiness level. And yes, this may be costly, but they are trying to do it as cheaply as possible and learn from this. So the Hermes reactor, for example, is being constructed at Oak Ridge by Kairos. And I know many other SMRs are really trying to build test facilities or even mock-ups to try and enhance the technology readiness, but also very important to have information validation of the codes available for licensing with the regulator. And maybe lastly, I think harmonization was mentioned. And I think especially for SMRs, if we don't get a standardized design that can be rolled out in many different countries, I think the business model doesn't make sense. So that's very important. It's not only on regulatory side, it's also on the technology side. So things like user requirements, codes and standards. We heard about things like fire protection regulations. That's different in every country. So I think a huge effort is required there and to make enhancements on the technology side.
Well, we have some questions from the public through the app. We'll try to incorporate them here and continue with the conversation, and the remaining ones we'll try to address them at the end. But we have one question to Erika about what are the practical changes that outcomes of the PREDIS brought for the rat waste management, and if there is any solution that may have been applied in the industry.
Sure, great question. From the pre-disposal project, as I noted, there was kind of a hesitation, why are you doing this? But I think some of the biggest outcomes were really related to these new materials for immobilization of troublesome or challenging both liquid and solid organic wastes, and looking at binders, especially geopolymers and new types of cements. The other, I think, big topic that we looked at a lot was trying to improve the understanding and predictive degradation of packages through monitoring and digital twins that can be used in an interim storage facility to look at, for instance, premature cracking due to alkali silica reaction in concrete, and try to think, are there earlier ways that you can detect via monitoring and artificial intelligence and data models. And all of those tasks, the whole project was co-funded by industry. I'll come back to that a little bit later in the discussion as one of the enablers for engagement. So maybe I take that a little bit later.
Yeah, I think it's, let's talk a bit more about financing, because this is very interesting, but we also need to see how we do it, okay? So maybe Joanna, as you in the introduction, you already mentioned, so as innovative nuclear technologies move closer to implementation, securing financing becomes more crucial. What are the main goals of the state aid control in the nuclear sectors, and what key challenges you have observed in recent cases?
Thank you, Marta, for the question. So I think it's maybe a bit of a different perspective, but it's important to explain a bit what are the objectives of state aid control, also because in general it's perceived as an obstacle. No, it's a lengthy process that delays public support to projects. So it's important to explain, and the way we look at competition policy and state aid control is a horizontal enabler of policy goals. Most important one that we're looking at is really decarbonization, and we think then that competition and state aid control can really work. It's a piece of a puzzle of a number of policy areas that are required to meet this big challenge that we're facing, and while keeping the European economy competitive. So we need innovation, and we've seen we need taxation, we need regulation, we need industrial policy, we need a number of a mix of policies to further develop the nuclear field. So that's why I think it's really important to say a little bit about state aid control. Let me also start by saying that the way the Commission looks at the nuclear sector, it's really neutral. It is clear from the treaty that member states have a choice to choose their energy mix, and that entails also the decisions to finance the nuclear area. So what are the key kind of conditions for projects to be kind of meet the state audit control criteria and to then be eligible for support from member states' budget. There are a few key principles that really apply on all sectors, whether we are talking about innovation or mass deployment of technology or training and so on and so forth. So the first thing is that the first thing and the key point is that there has to be state aid. So this means that state interventions into the economy need to give an advantage to a company that other competitors don't have. So once this criteria is fulfilled, the key kind of compatibility assessments are that any project needs to target a market failure. And these market failures, for example, for nuclear new build, refer to the scale of capital requirements, this lengthy exposure to market price signals that really make it that private sector does not deliver in projects. We have similar market failure innovation. We have we have uncertainties. We have a situation where a cost of a first unit may be too high for the private sector to deliver, and then this requires state aid support, and it's then important that projects show this kind of, fulfill this criteria. And then a second important point is that aid from member states should not excessively distort the level playing field in the internal market and the market signals. So we look at this from various angles. When it comes, for example, for nuclear new build, it's important that if there are price support mechanisms that really shelter the investor from the price signals, these are really designed in a way that allow system flexibility and decarbonization. It is important that aid does not create barriers to other technologies, for example, renewables, but also in innovation. It's important, for example, that there are commitments to spill over, to share that research so that there are benefits across the value chain and across competitors in a sector. And an important point that we're looking at also is that when a beneficiary has significant market power, so this is obviously more about really market investments that are closer to the market, then the aid should not really increase the dominance or allow manipulation of markets. And there are various safeguards and controls that we are paying attention with. And finally, and this again applies across all fields and projects, a key requirement that aid must be proportionate. We're looking at funding gaps, so it's really important that any support does not go beyond what is really necessary for the project to go ahead. So maybe I stop there, and if there are any questions, I'm ready to answer.
And maybe now I have a question specific for you, Thomas. So what are your experiences regarding the funding of nuclear R&D, so in general and in the nuclear sector energy?
Thank you for the question. So mainly what I'm doing as my job is getting funding for R&D projects. So what I did in the past 2.5 years was mainly having 10 to 15 sketches. I didn't count the number. And half of them are funded. So usually in our department we have up to 5 and to 10 projects running in parallel regarding R&D projects. So overall, it strongly depends on the program and even more on the network you're having. So the better the network, the easier it is to get a good consortium. With respect to nuclear, there are some funding possibilities in Germany still, which are mainly for preserving the technological expertise, as well as supporting new talent in nuclear energy and safety, and also addressing long-term issues. For example, for us, it's decommissioning right now, and radioactive waste management in some parts. But if we look at our scope of dynamic loads, this is really not applicable. So we always have to. So I'm here as a member of SNETP, and it's key to have those networks to actually get consortia together. Also, I think the SMR Industrial Alliance is such a network, although they are focusing on emphasizing the approach on SMRs. In the end, it's going also to bring people together to go ahead. And also, when you go ahead, there's always a risk, so there's a reason for funding, in short. And I think overall, there are different possibilities of having funding. It just depends on the scope you're having. For us in general, right at the moment, we are not having an R&D project in nuclear, but as I'm here for networking, we hopefully can contribute to this too.
Maybe I could add also to what you said that I think we've been shifting away from the old style of like throwing out 20 applications and hoping 2 of them pass and being in massive competition with each other and then starting over again 3 or 4 years later. I think we've tried to be shifting in any sector, if that's in waste or in lifetime operation or new builds, to having these type of cooperative partnerships where we look as a group together, if that's via SNETP or IGDTP or other types of fora, that we pool together, we have a strategic research agenda, and as the SMR Alliance is doing now, what do we need going forward? As a community, what do we need? And then trying to link that really strongly to the member states. And for us in waste and also in material science with the Connect platform and Pianoforte, other joint partnerships where we say, okay, we're going to address what the member states need also, and they're expected then to co-fund it. And that has also improved, I think, in the policy at the member state level. For instance, for us in Finland, we can now utilize the national program where we have the Waste Management Fund and we have 10 million a year in R&D, and that can be counted as what we contribute as cooperative work, that we're sharing our national program R&D, not just published in Finnish, which very few people can read, but to get that into the European context and have that sharing. But that's been a change, I think, or shift how we plan the cooperative EU work. And that also, I think, touching on what Max said, enables the maximum access, that it's not just in Finland or just my company or my research center's IPR, but that we're doing it cooperative and hopefully putting it out there on the table in an open access format for others to build on. So I think we've been shifting this financial mindset in a positive way. Of course, it's hard to convince your member state, and for some players it's hard to get the commitment, especially if their role is more in knowledge creation, but it's a shift that I think is for the positive.
Yeah, maybe shortly to add, for financial enablers, I think not only funding is key, I think also if you look at what I said at the beginning, I think if you tackle regulations or just have a look on emphasizing European solutions on regulations, it's also a financial enabler, because then it's actually easier to see the risks and actually mitigating those. So that's also one aspect of financial enabling.
And maybe Max, for the enablers for small and medium enterprise within Europe, you have something to add maybe?
Yeah, let's say if you raise the question very easily, I think that the answer will be very easily all the organization looking to financial support, to contribution. And maybe you are even not in the best position to raise the question, because Framatome invested €1 billion in the last 3 years. Then let me say, I won't be unpopular. I do not agree. Let me explain a little bit better. It's not enough. So nuclear is quite peculiar. So is a resilience, a clear aim, and a strong application is needed to enter and to stay in nuclear. not only funds or opportunity, and the supply chain is not going to happen somewhere else because we will have a market. It's not working like this, because in nuclear everything shall be done upfront, as you are doing in your organization. And clearly small and medium organization cannot easily or simply afford a very large investment. Definitely they need to be supported, but the support is not just finance. The support is to have the chance to provide a clear and stable market for the next years, plenty of opportunities that will allow them to invest in people, organization, and equipment to enter into nuclear market. And finally, but very, very, very important, we definitely need some sharing program, because it's a kind of knowledge culture, let's call as we want, that needs to quickly and easily pass directly by organization workings in the same field. And this is not very happy, because not very simple, because typically, let's say, competitors are not so open in sharing the level of expertise, but we have to stay one step ahead. So we must do it, because otherwise nuclear is not going to happen, because the existing organization are not enough to cover the entire volume of work that we would like to have in the next year. Then it's for all of us.
I think some collaboration is being mentioned, so I will take this opportunity to go into the third pillar we mentioned at the beginning about the strategic collaboration, and also linked to the funding, maybe again to Joanna. The European Commission has approved the initiation of the design phase for the new potential important projects of common European interest, IPCE, focus on innovative nuclear technologies. So we would like to hear from you what next steps are required to turn this project into reality.
Thank you, Marta. So indeed, this IPCI, it's really an example of collaboration across member states, across the industry, and really a dialogue with the Commission in the context of the Joint European Forum for IPCI, which is really this forum that has various kind of working level structures that is really meant to identify the technologies that are key for European competitiveness and strategic autonomy, and then make them happen, basically. So as I said, IPCI is really a state aid tool that is useful to support important innovation where the private sector cannot take the risk. And there is now an opportunity to do this in the nuclear sector, as has been the case in the past, for example, for semiconductors, for batteries, for hydrogen, where the Commission and Member States promoted IPCIs and managed to mobilize really a lot of public and private support for interesting projects. Now, what are the key steps to make such an initiative a reality? It's important then to say that endorsement, which is what just happened last month, does not equal funding yet. It really starts the design phase of the project. That is really an important step to shape the scope and the structure of such an integrated project. Participation remains still flexible across member states, across industry, and countries are free to still, determine the level of involvement, the amount of funds that they would put into this project. It's important to say that funds come from member states' budgets in this context. So I also have to say that, and to stress that a successful outcome is also not given. There has to be a lot of work and close collaborations across the industry, across member states, with the support of Commission services to get companies to to participate and to really identify projects that were pulled together in an integrated approach. So I just like maybe just to say that there are a few key conditions to receive kind of clearance and support, and the most important one is innovation. Projects really have to promote breakthrough technologies that go beyond the state of the art in a sector, but they can fund up to first industrial deployment, so projects that are about pilot lines or demonstration plans, things that really help technologies move from the lab to the market. But they're not about mass production or commercial activities. Then another important project, and I think we've heard from the panelists how important this is to share the results of the innovation. That's another key conditions for participating in an IPCI, namely that there are positive spillovers, that participants and beneficiaries share the knowledge and the innovation coming from this innovation that is enabled with public support. And there are various ways to do this. They are required really to commit to, for example, when we're talking about research infrastructure, to grant access to interested actors, to laboratories or clean rooms or pilot lines, or to license technologies when you're talking about IP protected research on a fair, non-discriminatory basis to interested organizations. Then another key important conditions is projects must be integrated. They have to have to be put together and to have a unitary approach that covers a number of member states. 4 member states is a key condition, because this is really a very specific tool for promoting innovation under the stated framework. And there has to be cross-border collaboration and then a sharing of research and various synergies and so on. And then, as I said before, it is really important for projects to demonstrate funding gap, that there is a need for public support and additionality from the public support that makes the project really come to the market. Maybe I stop there. Thanks. And see if there are questions.
And about strategic collaboration, I have another question for you, Maximilian. So do you have maybe example of successful strategic collaborations where you have participated in?
Yes, I have at least a couple of very good examples, but because of nuclear, I will try to mention ITER again. And I moved back in 2009, where we were very lucky in finding Ansaldo Nucleare and Westinghouse, and have the chance to join them in participating to the manufacturing of the vacuum vessel, that is the nuclear reactor of a fusion reactor. And we have found very good partners, very open and fair. This was a kind of booster for us. We were 3 companies, 3 organizations, very different one from the other in terms of expertise, sites, point of attentions, and it was very inspiring for us. But I won't limit the benefit only to the consortium, but to the entire enterprise. There was a moment in the ITER project that was a very tough moment, the moment in which we tried to switch from the research approach to the industrial application. It was extremely difficult to change the mind of the 5,000 people working around the project. And we have rent a building, and we put 100 people together there, including the customer, the domestic agencies, ourselves, the consortium, the key suppliers, the notified bodies, the laboratories. It was like an open innovation experiment. And was very good because there was no competition among the partners, and all of them, the entire enterprise, worked very good in switching to the industrial application for the final target. If I can recommend an approach for the organization that would you like to join nuclear and so on, and typically, let's say, to apply in a consortium is a way to facilitate to enter in a new market, and I can recommend not to follow the lawyer recommendation. So the lawyer recommendation is try to be as much vertical you can. You have to divide, you have to build wall among you because of the responsibility. This is true. But the day in which you are building the wall, you are clearly limiting the exchange between the partners, and you also lose the possibility to learn. In our consortium, we had a completely transversal division, and we were liable and responsible for the good performance of the bad performance of our partner, and was so easy to be open and transparent in collaboration.
I think we've heard the panelists' opinions, and I'm going to pass you one of the questions from the public. I think this one is to Frederick. Streamline licensing as enable. How does the IAEA feel about product-based licensing for SMRs? Anything it can do to make it happen? What about the artificial intelligence supported licensing? I don't know if this is exactly your field, or if you could give some opinion on this.
Yes, thank you for the question. This is not my area that I'm specifically working in, but I agree. I think the licensing is very critical, and to try and get a single license across different member states. The agency have, it was mentioned yesterday morning, the NESI initiative. So this is harmonization, and there's two legs. The one important leg is on the regulatory side. I think, of course, it's the IAEA is facilitating these harmonization. The final decision and legal framework is in each member state. And of course, their regulators have the final say. But I think it also has been raised here, but also in the past, that maybe the aircraft industry, where aircraft get licensed and is accepted internationally, and the local authority look at the rules locally after it landed, what facilities are needed, what conditions. So still have an important role, but do trust the international licensing. So I think that's a dream, and I think there's a lot of progress been made towards this the last few years, but there's a long way to go. And maybe this is own opinion and maybe controversial. It might be easier for the countries still want to deploy nuclear, because they don't have an established regulator, and many of them have actually said that they will only deploy a reactor that's already been licensed and operated by a vendor country. So in essence, saying once it's licensed there, they will look favorably at such application. But that's very important, and I think it will be critical really to be successful, especially for small modular reactors.
You look at me because you mentioned AI.
Oh, okay.
Yeah, I think that we are asking too much to AI, in the sense that we have to use for what it is, a powerful calculator. Okay, so then it will belong to us. It's fine to use it. We must use it. It's very powerful, and it will be by us the sensitiveness in input data and the sensitivity in understanding the result. So if we are using it in this way, why not? If we expect that it is going to solve issues that we don't know how to solve, I think that is extremely dangerous.
I completely agree with you. So our experience is only use AI for the last mile and try to understand as far as possible, and just use AI for like data acquisition, or just looking into several data sets, but really just the last point.
And another question coming from the chat, so to all the panelists. With all the challenges that we are facing as the nuclear community, so from LTO to new build of large-scale nuclear power plants, from getting new reactor designs like SMR to the market to implementing DGR, is there still room for fundamental R&D, or should we better focus scarce resources on the challenges before us? Who wants to start? Erika?
Yeah, I can take it from the research community because it ties very strongly to human capacity development. We should be continuing to gauge with the academic from the university perspective or younger generation that might be in our companies or research centers. And they might need to dig into the deeper fundamentals so that they understand the background to that AI model code. And that is a way that they can get familiar with nuclear. So I think there should be a balance between we need to do good innovation and good science by understanding the fundamentals, especially in cross-disciplinary approaches to basic science. So I think there's room for all levels of that, TRL that might be down at 1, 2, 3 in the theories and the philosophies and the processes. And especially when we're looking at new materials, new types of fuels, things that haven't been done, we need to understand the basics of chemistry, material science, physics, to be able then to upscale it. So there needs to be that blend, and that is a way that the next generation can see they can do good science, but hopefully they're motivated and inspired that it can be used for jet propulsion in a reactor to space, or a great type of fuel that is going to be reprocessed and eternal, and severely minimizing the footprint for waste disposal because of the reprocessing. So we need both sides.
I imagine.
Yeah, I can add the agency, one of the important pillars of collaboration is our coordinated research projects. So this is typically a research project that the agency coordinate on a topic of interest, often fundamental research, and typically with small funding try and get, say, 6 or more organizations from different member states together. And I must say, often the outcomes of these research projects are really very valuable later on. So often it also captured a lot of the knowledge at that time that even many years later on, especially I think if we look at reactor technology, there's really nothing new under the sun. All of the modern designs, if you go back, you'll see some publications in the 50s and the 60s where someone at one or other national lab looked at it and even do experiments. So there's a lot of valuable information on fundamental research that we can use as a basis today.
I think we have one clarification, maybe to Max, something you meant. You mentioned. What do you mean with SMR mega projects, and what are the difference with the fusion case?
Let's say ITER is 10 times larger than the overall sum of all the other research projects in Europe. So when we talk about mega project, it means that we need projects that can be accessed by plenty of organizations spread all over the Europe and for the entire supply chain. So INCAS teach us in building pyramid from the ground. Okay, so the top is gold platinum. We fully recognize the important roles of the technology developers and the operators, but we have to be there, and to be there, we have to start from the ground.
I think we have time for a last question, and this is a bit, how is your feeling? And there's one question, do the major armed conflicts and the consequent threats stimulate or hinder innovation in nuclear? I mean, the new threats we have due to the armed conflicts. Do you think these have impact in innovation in nuclear, positive or negative? Does anyone? Erika.
Yeah, I can take it from the research community. I think that it has been a driver to accelerate the research on fuels, for having resilience and autonomy here in Europe. And definitely, of course, we're looking at SMRs, and even for us, like in countries in Finland, in reducing imports from neighboring countries, then we have greater investments towards R&D in research technologies and especially fuels. And there are quite many of those projects that are driven by what's happening. And I think also in safety issues, safeguards, understanding what are the consequences or risks, and also how to, for instance, even in just characterization or monitoring, accident release scenarios or dose releases. So I think there are R&D that has shifted because of the global economic and political and security issues.
Yeah, maybe to add shortly, I think regarding this aspect, of course, it's emphasizing that the EU has to strengthen its energy independency. We're not only talking about an armed conflict, also the working with the United States at the moment. It's not clear how it evolves in the next years. So if they are going to put any more tariffs on anything, so it's going to be a huge challenge, and I think there nuclear is one of the key aspects.
Maybe I could also add, like from a digital technology platform, we talk about AI and digital twins, but maybe we have a heightened awareness on what it needs for cybersecurity. So that plays in. But I do think there are coming stronger avenues for the global cooperation via groups like NEA and IAEA. We've had stronger MOUs and cooperation with Department of Energy in waste management to say we shouldn't be doing the same things on both sides of the pond. So I think the communication and realizing we do need to stick together to have this innovation, not just in Europe, but with key players who have sometimes a lot more investment in if that's fuel research or other topics, for instance, in the US right now. Then there's the benefits to that also that drive us to cooperate from an R&D perspective and try to align our research programs to not repeat things that our friends are doing or be better friends.
Okay, I think we have, it's coffee time. There is one final question that I can answer. They were asking for the presentations that were made at the beginning. They are already available in the app and the website. I have just seen them, so you can access them and download it. So thank you very much for this discussion. It's been really a pleasure. And thank you very much for the public and for your question. So see you later. Thank you.
Thank you.
Is it music? Style. Is it music? No matter what kind of style it is, it's music.
to river. City life reflects on me. Walking through the record store, talking to my friends now. I can see your face, baby. Standing here watching you, watching you, watching me.
Allô?
1.5 to 2 hours. 4 minutes. It actually, you can go there, but I don't think it's necessary. So
Hello, I'm Sawar Sawi.
normally, I think it's in the community.
Hi, Sawar Sawi.
But it's up to you.
From
I don't think it's...
Harry.
Why do I have it on mic? It's not...
Hello. Hello. Hi, how are you?
It's me, yeah. Usually it's me.
Yeah, material. I don't know what I'm doing here because I'm not materialist at all.
Yeah, but you're still... Okay, fine. You're still dealing with LTUs, so there are some material...
I have some text I try to say something.
So I think we're already prepared.
Okay. Oh, sorry.
You've actually said it according
You also have a text what you would like to say?
Oh, yes. I need it.
I know more.
No, it's okay. We all have our own mic? Okay, that's true.
You can let Lorenzo speak and
Yeah, you're right.
we can have a relaxed 2 hours. He knows everything. I know. You know everything. But you can use yours.
Usually the same thing was like telling people outside to start.
He was in Usher.
That was our secret.
I'm going to ask.
I hope I have everything, but I don't know what I will be able to say.
You know the mics have a click here, so to on you should push it upwards, off downwards, and you should each have a mic, so there should be a passage.
Hello.
Everybody is so prepared. Lots of
I think 35 should start. Where they come, they come.
one thing that if I have a slide, and how they will change it? I have to change the next or
No, there should be a.
You mentioned some others also have it.
Yes, Veronique has the first. No, you have the first one, so you can keep it.
And who is the next? Who has that slide?
Veronique.
Ah,
That's it.
I see. So back and next. Okay, very easy.
Next back.
Okay. I guess it's a quite understandable. no one says of the public. These people in our
We will start.
Dear ladies and gentlemen, dear colleagues, good morning. We are going to start a session dedicated to the nuclear fuels and materials. It will start from a short presentation of people here on the stage. My name is Mykola Dziubiński. I am a project officer in the C4 Euratom unit of the Commission. Luckily, my background is in material science, so I'm really happy still to follow material science. I would like to start this session from the short observation. If you go outside to adjacent rooms and you check all the posters, you see that more than half of them, for sure, are dedicated to materials and fuel, which I think signifies importance of this subject for the nuclear technology. Also, I would like to remind you that I am representing the Commission, and Commission has a policy to follow. The very good source, the very good income for our policy also in this particular domain is input from the stakeholders, from you. And that's why this conference, where we will be very attentively listening to you. On the other hand, our policy should be aligned with the consensus opinion of all member states, so we do have our certain limits in that respect. So I pass the microphone to my colleague Pau to introduce himself.
Thank you, Mykola. Thank you to all the audience for being here. My name is Pau Aragon. I'm currently a researcher at the Joint Research Center in Karlsruhe from the European Commission. My background is fuel performance modeling. I obtained a PhD working at the Unit of Nuclear Safety Research at CIEMAT. And I'm also the chair of the Spanish Young Generation Network, Jóvenes Nucleares. So with any further ado, let's introduce our speakers today, which I'll welcome and thank them for taking the time to prepare the session and being here. We will start with Lorenzo Malerba, please.
Okay, I'm Lorenzo Malerba. I am, just to tell about myself, I am a nuclear engineer as a training with a major on materials, and I am probably the only one in my promotion who is still working on nuclear materials, because I graduated in Italy, Politecnico di Milano. Then I did a PhD in Spain at the Universidad Politecnica de Madrid. I worked for 18 years in Belgium at SKCN in the Nuclear Material Science Institute, group on structural materials. I had a unit dedicated to modeling and microstructure. And since 2014, I have been coordinating the joint program on nuclear materials of the European Energy Research Alliance. In 2018, I moved to CIEMAT as research professor, where I am still now, in the division of energy materials of the technology department. And at CIEMAT, I coordinated a project, M4F, which was on materials, cross-cutting between fission and fusion. And then the project called Orientenem, which was the preparatory phase for the Connectenem partnership, which started on the 1st of October 2024, which I coordinate as well, which is totally dedicated to nuclear materials. And in fact, in that respect, this panel discussion is very important for me and in general for the context, because Connectenem intends to promote a change of paradigm, as I will maybe have the occasion to say, in the field of, in the research on nuclear materials.
Okay, now please, Virginie Solans, introduce yourself.
Hello everyone, so my name is Virginie Solans. I am a nuclear engineer. I did my master at a joint master program of EPFL and ETH Zurich in Switzerland. And I have a PhD from Uppsala University, where I was working in collaboration with SKB on decay heat prediction. And right now I'm working at NAGRA as a specialist in radioactive materials, and I'm responsible of many high-level waste topics at NAGRA, coming from decay heat predictions, uncertainty evaluation, and also I am helping on criticality subjects. I am a deputy work package leader for the criticality safety, post-closure criticality safety work package 17 of EURAD2. At NAGRA, I'm also responsible of some optimization part, for instance, the canister loading optimization plan. I am a project manager and the main developer of this optimization tool. So I have some competence in machine learning and artificial intelligence, and I am part of the advisory board on AI at NAGRA. What I will be focusing on today is the waste management part, so looking at spent fuel disposal and long-term safety. And I think coming from Switzerland, we are going to have a very different discussions compared to other panelists, so it will be interesting to see. Also because we are restricted by some laws on what we can do, so looking forward to it.
Thank you very much, Virginie. Our next panelist to introduce himself will be Paul Schumanns, please.
Good afternoon, no, good morning. Yeah, I'm Paul Schumanns. I'm actually a nuclear physicist, a very fundamental one. Until 2001, I got a call from Hamid who said, hey, I have this interesting project called MIRA, why don't you join? And since then, I moved to SEKC, working on heavy liquid metal systems. First MIRA, later on the lead-cooled fast reactor project that we have. And my main focus is about sustainability of the nuclear energy, basically on how to recycle things and how to reuse and make efficient use of resources and clean up your own waste. My job at SEK is I'm working as a scientific advisor officially, which basically means that I'm involved in the R&D program, the R&D roadmap, in order to come to the realization of these machines. So I'm really focused on getting things built. And in the meantime, I'm also the coordinator of a number of European projects. I think Patricia, Anselmus, and Transparent are the three that are still running at the moment. Yeah, that's basically it.
Thank you, Paul. The next panelist is Sasha Sabot. Please introduce yourself.
Maybe I have some slides, so if you can open that. Well, I don't want to say so much about myself, because you can find my CV. But I'm Szabó Szávai, Sasha from Hungary. I can see some faces, we know each other from several years. So nowadays I'm a lead the technical division at Atomic Energy Engineering Ltd. In Hungary. Yeah, you can see. So I'm also here to delegate as SNETP secretary. And well, since you know that before I was working for another institution, since last year we joined to the Atomic Energy Engineering Ltd. With my colleagues. We spent 25 years in LTU and the structural integrity nuclear power plant, not only on national level, but in several EU projects, starting somewhere with ADEMU in the very beginning phase, early 2000, and since then we continued several projects through perfect performance, still long life, and continued to Entente, as you can see. So, well, yeah, so just saying that we continue this kind of work, what we started 25 years ago together in the Atomic Energy Atomic Engineering Ltd. So that is spin-off company of the Hungarian research network. This Center of Energy Research Center is the owner. We are a spin-off company. Maybe it's a wide, you know that this company is a widely recognized institution of European nuclear research community, but maybe you know that this is a IAKI, MTAKI, whatever. So it's a Hungarian Research Center for Atomic Research. And we, as a spin-off company, we have a strong partnership with the Hungarian players like MV and PAX, or we're also working for the PAX-2 project as well, but not only for nuclear sectors, but also for energy, petrochemical industry, and other industry where the pressure vessels appears and the material is important, and well, the long-term operation is an issue. So our main focus and my focus, what with my colleague we developed is really concern this kind of field. But first I would like to mention that in our company we have three divisions. That one is the nuclear division, mainly focus on reactor physics, time, hydrogen, fuel behavior, fusion, and reactor simulation, and so on, the monitoring system. Also, we have a general engineering division dealing with rather civil engineering issues, large project infrastructure, and our division, the technical division, is very focused on now on the nuclear LTO issues, such as integrity and reliability of critical infrastructure, applying the state-of-art engineering tools like AI, the digital reality to enhance safety and performance in practice. So the case service and my background is rather LTU and structure integrity behind with some advanced NDT technique and developing a predictive maintenance and the monitoring system. And nowadays we focus on incorporating with digital reality application. So in my case, and not only my case, but I was talking about my colleagues as well and my team, we always focus on the material issues. And since I'm representing now this engineering SME or spin-off company and SNETP secretary, so this kind of dual perspective for me is saying that the total today topic is our main pillar. And well, while I'm not really dealing with the new fuels and really new materials, but we think that the long-term operation is just kind of existing database and existing research and help us to understand how to continue the nuclear material development. And well, let me say that the knowledge what we create in the project, as I mentioned before, the early century, that help us to understand the material degradation and help us to form in the future reactor design. And we would like to also turn to the SMR development, and where this kind of design philosophy can be taken into consideration. Just I would like to mention shortly that such kind of project like Entente, Lorenzo, you know, it's quite well generated, created a European database and integrated a kind of AI support analysis. And this kind of database based on existing data from reactor pressure vessels and available data sources. And this is essentially supports the future development. So, well, we can say that the truly effective strategy for innovation in this field, I believe, at least, must be a comprehensive integrating the invaluable experience from the operating reactors with the looking forward development of new materials and fuel concepts. Thank you.
Thank you very much, Sasha. Now let's move to Véronique Reverol, who has also prepared a presentation. Okay.
So good morning, ladies and gentlemen, and thank you for the invitation for this panel session. Yes, I do have a presentation, a short one. So about a few words about my background. I spent basically half of my career on research, especially on zirconium-based alloys for the cladding and for structure materials of the fuel assembly. I entered into Framatome and started on this topic. I was a component research center manager, so we have a research center in Eugene, in France. I started there in 2005, and then I decided to change. I accepted a position in 2012 as a manager of the project, I would say. And at that time, I became the product line manager for materials. I was involved in monitoring several developments on MOX fuel, for instance, and it was the beginning of enhanced accident-tolerant fuel development that we made with CA, so it was quite interesting. And finally, now I am the Fuel Business Unit Research and Development Manager on fuel for the Fuel Business Unit of Framatome. So I have changed from research to rather driving research and development programs, taking into account our customer needs in terms of reliability, performance, and of course safety. And I am in charge of analyzing the trends for the future, especially for advanced modular reactors. So just a few words about our research areas in Framatome on fuel. As I said, we are focused on utility needs and innovation. So the first area, so this is just an illustration, a summary, a short summary. So the first area is related to advanced fuel products. So we have products already qualified, like Kaya for PWR or Atrium 11 for BWR, on which we are still working. And at the same time, we are developing VVR fuel to ensure resilience for the Eastern Europe nuclear power plants. And we have the support of European community for that with the SAVE project. We are progressing quickly. So the second area I would like to mention is enhanced accident-tolerant fuel. So Framatome solution, the name is Protect Chromium. It's an evolutionary solution. And we are on the way to deliver the first batch in Europe for this accident-tolerant fuel. A key area which is linked to the topic today is how do we optimize the fuel management. So here we have a big project in US where we are working on enrichment increase beyond 5% for the current fleet. And also this needs to achieve high burn-up. So this is a very interesting project where we are able to optimize the fuel cycle cost. But we are working also in France on MOX fuel and based on EDF requests to optimize the fuel management. So, and now more and more we are working on innovation and cutting-edge technologies like additive manufacturing or AI for fuel management. We have created a kind of digital innovation factory where we collect all the ideas, and the name is Free to Innovate. And the last part I wanted to emphasize is the fuel for advanced reactors. So you see here a nice picture of a TRISO fuel. We are working on fuel for fast reactors on the design side and also manufacturing capabilities. So this is just an illustration of what we have created to work on advanced fuel for advanced modular reactors. And this is what we call the Advanced Fuel Technology Hub. In blue, you can see the design engineering units that we have in US and in Europe. And in orange, reserve our capabilities. So in US, Richland would be the center of excellence for manufacturing the fuel. And in Europe, which is the focus for today, we have several labs and plants, manufacturing plants, in order to be able to manufacture such fuel in the future. Okay. So just to open the discussion on the perspective for Framatome regarding innovation on fuel cycles and advanced materials, I would say, and I think that you are all convinced in the room here, that to the question, do we still need innovation in that domain? The answer would be definitively yes.
Okay, thank you very much, Veronique. I'm going to introduce another panelist, Hugh Interland, please.
Thank you, and good morning. Thank you very much for the opportunity to speak to this great conference. I'm Hugues Interlang, I'm in charge of the EU Public Affairs, and I'm based for Orano, and I'm based in Brussels. So even if I have not a scientific background, I am more than happy to speak about innovation, because we love innovation at Orano. So thanks really to the European Commission for organizing this great conference. Because our topic of today is of great importance. In the current context of abundance of new projects in nuclear sector, it's really essential to remember that the deployment of new reactor technologies cannot be separated from the question of fuel cycle, and I think that a lot of panelists have highlighted this fact also today and yesterday. Because the fuel cycle is really a key pillar of any new nuclear project. Because without secure access to materials and without advanced fuel solutions, the full potential of next generation reactors cannot be realized. So, as you know, Orano is a European industrial leader with a unique position in the nuclear landscape. We are the only EU-based company that masters all the stages of the nuclear fuel cycle, from uranium mining to recycling of used fuel. And this expertise makes us a partner for those working to bring forward the next wave of new nuclear technologies, for sure. So we do not design reactors ourselves. Our focus is exclusively on the fuel cycle, but it is precisely this specialization that allows us to bring deep industrial insight and also practical solutions to developers of innovative reactors, especially those pursuing advanced fuels. So we already actively cooperate with the main small modular reactors program in France and internationally. And we are fully committed to supporting the broad ecosystem of emerging designs, because I think that a robust nuclear future needs a diversity of solutions. And this is also why we are actively involved in the European SMR Industrial Alliance. And we hope that the work carried out by this initiative will help the European Commission to identify the needs and key actions required to support the safe but also quick deployment of SMRs and AMRs in the EU. As we are a major player in the closed fuel cycle, we pay particular attention to reactor concepts that are compatible with recycling strategies, because we consider plutonium not as a waste but as a valuable resource. Just 1 gram of plutonium contains the same energy as 100 grams of enriched uranium or 1 ton of oil, so this is really important. And that is why we closely follow and we support the emergence of fast spectrum AMRs, which can use MOX or plutonium-based salt fuels. And these reactors can, I think, significantly enhance circularity in nuclear energy. It can reduce dependence on natural uranium and help us to move toward a more sustainable model. Among these designs, those capable of approaching ISO generation or even breeding of fissile material offer particularly interesting prospects, especially in terms of long-term resource optimization and alignment with France's strategy for closing the fuel cycle, as it was said yesterday. Orano is also preparing for the future of its own industrial facility, because we have several forward-looking projects under development to ensure that we can support the production of next-generation fuels and also adapt our infrastructure to meet the evolving needs of reactor developers. So in this context, I'd like to highlight the crucial role of research in transforming promising ideas into industrial realities. And at the EU level, the Euratom program plays, I think, a key role. And we are really proud to coordinate several Euratom-funded projects, including, for example, the Mimosa project, which aims to demonstrate multi-recycling strategies using molten salt reactors. So if I may, I would suggest, and I see very important people from the European Commission in the room, I would suggest that the Euratom program should increasingly focus on aspects on the fuel cycle and should have a more important budget. So I speak to the European Commission, but also to member states, so that we can have more budget in this Euratom research program on fission issues. So in summary, we are really committed at Orano to being a trusted partner for all stakeholders in this new nuclear landscape. And we bring our industrial experience and a global perspective, a strong belief in innovation. So we are really ready to build solutions for new reactors. Thank you.
Thank you, Hugh. I would like also to introduce Guillaume Tremblay from Westinghouse. He is a rapporteur of this session, and he will prepare a report as a result of this session. Now we will move to the general discussion. Paul, please.
Yes, so the idea here is that we have prepared a few questions that we will ask to our panelists, and they will have some time to address them. I would also like to mention that all the audience, please, you are very much encouraged to ask questions throughout this discussion in the chat that is embedded in the app, the particular chat of this session. So please go ahead at any time and post your questions, and we will read them at the end of the discussion. Okay? If you don't want to use the app, you can also raise your hand in the end, and we will also give you a mic. So let's move to the questions. First of all, to start this, break the ice, we will ask a very generic question to warm up. So different strategies coexist when it comes to innovative fuel cycles or materials. Some are being more driven by an incremental progress, where others are seeking for game changers. What main steps, whether they are related to technology, safety, regulation, or society, do you believe the sector should take to implement and foster innovation for fuel and material strategies? And now the floor is yours. Whoever wants to take the lead. Lorenzo?
Yeah, I can start. So, of course, I bring the point of view of a researcher and of research projects, but of the two possibilities that you mentioned, I definitely prefer the second one. I think that probably the main step that we need to take in the field of nuclear materials research is to try to change our mindset and the way of doing research. And this is what we are pushing for in Connect-NM, and it is based on the idea of a change of paradigm, which we summarize in the expression that we move from observe and qualify to design and control. Now, this was proposed now quite a few years ago, maybe 8 years ago, by Joe Somers and Marjorie Bertolus. And in fact, it preconized what is now, let's say, the official philosophy, also pushed for, promoted by the European Commission, in the field of materials, whichever the application, not definitely nuclear, which is safe and sustainable by design. There are documents that you can find on the website issued by the Commission on this topic. What does it mean, safe and sustainable by design? It means that the idea is really not just to take materials and incrementally improve them based on experience, but really to take the other point of view, to design the material from the beginning, to be able to basically have the best possible properties for the application that we have in mind. So it's a sort of Copernican revolution. And this is made possible today by the fact that we have digital technologies that maybe didn't exist or were not equally widespread 10 or 15 years ago. So this is happening outside the nuclear field. And in the case of nuclear, of course, we would like to bring the same idea. We think we have to bring the same idea. It is a tremendously challenging point of view because it requires really taking a different perspective, and it's not simple to design a material for the application that we have in mind. And in nuclear, it is probably even more challenging somehow because there are at least three reasons. First of all, in this expression, safe and sustainable by design, when this is applied outside the nuclear field, the word safe mainly refers to the fact that the material has to be safe and sustainable in the sense that you take into account all the whole life cycle from mining to disposal, or actually better recycling or reuse. But safe means don't use dangerous chemicals or things like this. But in the case of nuclear, that safe mainly means the component that you build with that material has to be safe, or the installation and so on. So this is the first challenge. It's different from the other fields. Second point, we have irradiation. Irradiation is a specificity of the nuclear field, and it is a very difficult, let's say, degradation mode to tackle with respect to others because we need specific infrastructures, as you know, and they are not enough right now. And there is a third and extremely important point, is that obviously we cannot think in the nuclear field of changing our way of developing and qualifying materials without involving from the very beginning the regulators, the standardization bodies, because otherwise we can do whatever we wish, but if we don't have an interaction with the standardization bodies need to be able to tell us, yes, what you are doing is actually going to produce data that can be used for the design rules and so on. And the regulator, of course, has to know about these approaches, and eventually we have to license a hypothetical reactor in which materials developed in this way are used, and, well, it has to be, let's say, receive the stamp also of the regulator. So I think there will be occasions to delve more into this point of view later.
Thank you, Lorenzo. Who wants to add? Okay, Virginie and then Paul.
Okay, thank you. So I'm going to focus on the second part of the question. You focused more on the first part about what are the main steps that we need to take. So is it technological safety or regulation? Technological regulation or societal. And if I take the case of Switzerland, so right now we have a ban on the constructions of nuclear power plants. It's following the Fukushima Daiichi accident from 2011, and this ban was made in 2017. Since then, the electricity market has significantly changed, and right now the Swiss government is thinking of lifting this ban. This is just a discussion, so it's not done yet. And it's also the part of this Swiss initiative that we would like to have carbon neutrality by 2050, and to my opinion, we cannot achieve it without nuclear. So there is definitely a high a part that is for us is regulation. Because we are just at the beginning of this discussion of should we lift this ban, there's of course not yet discussions about innovative fuel cycles or which technology we might want to use if we were to build a new nuclear power plant. So for me the main point is regulation, but also societal one, because Switzerland is a direct democracy, so to make this kind of changes we need to have a public referendum So societal acceptance is key, and it goes hand in hand with regulation. And how can we overcome it? We need to, as a nuclear industry as a whole, we have to say that we are ready and we can do it. And it goes, of course, also with waste management, and for every innovation or things we want to change, we need to see that we are ready and we can do it, and it goes back and then long-term safety.
Thank you very much. Now, Paul, if you want to add something.
Yeah, I'm going to throw a wrench in the system, because I don't agree with Lorenzo, basically, that as usual, it depends on what you want. If you want to build a machine, one step back. If you want to build a machine, you need to get a license. If you want to get a license, you need to have a demonstration. You cannot build a machine without qualification. I think there we basically agree. So if you want to work towards deploying new reactors by 2040, 2050, and so on, the route of trying to start from scratch is just too slow. I agree with you that if we do small steps of the same thing, then okay, we might miss very fundamental improvements. So I honestly think that we should do both, in the sense that if you really want to go into completely new directions, yes, you need to basically doing the design of your materials, using computer codes and using modeling and so on. This will save you quite a lot of what we call screening tests, and this can improve the speed of your development quite significantly. But eventually, down the line, you still have to qualify the materials, and we can discuss with the regulators and so on. We can discuss with the construction code makers. Again, the bottom line of the story is qualification. So I think that is, from a research point of view, we are standing on two legs, basically. And for the second part, yes, the regulation is important, but maybe it's a dangerous topic to touch. Safety rules are important. Another thing that we should dare to discuss is there are a number of rules that are implemented, but we never discuss the rules. We never think of why is this rule as it is. We have examples like limits for radiological release, which has a number. Why is the number like that? And it turns out that, for example, at the boundary of your facility, the limits is the equivalent of a person staying there right on the boundary for a month and breathing deeply. Does that make sense? So that, I think, is also an important question that we need to dare to address, in my humble opinion.
I'm very happy to see some actual discussion here in the panelists. So maybe if Sasha or Veronique or Hughes have something to add?
Yeah, so however, actually, almost I can join you. So almost everything was taught. Because, well, it's a really interesting question. First, you asked that whether we believe that the sector should implement innovation in such issues. So yes, and we can finish it here. So I guess we all believe that that's why we are here. However, we had a parallel session yesterday when we learned from Westinghouse, from Lou, that innovation could be a risky issue, that we have to be careful if we have innovation not to increase the risk on the existing designs and so on. However, let me say, and it was very true that Lorenzo told that such kind of step from the traditional methodologies to the design philosophy is essentially needed. But I also have to say that the innovation in nuclear materials and fuels indeed requires a multi-dimensional approach. When if we would like to have a game-changing technologies, we must continue the innovation and in understanding of managing of current asset, because that's we have as a basis of our knowledge. So it's not just what we do in LTO and the long-term operation and such kind of fields. It's not just the maintenance and just would like to extend the lifetime for what, because if you would like to extend the lifetime, always you face something new, because you never had the operating lifetime for 80 years. So that's always a new thing for us. So it's active research that can be utilized. So well, whether it's an incremental step or a design could be a questionable issue. But what we have, this enhancing our predictive capacity for material degradation through advanced multi-scale modeling and robust data is needed. So that's why I like what was carried out in the Euratom in the last 2 or 3 decades in the project, continuing this kind of development, as I mentioned, starting from Perform 60, before long line, Soteria, Entente. That always was an incremental step, I guess, and finally the Entente developed the radiation damage database integrating AI issues. And also we had several projects when the regulatory was involved, and we had a step for the regulation and the harmonization of the codes and standard. Like we can talk about the fructases when we recognized if we would like to have a long-term operation, we need new data, and what we, because of the surveillance was designed only for 30 years in the beginning, so we run out the data, what we, material that we can take into consideration, the small-scale specimens are vital. So, so I guess it's not a contradiction between the incremental and qualification issues that, so this is a basic. And, this makes the basis for the next step, and I believe that innovation is what we would like to do. Yeah, well, and that's why I guess this kind of activity, what is run under the SNETP umbrella, and in this project portfolio, especially in Eugenia pillar, that essentially needed for the next steps and for the turn to the design phase and design of the materials, and we have to understand the aging mechanism even deeper. We should even verify model that is needed for the next step. So it's incremental and also game changer. Just you mentioned also the social and collaborative issues. Well, we can say just that we have to strengthen, but I also would like to mention that when we would like to have a next step and design phase and so on, it was not mentioned that before, I guess, that we also have a critical issue that we have to invest the knowledge transfer and training as well, because we had some unfortunate, sad issue when we lost someone during, for instance, COVID colleagues, and we lost very valuable knowledge. So then that's why we have, if we would like to have a next generation fuel, next generation materials, we have to keep reserved our knowledge, and we have to focus on the young generation as development as well. So I guess, I can say the innovation requires a holistic strategy, and this incremental advancement is on current feet, pave the way for the integrated, game-changing future technologies. So that's what I can add to this point.
So I would not disagree with my two neighbors regarding the fact that it would be great to design new materials with new tools, and at the same time we need test and qualification. I don't think that they fully disagree. On my side, I have selected 2 steps, one short term, one longer term. In fact, you can have different strategies. This was mentioned yesterday regarding fuel. Either electrification of usage, if you want to increase your production, decarbonization, energy mix with renewables, availability of the materials, enriched uranium or plutonium, and finally choice between reprocessing or long-term disposal. And depending on these strategies, the steps might be different, but in any case, fuel has to support all these strategies. So it's not easy to define the main steps. I have selected two, as I said. So on the short term, we have long-term operation of existing fleet and new builds in Europe, and it's a priority. And we are always targeting higher fuel performance and at the same time improvements in safety. So we know that the evolutionary solutions enhance accident-tolerant fuel with a chromium coating cladding and potentially chromium.UO2 fuel will bring some additional safety margins in a loss of coolant accident. This is fully demonstrated, and we have also irradiation experience in several reactors. Among some of them, we have reached 60 gigawatt day per ton of uranium. So we are now ready to deploy this solution. Euratom was supportive of that, thanks to the taxonomy. And now I don't believe that we need so much research. What we need to do is really to have more dialogue, maybe between safety bodies, utilities, and fuel suppliers to achieve the deployment. So this is for the short term, and this is an incremental change. For the longer term, of course, the game changer is related to the manufacturing of these different fuel types and the diversity of these fuel types for advanced modular reactors. For a small modular reactor like water reactors, it's not so difficult because the fuel is of the same type as the current one. For PWRs, it's shorter, but just shorter, I would say. But for advanced modular reactor, it's really different. And here we have really a challenge to be able to supply the fuel. So it's not only a question of core design, but if you don't have the fuel to put inside, then you can do nothing. And here we are not really organized in Europe to achieve such supply today. So I think we have two different questions. One is related to do we want to develop high temperature reactors, and then we will need triso fuel with potentially HALEU, or rather go to fast reactors, especially sodium fast reactors. And in this case, we need to be able to have the plutonium oxide fuel coming from Orano, maybe.
Yeah, the floor is yours, Orano.
Thank you. But I think I agree with my colleagues. I think it's important to support all the strategies that can drive innovation in the fuel cycle. But I think it's also important to be realistic and to have an industrially grounded approach. This is important, and that's why at Orano we have a long-term strategy which focuses on the extension and the renewal of our key infrastructure of LAG in the north of France for recycling and manufacturing of MOX fuels later, while developing multi-recycling capabilities for light water reactors. I think this will improve circularity, reduce, as I said, reliance on natural uranium, and also prepare the path toward the full fuel cycle closure with fast reactors. So we have some steps to this full closure of the fuel cycle, and those steps are important. And for us, there are a lot of conditions to bring on new capacity to implement innovative fuel cycle strategies. Those conditions are, for example, real demand, a clear regulatory framework, market conditions, long-term contracts, financing, incentives, and skills, of course, competencies. So all these conditions must be met to de-risk our investment projects and continue to ensure the continuity of the supply. It provides to the industry in the supply chain.
Thank you, Hugh. Thank you to all the panelists to take part in discussion on this general question. Now we'll be moving to more specific question. And the question I would like to ask all the panelists, it's about advanced fuel. Advanced fuels like HALEU, MOX, and ATF are central to present and future reactor concepts and fuel cycle strategies. In your area of expertise, which are the most promising fuel innovations to enable closed fuel cycle and enhance reactor safety, and what technical or supply chain hurdles must still be overcome in that respect? Thank you. So I think Veronique or Paul. Veronique?
I can start if you want. I think I mentioned already the main aspects of innovation. I see, at least. So the first one is really enhanced accident tolerant fuel. It's an evolutionary solution right now. It's incremental innovation, but very useful. And we have, for the longer term, some breakthrough innovations in the cladding material or even in fuel, such as new types of fuel, dense fuel, in order to be used either in current fleet or in advanced modular reactors. So right now, enhanced accident tolerant fuel is ready, but in an evolutionary solution, and we have in the pipe longer term innovations.
Okay, thank you. Paul, would you like to add?
Yeah, as usual, it depends on what you want. I mean, we are discussing about sustainable nuclear energy, and if you look through what we are doing right now, there's basically for every ton of heavy metal we dig up from the mines, we use 1%, and the rest we throw in the bin, which is called deep geological disposal. And that's not sustainable, that's not an efficient use. So you have to increase this percentage. And if you want to increase this percentage, that means that somewhere you have to go around plutonium, because basically the uranium-238, if you want to split it, if you want to take energy out of it, it will be plutonium somewhere down the line. Which means that in order to increase this efficiency and also, open brackets, clean up your own waste, close brackets, you also have to go through this path. And you have to go fast, which means that for the sustainability story of the entire action, you have to go through plutonium, but we also have to be very much aware that taking plutonium and then doing it once through is also not good enough. Because, okay, you can gain a bit, but you do not gain enough. And that's why it's very important to also include the plutonium fuel from fast reactors into this multiple recycling path. And okay, you will produce minor actinides as well. And yeah, as a transportation guy, this I think is also an important thing to be addressed. This, okay, it is a small matter in terms of absolute mass. It's a kilogram, something like that, per ton, or even less. So that is not very big, but it is an important load on your geological disposal. So that is also something that you have to take into account into your multiple recycling path. And then on the other hand, we have to be very much aware that if we are trying to develop new reactor types, like, for example, high temperature gas, all very nice, all very good, but we also have to be aware that the more stable we make the fuel against high temperatures, the more difficult it is going to recycle the same fuel. So you can't have it all. You cannot have a very high temperature resistant cladding, the TSO layers, and at the same time have something that is easy to recycle. So this is something that we have to be aware of, and we have to make sure that the choices we make take the entire cycle or the entire idea into account. So we need a holistic, it's a buzzword, we need a holistic approach for this. We need to look from the beginning until the end, and also in relation to the other sources, because basically we try to make electricity and other uses, of course, of the heat, but also other players try to do the same thing. And we have to make sure that this integral story works out.
Thank you very much, Veronique and Paul, for the nice and detailed answers. Now we will move to another subtopic of this session, which are structural materials. So I will address the question particularly to Lorenzo and Sasha, but feel free to intervene if someone else wants to. So the question is related to materials are often among the key bottlenecks for next generation reactors. This is especially true for lead-fast reactors and molten salt reactors, which are the focus of several European startups. However, even for light water SMRs, material challenges persist, particularly in relation to the advanced manufacturing techniques required for modular, which is supposed to be faster or cheaper construction. So in this context, and here comes the question, and in an era marked by the efforts to extend the lifetimes of existing reactors, how should we reframe the role of materials R&D?
Yeah, so I would like to restart a little bit the conversation, because in fact what you said is in the question is very important. There are still lingering issues on materials despite so many years of projects. And this is why we need to try to take a different approach. And I would like to clarify one point that maybe was not clear. I never ever said that materials do not need qualification, not at all. But what materials need is more intelligent qualification. This, yes. Which means we need to try a better and more intelligent way of doing things along the whole materials life cycle. So materials are developed, or perhaps not developed as totally new, but improved from what exists. Then they are qualified for a certain type of use, and then they are used eventually in the reactor. And eventually they are disposed of, or perhaps recycled if this is possible. So we have to look at the whole cycle in a more intelligent way by using techniques that, as I said, these so-called digital techniques, everyone thinks of artificial intelligence, but it is not the only one. There are other ones that are equally important: high-performance computing, semantic technologies, which are used for knowledge and data. So there are plentiful techniques of this type that we can now use to make things in a better way. So each of these steps is extremely important, fundamental, crucial. Qualification is absolutely necessary, but we can do it in a faster and smarter way. The development of materials should not be simply, okay, let's do a few trials, and by trial and error we get a slightly better material. No, let's make it in a systematic way. Let's adopt strategies that allow us a fast screening of several possibilities using, as I said, all high throughput fabrication, new fabrication methods, high throughput characterization, high throughput calculation. For this we need suitable techniques and also infrastructures in such a way that we can maybe not fully design, but at least identify the best material for as much as we can do at that stage for our application, or a set of material, which is better than what in the past was done. We take 2 or 3 possible grades and we see how they behave. Second step, qualification. Qualification has to be done, of course, together with standardization bodies, because they tell us, okay, if you want the material to be codified, you have to fulfill a number of conditions. Okay, let's talk to them and see if we can get to the same point in a faster way. So these are the so-called accelerated qualification path. And let's also make sure that we have the infrastructures to follow that path. These are called test beds. It's a little bit abused or misused expression, but basically it means if we want to follow an accelerated qualification path, we need to make sure we are actually able to do that, so we need infrastructure for that, or a group of infrastructures. Third step, the material is finally used. The story is not finished. We need to monitor what the material is doing, but not only monitor it because we want, and of course this is the key issue, we want the component to be safe, we want to make sure the component is behaving, let's say, correctly. But let's use the data that we get from there and put them back into the loop, because we can further improve the material. Maybe not immediately, but later. So this is the idea of this holistic approach that tries to make use of technologies that were not available until not so long ago, to make things better, which doesn't mean we throw away what we have done until now. Sasha mentioned a chain of projects, Perfect, Perform 60, Long Life, Soteria, and Tente. I was involved in all of them, absolutely all of them. I know perfectly what was done there, and a lot of things were done. But altogether, these projects took about 20 years. Can we be fully happy about what we achieved? We have to think about it. So I think we need at least to try to move into a different way of doing things. It is an asymptote. We are not going to get there overnight. It's difficult, extremely difficult. But if we do not take the initiative of doing that, I don't think we are going to be able to bring innovation in the time frame that we are setting for ourselves, because we are talking about not only small modular reactors, light water technology, which are already a challenge, also from the materials point of view, new fabrication methodologies and so on. But if we talk about advanced material, to go in the direction of the fast reactors, we need materials that we don't have yet, in fact, or we have up to a certain extent. And when we talk about startups, but I think that this is also true for bigger industries, we are talking about a very short time frame, because startups cannot survive for 20 years. If they need to deliver. So if we want to at least try, success is never guaranteed, but at least try to make it in this short amount of time, we do need to try to change our approach, our mindset, which again is not, let's throw away all we did before, not at all, let's build on it. In fact, Entente was the very first attempt of doing this, because the idea was to use semantic technologies, or to try to use them, in order to organize the data on a case, which are RPVSTs, which is well known. There are a lot of data around the world. So it was an easy case, and still, even though it was an easy case, it was not easy to get, to having a database the way we thought. So we need really to make an effort, all of us, the researchers community. I'm talking for that community, but I think that this is of interest also for the industry. And I can cite, in ConnectNM, we are in the process of selecting projects. I don't have yet, and I cannot foresee the final situation. But I have some statistics about those who are proposing. And when I look at who is proposing in ConnectNM, of course, almost 70% are resource centers, universities. That's normal. But the other 30-something% are regulators, TSOs, private companies, industries. So it means, let's say 1/3 to 1/3, but 1/3 is interested in this approach. And I think it is interested for obvious reasons. As I said, we have a short time frame, so we need to try to make use of ideas and technologies that, I insist, outside this world are being used. So in the nanomaterials world, in the materials for batteries, and other energy applications, people are using these approaches, so why shouldn't we? Of course, our case is maybe more difficult. If you listen to them, it is always there, is more difficult than ours, but it doesn't matter. it is always difficult, but let's move in that direction. Let's try at least.
Thank you so much. Then, Sasha, how does all of this apply to the long-term operation? What do you think?
So always. Actually, Lorenzo told everything, so and I fully agree with him. So I guess we have no any contradiction between us. So and I also believe what he told. So coming from another point, that what was the end of his talk, that concerned the startups issues, and well, I guess if you talk about well, not only, of course, the fuel is the same issue, but the material also is not, let me say, a stand-up show or something like that. This is not only a one-man activity. So if you talk about startups, they should come from somewhere. So, well, I guess what we can see in field of materials, they are not really startups, but spin-off of huge companies or something like that sometimes. In case of new technologies like digitization, we have startups that can serve our activity in material development, new materials issues. But of course, we have to support SMEs and the spin-off companies and small enterprises to be a player in this playground, and that's why I just like to mention that platforms like SNETP and such kind of collaborative project like ConnectNM or led by Lorenzo are fundamental issue for pooling the expertise, sharpening the infrastructure, and sometimes avoiding duplication. So in SNETP, we have the offer project for this case. So if you talk about startups, the startups is somehow supported within this kind of activities of the SNETP to have access for large infrastructure, to have some kind of additional value and results. So, well, indeed, the materials offer a bottleneck of the next generation reactors, it's true, but not only for that, not only for the advanced system, but also for long-term operation as well. So that's why I'm always saying this is what we carry out in our existing fleet materials. So the research, for the research and for our long-term operation project for the next generation, we need a clear strategic focus. That was also emphasized by Lorenzo in the previously, that we always have to see what is the benefit of the research and what is the next step. So when I'm talking about incremental things, that I'm also talking about the incremental things that is not just try and error or something like that. We also have to say why we do it. So the design should be also in the philosophy concept that we have to see. So I think that the connecting and portion rightly emphasize the shift from observe and qualified to design and controls for new material perspective. And it should be based on extensive L2 experience. And these two approach not contradictory, but deeply synergic, I guess. And I guess this is what Lorenzo told as well. So we're just saying the always say. And the L2 is what I'm working for. Is not just keeping old plan running. This is a dynamic R&D field, generates data, operational experience, material behavior under real long-term and complex conditions. So that's the source where we know the aging effect caused by irradiation, thermal fatigue, corrosion, and other loads. And that's why this kind of project series was mentioned actually, and rightly emphasized by Lorenzo. This we always well, sometimes we are not satisfied with the result of a project because it's a very hard and risky issue. That when we have a proposal, we have a dream always, what we would like to achieve. And when we try to achieve it, we face the difficulties. And sometimes we can make only one step, incremental step, and in few times they can have a game-changing result. So, but what the LTO can offer for the new generation materials and so on, we can say we have at least 4 issues that the LTO is very important for us. One is the validation of advanced material. So predictive tools, what we develop is not just we develop in the traditional project, let me say, previously carried out in the project series from Perform and so on up to Entente. But we develop from microstructure level, meso level, micro level, and I guess all of us would like to have a validated model on industrial level and part level, so component level. And the LTO programs gives some kind of possibility for validation and also for benchmarking the new materials and comparing the new materials with the previous one. Always have to think what is the benefit of a new material. Also, the accelerated qualification is very important if you would like to carry out. So we have to develop methodologies to determine the material properties. We have to understand how can we rapidly, even short time, to develop the material properties that we can use. Environmental, I think INSAFA series carried out significant practices and subsize specimen. Because in case of when we mention the subsize specimen, this means that we turn not only from lack of material issue, but the traditional Sharpie energy-based philosophy to the fracture toughness master curve approach. So it's also it's kind of a different approach. And also the L2 improves some kind of innovation concerning the additive manufacturing as well. So we have the Nucoban project, for instance, when the additive manufacture part was qualified and discussed, and the additive manufacturing is to understand the material and the components developed and the product manufactured by additive manufacturing. We have to know how it is behave, because in this case we can apply it for SMRs, and this is very important issue if you would like to have SMRs to use such kind of technologies instead of a large, huge manufacturing infrastructure that is sometimes is not available nowadays. So I guess, I guess we are on the same platform when we can say that material R&D should be seen as a continuum, and the observer qualification validation model gives the know-how and allow the design and the control to success developing material next generation reactors. And the deep understanding of the margin of LTO serve not only for observed qualification, not only for maintaining legacy, but also for the new generation. And what we carried out in this project series under umbrella SNETP, New Genia period before, our project I would like to mention, the Strumat LTO or the DERISA LTO has some kind of vital role, because the result can be back into this kind of R&D cycle, what also mentioned. So, so it's like I said, we don't have to choose one paradigm between this observed qualification design, but we have to work together, and this kind of synergy could have a significant benefit for the next generation. Thank you.
I would like to make a very small comment on your answers. That I think we have to make a clear distinction between existing materials and trying to expand their applicability and the new materials. And I think you have to be very clear that if you want to aim for short-term deployment, we have to go with the existing stuff. And that's, for example, why in the heavy liquid metal reactors we are taking the Phoenix material, the 14970 or whatever it is, and try to expand. And these are I mean, this is essentially different from trying to develop a new material or new, for example, additive manufacturing. It's all very nice, but this is an improvement of existing construction. It is not a new way, I mean, it's a new way of making things, and therefore becomes a new material that needs to be qualified, etc., because the entire chain is changed, no problem. But it does not change, it improves things, but it does not change the fundamental use of these materials. And I think there we have to be very much aware. And again, I mean, as Laurence had put it, the bottom line is testing this stuff, and the bottom line of the testing is the irradiation. Somewhere down the line, this thing has to go into a reactor and see the neutron dose in relevant circumstances. I think this is, I mean, for me, the bottom line of the materials research.
If I may add just a very small thing, you are right, these are two different things, but at the end of the day, the methodologies, if you want to follow the whole path at a faster pace, are the same. In both cases, right? So, and you, let's say, of course, the new prototypes, whatever, they can only be built, licensed, and then built with existing material because we have data about them. But it is highly desirable that as fast as possible we can move to more performant materials.
At least there we agree.
Yeah, I agree.
So it's really interesting to see the real discussion here among the panelists. Thank you very much, Paul, Lorenzo, and Sasha. We will move now to our third topic. It's on spent fuel. And the question is, spent fuel management is a major challenge for long-term sustainability. From your perspective, what technological or strategic advances, whether in long-term storage, transmutation, or waste from development, show the most potential to reduce environmental and radiological burdens? And we should start discussion. I would suggest perhaps Virginie, what's your opinion from long-term storage and direct disposal perspective?
Yes, so I think the question is maybe a little bit tricky because it will strongly depend on the country answering it and what is the waste management strategy if you have open cycle, closed cycle, so it will strongly change the way you're answering the question. And especially so in Switzerland, reprocessing is not allowed. That being said, you're starting the question with spent fuel management is a major challenge for long-term sustainability. We could argue that it's maybe not really the case because if we look at Finland or Sweden, they are already starting the constructions of the geological repository. So they have some solutions, they have a plan that has been accepted by the public and the regulator. So they are already doing it. And in the same way, NAGRA, with the general license application that we submitted last November to our regulator, we are also proposing a solution for long-term disposal of spent fuel. So what might be the challenge now, it's more to go from planning to actual operation of the geological repository, and with all the challenges that we might encounter, and also maybe to go from conservative assumptions, this is what we are always management's doing, to maybe go towards something that is slightly more towards best estimate plus uncertainty. So as waste management organization with direct disposals, what we are focusing on and what's the innovative part, so that's we are based on the multi-barrier concept. So it's engineered barriers that are placed into a natural barriers. So we have the spent fuel that is placed into canisters, that is placed into a buffer that is in the host rock. So of course, where we want to innovate and focus our attention on is, for instance, the choice of the host rock. But then what we can actually really have a say and have actions in it is on the engineered barriers. So the buffer materials, try to find some buffer materials that has the best retention of radionuclides, and then a lot of development on the canister concept. So it can be like looking at the materials and the way the canister is designed. So we want to look at corrosion, mechanical, physical, chemical property of the canisters. So I know that there is a lot of research in EURAD, for instance, on that. I think on EURAD there is common And in EURAD2 is in command. And on spent fuel characterization, that's the other step. When they are in the canisters, we want to focus on spent fuel characterization because it's the source term where all the other calculations are coming from. So that there is also research in EURAD. So there was the spent fuel characterization work package in EURAD1, and I hope there will be another one in the wave 2 of EURAD2. And there is also the one on criticality safety in EURAD2. So that's something that we can look at. But spent fuel characterization is not only just looking at the fuel properties, but also looking at in its globality. So it can be also data management. We have very old spent fuel assemblies where we might have some incomplete or missing information. So how do we bridge the gap in this knowledge? Especially if the nuclear power plants are already decommissioned or soon to be decommissioned or currently decommissioned. In that case, we might have experts from the nuclear power plants that are retiring soon or already retired. So we are losing some knowledge. And how can we make this gap so that it's also not too much of a burden from the nuclear power plants or the waste management organization? So we might want to think about some state-of-the-art techniques like machine learning. And the second topic that I would like to focus on is the optimization in a holistic way of the geological repository. Because if we are maybe removing or having less tunnels, less excavation, we are also improving and optimizing the resources that we are utilizing for these geological repositories. So this is where an area that we want to focus on. And that's to achieve that, we cannot just look at optimization of small parts independently, but to look at its globality and to try to achieve some kind of global minimum. And for that, we could use like digital twins, for instance, to try to make a proxy models of all the steps that we are doing. And that is something that is done, for instance, at NAGRA, but there is also a lot of research projects like the OPTI work package of EURAD2. So that's the points that I would be focusing on.
Okay, thank you, Virginie. Hugh, could you please add from the different point of view, I think, for the fuel cyclarity point of view?
Yes, thanks for the question. And indeed, used fuel management is often seen as a challenge, and it is. But it is also a major opportunity. And the EU has, and we have at Orano, world-leading solutions in treatment and recycling technologies, which allow, as you know, for the recovery of up to 96% of the material contained in spent nuclear fuel. So 95% as depleted uranium and 1% as plutonium, which can be reused in the form of MOX fuel. And the fact is that the separation of plutonium and the remaining 4% of final waste, mainly fission products and minor actinides, not only reduces the volume of high-level waste by a factor of 5, but also decreases its long-term radiotoxicity by a factor of 10. So it answers the question about the fact that we have to reduce environmental and radiological burdens, and recycling helps to do it. I would add that reprocessing recycling makes it possible to standardize the final waste to be sent in future geological disposal, whatever the type and form of used fuel reprocessed. And standard containers are certified for long-term storage, transport, and disposal in those geological repositories. Standard compacted and vitrified waste containers are certified by 9 safety authorities worldwide, including, of course, the French authority. In particular, the vitrification matrix for fission products and minor actinides is recognized and certified worldwide. So optimization of the final waste with standardized long-term conditioning could facilitate the implementation, I think, of potential storage and why not shared between countries. And looking ahead, the fourth generation reactor technologies, such as fast neutron reactors, offers the potential to further optimize resource use, because these systems would enable the reuse of currently stored materials like depleted uranium, and the EU holds strategic stocks equivalent to thousands of years of potential energy production. And some of these technologies, such as molten salt reactors, could allow the transmutation of minor actinides and therefore significantly reducing the long-term radiological footprint of final waste. So I think that in this context, the circular use of nuclear materials is indeed a fundamental strength of the nuclear value chain.
Thank you very much. Now I think some other panelists wanted to add something to your answers.
I would like to add one small thing, and that is we are talking about the environmental impact of storage, but we are ignoring mining. So I think that we have to be very much aware that if we are discussing environmental impact of nuclear energy, that we have to start from the beginning and end at the end. And whatever you do, the least amount of environmental impact of uranium is the stuff that you don't have to dig up. So that's why the use of the material that we have already is so important, in my humble opinion. We need really to increase this efficiency of the heavy metal that we have dug up. You said 96% of the fuel we can recover. It's 1% plutonium, very nice, and 95% depleted uranium. But this depleted uranium is basically also a source. And if we can bring this 95% up to, and together with the other 4 tons of uranium that we've had, or depleted uranium that we produced when we were enriching the fuel in the first place. So it's basically 5 times as much as you are just mentioning. This stuff we can still burn if we do it smartly, which means that all mining activities can go down by a factor of many. And I think that's much more important than the geological disposal. I think the geological disposal guys, from an environmental point of view, are already doing a very good job. It is not there that the big gains are. The big gains are in the beginning of the cycle. And I would like to also make a small comment about molten salt reactors, because you were just mentioning molten salt reactors can be used for transmutation, but we have to be very careful about the term molten salt, because molten salt, I want to clarify this, because sometimes I get very much annoyed by this. Molten salt reactor is a collection of designs. There are 5 different molten salts, there are 2 different versions of how to put the fuel inside, etc., etc. There's an entire collection of families of molten salts and reactors, and not all of them have the same properties. So if you say molten salt reactors can be used, that means that there is a design of a certain type of molten salt reactor that could potentially be used for transmutation, which is not the same thing as molten salt reactors can do transmutation. I think we have to be very clear about this.
Okay, thanks. So, any more comments, quick comments from the panelists before we will move to the questions from the audience? Okay, no? Okay, so thank you very much. Now we will do as follows. 1 question from the chat in the app, 1 question from the public, and we will do that until the time is over. Okay, I will pass the mic around when it's your turn, but first we will start with the app.
Yeah, we will have about 20 minutes. We really received a number of questions in the app, so I think we will try to answer the most important of them. And the one was directly for the Commission. That's why I think I will start from this question. The question was, do you consider that the selected EU strategy to fund materials research via partnership is enough, or should there be something more? And I would like my Deputy Head of Unit, Domenico Rossetti, to answer the question.
Thank you, Nicola, and thank you to the colleagues that raised the question. Whatever political decision we take on the management of research, it can be discussed. But what we decided in the Commission since several years now is to have a continuity of research actions. And we privilege the continuity versus the diversity of projects that we had in the past. I remember 6 years ago when I arrived, there were 160 projects running, which were, I think, diversity is a richness, it's something that we appreciate, but what I understood also from the higher level of the research organization is that it was always like a bid. Yes, you get a project for 4 years, then you don't have any more for the next 4 years, you may get another one, and then we decided to use the European public money in the Euratom program, mostly, because now almost 75% of the Euratom research and training program of indirect actions is managed through the partnership, to say the community, and we have that for waste management with EURAD, we have that for radiation protection with Pianoforte, and we are very glad that Connect-NM is making this job, reassembling the community on the different topics that you feel are the most relevant, and you manage it. Just a question on budget. Over these 2 days, I've been here for 2 days, and I've spoken with many colleagues during the coffee, during the session. If I have to take all the comments from the different part of the community, from safety, from waste, from radiation protection, colleagues say, but you know, you should give more money to radiation protection. You should give more money to safety. You should give more money to the new reactors. You should give more money to nuclear materials. That's what we intend to do and to propose for the next framework program of Euratom. We expect to have a proposal with a substantial increase of budget to the Council. Then it will be up to the 27 member states to unanimously agree on this global envelope. Within this global envelope, we'll take care of being very fair, objective and clear on the distribution of this budget among the main priorities of the fission indirect actions. I hope, Michael, that it answered more or less to the question, and thank you for your attention.
Thank you. This was not my question. So.
Thank you very much. So after this break for the panelists, let's move to the questions. If someone wants to raise their hand, okay.
Yeah, Hamid Abderrahim. We work for more than 50 years about closing the fuel cycle, since the beginning of nuclear energy, actually. And we did fantastic job for many years, and we are progressing too slowly. And things have been said in the panel which were very relevant about better use of the resource, considering what we are considering waste being an asset, not impacting the environment by mining more than needed, etc. All those things is good. And we are in EURADWASTE. In 2005, because also the European Commission spent a lot of money, it was one of the, I would say, programs, the PNT and the closing the fuel cycle, where a lot of effort has been conducted at national level, thanks to the money that we were securing in all the FPs since FP4. And the volume was not what we dream about, but I would say I'm one of the less complaining about that, because it have ensured a continuity of this activity in many labs, in organizations, in industry, etc. So it was fostering the effort. And I think in 2005, when jointly the industry, the research, the academia, etc., and also the European Commission officers, we came to the decision to put what we called the 4 building block strategy for going to industrialization of this endeavor. And what I see today, that was 2005, so we are 20 years later, and we hadn't succeeded really to go in that direction. And the play we were doing was to say, we need now, for different blocks, to make pre-industrial engineering and performance demonstration. Means that we have to go a step higher to what we have done at lab scale. Everyone knows the radiochemistry we did fantastic in Atalante, how much grams we manipulated of minor actinide in MALAB, how much of irradiations we did in Phoenix, in HFR, in BR2, etc., with small grams of minor actinide, etc. And we were saying, now it's time to go to pre-industrial. And I repeat, this is really the step we need. And in the panel previous to that was big discussions about enabling things to create this new nuclear revival or whatever you call it. And one gentleman said, yeah, the fusion is going, those startups of fusion will go very fast to achieve their small fusion reactors, because there is this big project which is called ITER, which is nurturing industry, research, and then they have the supply chain. I can tell you, if we are looking for something that will be the supply chain or triggering the supply chain in all the domains that we are looking for our SMRs, go please to make this pre-industrial demonstration of the 4 blocks, and you got the answer for your fundamental problem. Because it touches about advanced fuel, it touches about advanced technologies of the reactor, all the technologies of SMRs can be used. And I think this may be a learning from such a panel and the one before, that maybe there is something to dig out of that idea of the pre-industrial performance and engineering demonstration.
Thanks. I'm not sure that was a question, so anything to add?
Anyone from panelists would like to comment on that?
Maybe I can shortly comment that regarding the fuel cycle closure, because recently in France there was an announcement to restart a program on fuel cycle closure from the President Emmanuel Macron. So hopefully we are going to work on it.
There's only one thing to add. You're right.
Okay, thank you. Another question from the chat. There is a vast variety of different fuels and cladding materials under investigation and considered by SMR developers, oxides, nitrites, metallic trees, etc. How do you prioritize what to do first, and vice versa, how will availability of qualified fuel limit timing of new reactor implementation? Anyone in? I see, Paul, you would like to?
Yeah, I think prioritize what to do first. The first thing you do is take the thing that works. So we have an entire bunch of versions of fuel, and the most outdeveloped fuels are the oxides at the moment. So that's where you start. If you want, I agree 100% with Hamid. If we want to make progress, we need to go to the industrial demonstrator. In this industrial demonstrator, the first fuel you will use is the fuel that you have qualified, which basically means, for a fast reactor, this means the MOX. And if once you have that machine, then you have the tool in your hand to do the improvement, because all the other versions, nitrite fuel, metallic fuel, whatever, carbide fuel, and so on, These are actually modifications of the oxide fuel in order to reach a certain objective, higher density, easier reprocessing, whatever, doesn't matter, or accident tolerance. But again, the beginning is things that work. And for me, it's that simple.
Thank you. Veronique, would you like to add something? Or?
Maybe yes. I think that in fact, at what point of time we are going to select some types of reactors, and in between, we need to work on everything. Oxides, I would agree, but we need to start being at pilot scale to manufacture some fuel, study it, qualify, and step by step, we will be able to select and define the supply chain. That's what I would recommend.
Okay, thank you. Someone else would like to?
I just would like to add that
join.
What emerged in general, and it is true for fuel and it is true for structural materials or other types of materials, what is needed is a staged approach where you start from what you more or less have and know and then try to go to something else. And I think that this is more or less the strategy that is followed by most projects around a specific type of reactor. Having said that, I insist on 2 points. The first one is, at the end of the day, the methodology, whichever the choice about the material from which you want to start, methodologies are the same. And this is why, from a research point of view, we stress a lot the aspect of the methodology. And the second point is that, again, at the end of the day, it is totally reasonable what Paul says. I think it's the most obvious way of proceeding, and indeed most people are following that path. But at the same time, if around a given project there is convergence of a sufficiently strong and rich consortium around a specific choice that is maybe different from, let's say, the standard one, why not? I mean, I don't think we should say, no, you cannot do that. I mean, at the end of the day, it's a strategic decision that is taken by those who are ready to bet on a specific solution.
Thank you. I think another question again from the audience, please.
Thanks very much, Ian Darby from UKNNL. What's the most urgent interventions that Europe needs to make to preserve independence and security in the fuel cycle and access to critical materials?
I don't know, Orano, perhaps, or Framatom, you are the best post to answer this question.
Thanks for this question. Indeed, I think that we need really to keep in the EU the technological leadership that we have on the whole fuel cycle. So what we need is a clear support, political support at EU level, and I think that, for example, the Industrial Alliance is an interesting political support at the EU level that we should really use to speak about the need to keep this technological leadership. And we have to also ensure that the EU is able to support and to finance new innovative ideas and all kind of industrial projects in the fuel cycle. So, for example, we have signed with the European Investment Bank a loan for one of our enrichment extension of the enrichment capacity. But we should see this support on the long term for the whole nuclear sector in Europe. So I think that there the European Investment Bank has a clear role. And we hope that this support will continue in the next years, because it was a long time that we did not see such strong support from the EIB for such big nuclear projects. We need also to have a clear support for technologies that we have and that we can develop. I can think about HALEU, for example. We have the technology and the know-how at Orano, for example. So clear support at EU level would be, of course, welcome to keep this technological leadership.
Thank you. And we have actually still quite a lot of questions in the chat, but I will follow democracy principle. I will choose the one which got the highest support. It's a question actually to Mr. Schurmans. France is considering closing the cycle for the second part of the century. To your point of view, what is the path to be ready? And advancing at realistic pace, when, to your view, would we be ready?
This is a very difficult question because it's highly speculative in the sense that first question is, what do you mean by closing the fuel cycle? Does this mean we are ready to reprocess and take the depleted uranium and store it somewhere and take the plutonium out of it and refabricate this, put this again as MOX in a water-cooled reactor and ignore everything else? Yeah, that is something that we can do right now, basically. Does this close the fuel cycle? In my humble opinion, no. Because you still have an entire pile of useful material that you don't use. So I think we should be more ambitious about closing the fuel cycle. And that also means that you have to develop the fast reactors. You have to, and eventually you will have to be able to not all of your park, but a significant park or part of your nuclear fleet will have to be fast reactors. And then we are talking about deployment of fast reactors. Okay, you can do 10, 15 years from now realistically to deploy a prototype, given that the funding is there, to come to an industrial fleet. This is going to be a bunch later. Second question, and there I am not the expert, I have to refer to my colleague of Johanno, is that you have to do the multiple recycling. You will have to be able to take fast reactor fuel and recycle it again, and again, and again. And that means that you have to be able to work with higher loads of minor actinides, with more, hotter fuel, so to speak. And this is the development that is still going on. We are making progress. We are trying to develop the different ligands, the different extractors, with the boundary condition that we want to get rid of the sulfur inside these things, only using carbon, nitrogen, oxygen, hydrogen in order to make them completely combustible, and so in that say also reduce the solid waste of the process. But I honestly have I'm not in a position to make a realistic estimate of how long this development is going to take until the industrial deployment. So you can ask, but I don't know.
Someone would like to add something? No? Probably the very last question, because we are approaching the end of the session. Many presentations over past 2 days have described the ambitions of several European countries to build SMRs and AMRs by mid-2030s. Is it feasible for these new reactor designs to use substantially new materials, or is it more likely that we will see incremental change to materials?
I think this was already addressed more or less in the previous question, but obviously it is highly unlikely, I don't want to say impossible, but highly unlikely that by 2035 we will have available on the market, let's say, totally or significantly new materials. Of course, we would like to, but yeah, we have to be a little bit realistic. So it's what Paul said as well. The strategy is a staged approach. So you start building, licensing and building things with what you know most, or you think you know most at least, and you are able to make the case, and then you move towards something new. However, I insist on something that I said already. This is probably the only possible strategy, but it is highly desirable if we really want to achieve the real objectives in terms of efficiency, of use of resources, and so on and so forth, that next generation reactors are promising. We need, as fast as possible, to move to better materials. And there is where the accelerating strategy is important. Not necessarily to build a prototype, but definitely to go further in a sufficiently fast way.
Okay, thank you all very much. You wanted to add something quick?
Yeah, just one sentence maybe that, yes, I agree. So it's very unlikely that something appear. Because it's not just because we are pessimistic, but we have done so much in the past. So our field, so the ore industry is a very science-based issue. So we developed, we understand the clustering, understand how the material behave, understand the separation, how the precipitates develops. So this kind of knowledge is not come from nothing. It comes from the previous researches we carried out. So what will be developed should be based on the knowledge what we have. And also we should be very proud because the knowledge we use, we developed. Other industry mainly use what we developed as well. So that's, we serve the other industry as well for material development. But what we can utilize from others, it could be questionable.
Thank you very much, Sasha. I actually prefer wrapping up the session with a drop of optimism. Although, yeah, lots of challenging things ahead of us. So with this, as I said, we are going to wrap up this session on nuclear innovative fuel cycle and material strategies. First of all, thanks to all the amazing panelists, which not only provided great answers, but great discussions as well. So thanks. Thanks, Nicola, for making this very easy to moderate, to the rapporteur. And thanks especially to the public for your attention, spending 2 hours here with us, and for the really interesting questions. Thanks.
spiraling big band. cosmic space. Here are the pioneers seen off by some of the thousands who contributed to the maiden voyage. Man is stepping into the unknown world of caution. Only moments left before the start.
I will let you open, then I will tell them how it will work. General question. Okay, but I'll let you.
So it's okay. Also the subject. I do the subject and their names.
Their names. When you just say this, and then we can just welcome them. They can come.
So they are not here.
Yeah, they can sit there, and then we welcome them. Yeah, that's better. Okay.
Yes, yes, yes.
Yeah, I'm gonna tell them, and then they come and sit wherever they wanna sit. I will say a few words about the practicalities, and then we start calling them one by one in the order, and they come and introduce themselves.
Okay.
Okay, I think we're going to start because I'm done waiting. Lydia, the floor is yours, please. Yeah.
Thank you. Hello, everyone, and welcome to the plenary session number 3, Empowering Future Generations and Engaging with Civil Society. My name is Lydia Gainovic. I'm a researcher engineer at the CEA in France, and I'm a member of Young Generation Network of European Nuclear Society. Today, the topics that we will cover will focus on how the sustainability, safety, and social acceptance of nuclear energy depend on building a well-informed, skilled, and engaging community of professionals and stakeholders. The crucial factor, of course, empowering future generations through education, training, and transparent communication. This factor is essential to ensure the responsible development and deployment of nuclear technologies. Moreover, we will focus on how engaging with civil society to build public trust.
Perfect, thank you. So, my turn now. My name is Saif Ben Haj Hassin, and I'm part of the European Commission. I work for the DG Research and Innovation. I'm supposedly the person in charge of everything related to research on waste management and decommissioning. So the EURADWASTE part on the logo behind me is me. Other than that, I'm very happy to co-moderate this session with Lydia. And I wanted maybe very quickly to give you an overview about the sessions. First, I would like us to welcome our 6 panelists. So Stefano Monti, Francesco Javier, Teodora, Philippe, Jana, and Nadia. I didn't say all of the last names because I'm not sure I can tell all of them properly. So please join us and take a seat. The way we will proceed is I will ask in turns our panelists to come to the mic and say a few words about themselves, and then we will move on with one general question that I would like them to address collectively. And finally, we have 3 specific questions. We will take turns in addressing these questions. More importantly, please, if you have any questions for our panelists or for us, I'd put them in the Q&A on the app. You can also raise your hand. We have 2 mics, one on the right side, one on the left side. You can take the floor if you wish to. We only have 90 minutes, 6 panelists. we will do our best to manage the time properly. What did I miss? Yeah, I missed something very important. I wanted to ask the audience already here when they got into the nuclear sector. So if you got in the nuclear sector under the age of 25, can you please stand up? Under the age of 25, the nuclear sector? Yeah, all of the young ones, basically. If you got in the nuclear sector under between 25 and 35? Okay. And if you got late in the nuclear sector after 35? Okay, that's interesting. So basically, nuclear sector is either you get in early or you never get in. Okay, interesting. Anyway, so without any further ado, I would like to, Lydia, this is your turn. Yeah.
Thank you. So I would like to introduce our first panelist, to give him opportunity to introduce himself and give a short introduction to this session. So I invite Francisco, the president of the NN Association, to present himself.
So you can. Okay. Thank you very much. So thank you very much for this invitation. For me and for NN, it's a great honor to be here to present our activities and our vocation in this sector. So I am Francisco Javier Elorza. I am professor in the Technical University of Madrid, la Universidad Politécnica de Madrid. I am mining engineer, but on the energy track. I started at the beginning of the 80s studying, making calculation for the small circuit of the ASCO-2 nuclear power station. So I was from more than 43 years ago working on this field. And after that, in 86, I started to work for ANRESA, for the Nuclear Waste Management Agency in Spain. And from that time, I am working with them in different projects. I have been involved in research and development projects like FEBEX or like CLIPEX and many others related with bentonites and with, in general, with nuclear deep geological repository. From some years ago, I am also working on dismantling. Now I am working in the final phase of the decommissioning of the Sorita José Cabrera nuclear power plant. So I have skills, I have activities in my career as engineer in different parts of the fuel cycle, from the beginning, from the development and from the design of the nuclear power plant until the back end. So I am completely convinced, being Spanish, that the nuclear energy is very important and is the only solution to the sustainability of the energy system in our modern society. So from that time, from where I started as professor many years ago, I have been always pushing and fostering and bolstering also the activities of the students in the design, in the environmental aspects, in the geological disposal aspects, and in many things to develop skills and things like that. So now in NN, we are working on that as president, and we are trying to make a more strong and a more influence network, an academic network. So we are working on mobility, we are working to give the opportunities to the students, not only from the university, if not also the secondary school students, to know better what are our problems, what are our challenges, and to demonstrate then that this is a sector that is very innovative and is crucial for the development of our society. So we are developing many academic and teaching programs from the secondary school to the doctoral degrees. And I think that we need also to start to work not only in the students, if not also in the general society, to open our activities to the long life learning activities to motivate both the attraction of in general the society to our sector, but also to renuclearize some technicians or some engineers or scientists that has been working in other sectors, and now they could move to our sector that is a very challenging and promising one. So thank you very much by this time.
Thank you, Francesco. Just a small comment to my panelists. If you see me or Lydia standing, it means I want you to go faster. Okay. So please, our second panelist would be Theodora. Please, Theodora.
Thank you very much. My name is Theodora Redegan-Folmer, and I'm a professor in nuclear chemistry at Chalmers University of Technology in Gothenburg, Sweden. You can see a little bit a part of my CV. Yeah. So basically, I'm maybe a little bit of a weird bird in this respect because I'm a chemist and a physicist. So I'm kind of with a foot in both fields, and I got a master's degree in applied organic chemistry in the nuclear field from Babeș-Bolyai University in Romania, and then I got my PhD. And my future professional path has been at Chalmers University. What can I say is that, well, I'm a passionate teacher. I like to teach, and I enjoy to have students of all ages to be able to form the future generation. And it's something which I'm always striving for. My research path has been, in a way, going towards two areas. Main areas is hydrometallurgy and its reactor safety from the chemistry point of view. And when you think about that, is that how this can converge? Well, it's rather easy because hydrometallurgy is strongly connected with waste management as well. So basically, I have all the fuel cycle in my research area. Yes, I have quite a long experience in nuclear field. I have started as a young master student when I heard the first time that I can apply organic chemistry in nuclear field. And it has been a while ago, so yes, I started when I was around 21 years old. And since then, I continued with a lot of work done in the field. I have been involved in many projects, and many of these projects started early on in 2002, but since 2010 I have been involved in a chain of projects dedicated to education and training, and that continues even today with the latest project we have gotten, which is called Skills for Nuclear, and it's exactly what it sounds. We are looking for skills for nuclear. And with that, I think that I said enough about my CV, and I'm looking forward to continue the discussion here. So thank you very much.
Thank you, Theodora, for this nice presentation. Now I invite Philippe Chary, the French representative of European Economic and Social Commission, to give his introductory presentation.
Thank you, Lydia. So my name is Philippe Chary. As he said, I'm a member of European Economic and Social Committee. As my two colleagues here in the room, Baiba Miltovica, you saw her yesterday, and Alena Massantono, you will see her at the next panel. So I'm a unionist, and as a unionist, I defend interests of workers, including those of the nuclear industry. I never work in nuclear industry, so I did not go up. Yes, but I'm interested in the topic. I also defend the purchasing power of populations who are today facing repeated crises, especially with high prices, yes, you know. But what brings me here is my involvement in ESC, and you know, the 10th section of ESC deals with energy issues, including nuclear energy, but also with everything related to radioactive materials, for example, in their medical application. It's important. Within the ESC, which represents organized civil society through its various components, many of us want to highlight all the benefits that nuclear energy can bring in the face of current challenges. This includes the decarbonization of electricity production, of course, the decarbonization of industry, and in the same time, competitiveness. Competitiveness, I have a problem with these words. I prefer cooperation than competition. It's my side unionist. It's also a matter, and for me it's essential of stabilizing prices at a level acceptable for the entire population. All these aspects are present in the debates taking place in our European society with different approaches depending on the member state and, of course, controversies that must be addressed. In civil society, nuclear workers are the first to be concerned, and they are the best ambassadors for the sector because they have been an integral part of it for decades. Their practical knowledge and direct experience on the ground are invaluable to the public debate. This is very important. It's the main message I will bring here today. In France, the 200,000 nuclear workers play an important role in the debate within society. It's partly thanks to them that the debate is clearly settled in favor of nuclear power in the country. In Europe, we have around 1 million workers, and we need to involve them more. The trade union, which represents these workers, are relevant interlocutors for advancing the debate positively in the society. In any case, it's in our interest to develop this dialogue with the trade unions, the trade union of the sector particularly, and to highlight their contribution. This can have a positive impact of the outcome of debates and decisions. In the debate, it should also be mentioned that nuclear technology is also used in the medical field, including for waste management. The use of medical radioisotope is booming, with great scientific progress and much hope for patients. All member states are concerned, even those opposed to nuclear power of energy. The transport of radioactive materials also pose one of the main challenges in the medical sector. We need to put all these aspects into perspective: nuclear power for energy, nuclear power for research, and medical nuclear power. They have in common need for fluidity for transport, including cross-border transport, and for waste management. And in the year to come, it will be necessary to ensure that SMRs can be established without obstacles in countries that want to do so, but do not have an industry to produce them. In short, this means that we need a single nuclear market with all the fluidity that this brings. This requires better cooperation between member states and appropriate rules in the European level. Thank you.
Thank you, Philippe. Maybe very briefly, I should have said this when I started, but all of the panels we formed are supposed to represent very different point of views on one single topic. So our panel today is indeed very diverse, and we heard about the trade unions from the workers' point of view. We had also Pachi and Theodora, who will tell us a little bit more in a couple of minutes about skills and competences. And I wanted also to invite now Jana Kalivodova, to tell us a little bit more about what it means to be a researcher in the corporate world this time. Yeah.
Thank you, Saif. Good afternoon to everyone. It's my honor to be here and to tell you something in this moment about myself. I am Jana Kalivodova, coming from Czech Republic. Small correction, not anymore working for CVR. It's a dynamic period, but I'm staying in the nuclear sector where I get to only after 35, so you could see me standing as the last group. Firstly, I graduated from the University of Chemistry and Technology in Prague I have more than 20 years of experience in the technical and R&D projects devoted to material science for mainly energy production, but also for other application, specifically high temperature degradation. Yeah, as I said, this study and research devoted to material science was first part of my career in the field of combustion of coal, biomass, co-firing, co-combustion, cogeneration, and so on. And then later, probably getting matured, I moved to the clean and green energy, nuclear energy, where I'm staying also now. And since the material science is a very cross-sectional topic, I had the opportunity to work in several international teams, research teams, and with very nice researchers around Europe, but also the world. And I became a member of several organizations, including also the SNETP, and my big honor is lately already 1 year being in team, in great team of the INN. So I think it's all from me now. Thank you.
Thank you, Jana. I give floor now to Stefano Monti, the president of the European Nuclear Society and Italian Nuclear Association.
Thank you very much, and good afternoon. Are you all here with us to listen our elaboration, I hope? So, frankly speaking, I was not at all prepared to talk about myself. I don't like to talk about myself, by the way. But anyway, it seems that we are forced to do it. In a few minutes, I try to review my long career, which means that I'm very old, which is true. I was graduated at the University of Bologna in nuclear engineering in 1982. That's what it is. And then I moved immediately to the nuclear sector, working in a Ansaldo-related company in charge of development of advanced reactors. And actually for a few years, I was involved in the design and realization of a material test reactor with fast spectrum, something that nowadays we really miss, at least in Western countries. Lorenzo, we talked about that in previous panel. But unfortunately, I was one of the victims of Chernobyl. So when the reactor was completed at 90%, our government decided to cancel the project. Okay, so I had to move to other sector. I was moving to more theoretical stuff like modeling and simulation for neutronics. I developed generalized perturbation theory. I don't even remember what it's about, but I did in the 90s. That I was also working on fusion. I was responsible for the shielding design for the conceptual design of the IFMIF facility. Again, something still to be realized, but we remain optimistic. And then I moved to, just to say, projects that were never implemented, the accelerator-driven system. For 10 years, more than 10 years, I was working even with the Nobel Prize on accelerator-driven system in Europe. There are a lot of friends here that they were involved in this project. Then I moved to the IRIS reactor design. So the real first Western country IPWR, at least in modern time, because there were IPWR also in the 60s and in the 70s. So I was involved in that project. Again, the project was cancelled for commercial reason, but I kept going anyway. And then in parallel, I was also very much involved in Europe for the development of the lead fast reactor. I don't see Luciano Cinotti here, but this is our mentor for lead fast reactor in Europe. I had the pleasure to work with him and other colleagues. And then I was participating in restarting the nuclear option in the country before Fukushima. And I was also a victim of Fukushima because we stopped again the nuclear program because of Fukushima. So I decided that at least in my country, Europe was enough. and I moved to the International Atomic Energy Agency. So for almost 12 years, I had the pleasure to be the responsible of the, let's say, program on advanced reactors and non-electric application, etc. At the agency now, we have a much better person, Frederick Reitzman, who was my successor at the IEA. So it seems that is a family reunion, this one. And then finally, when I was back from the IEA to Enea, I was nominated the president of the Italian Nuclear Association, and then afterwards of ENS. I was talking too much about me, but I would like to talk about ENS if you give me 2 minutes, which is much more important than me, because it's a standing organization. We can also go ahead with the, what we are. Well, I hope that you know the European Nuclear Society is a learned society which promotes the peaceful use of nuclear technology, not only energy, also medicine, space exploration, R&D, and so on and so forth. We represent 22 member states, and even more important, more than 12,000 members, professional all over Europe. Actually, it's not only European Union, it's beyond the border of European Union. And also, we have the pleasure to be advised by 28 corporate members. It's very important for professionals, of course, to be continuously in contact with the industrial world. Specifically on the topics of today, well, I don't say anything about our ENS young generation because there was a full session yesterday, so I hope that you learn about what they are doing. But we are also very active in this. Actually, we were among the promoters of this important initiative of Nuclear for Climate, how to have nuclear at the table when we talk about decarbonization of the energy sector. Okay, sorry. So we do a lot of work, of course, with young people, and above all, we try to listen to their needs and their expectation. Regarding public engagement, here also we have our activities, school workshop. You know, again, also for public engagement, we rely very much on the contribution from our ENS Young Generation Network. It's also a different point of view that we bring to the discussion. And I would like to just to initiate the debate, that I would like to say something again about, the main topic of this session, which is how to engage, how to motivate, how to have on board the youth. Well, actually, my current occupation is not nuclear, is skipper. When I try to go sailing as much as I can, and the first thing that I do when I have to manage. I'm not a professional skipper, I'm really a dilettante. But anyway, when I have a new crew, the first time that I want to do is to listen, okay? To listen what they want, and what is their expectation regarding, for instance, the sailing trip that we are going to initiate. And from this point of view, we cannot say that we don't know what they want, because now, they deliver a statement at this conference. So let me go quickly through this statement because I think that it can also enlighten our discussion. Well, the first thing that they say is pretty obvious, without offending our young generation, but they say that, yes, they want to see nuclear as part of the energy transition. Okay, good, is what we call in Italy, viva la mamma. We all agree on that. How to do it is a little bit more challenging. And then there is actually something which is, in my view, interesting to listen. And they say that they want to make nuclear more appealing and more attracting. Yeah, it's a big problem. This was I think that we have to debate a lot why nuclear is no more appealing or attractive, at least in our side of the world. The world is not even from this point of view. And this is interesting, creating a culture of demand for nuclear. So there is a cultural dimension to make nuclear more attractive and appealing. And then there is a kind of, I would say, constitutional statement. They say, ensure equal access to opportunities regardless of age, gender, nationality, or social status. I cannot agree more because, of course, we want that, for instance, when there is the need to cover higher position, we want that this selection is very based on technical competence, on scientific competence. Too much time we see that some selection is based on political consideration, which personally I don't like very much. And then I close very quick now. Yeah, from the very practical viewpoint, they say, of course, we represent the modern society, so we wanted to see digital transition in nuclear. And again, Lorenzo was scolding us this morning. It's not only about AI, there are many other digital opportunities. Of course, I don't know anything about that, but I'm sure that the young people are very much interested to implement that, which is not obvious because we have some constraint, for instance, regulation. So how to implement digitalization, AI, etc., in the nuclear world is not obvious because, well, we have always the safety authorities that they have their idea. And then they ask a very reasonable thing. If we are here to build their future, well, they have the right to participate to the decision-making process. So they ask to be part of at least to bring their ideas and also to be considered when we have to take important decisions in our sector. And I think that they are right. Sorry, I was too long.
Thank you, Stefano. So I will be forced to cut your time for the next questions. Nadia Zeleznik, please, our last panelist, she will introduce herself. And please feel free to react to the youth statement as well, if you wish to. Yeah.
Thank you. My name is Nadia Zeleznik, and I have 2 slides about my background. So basically, I am a physicist with a master's degree in physics and reactor physics, also master's degree, and later then I finished a PhD in psychology, all in the University of Ljubljana, Slovenia. I am specialist for radioactive waste management and for risk perception and communication. And I'm almost at the retirement age, so I hope I will still be involved, but I will have some my own boundary condition of involvement later. I have experience in research, so I was a researcher at the Josef Stefan Institute. I was a regulator at the Nuclear Regulatory Authority. I was leading a lot of projects at the Waste Management Organization for 18 years. It's called ARAO, and I am now with the EIMV, which is the technical support organization in Slovenia. But apart from that, I'm also chair of NGO, non-governmental organization called Nuclear Transparency Watch, dealing with the pro-safety and pro-transparency in nuclear. We are established for 2013 on, so we have now already 12 years of the activities ongoing. So basically, we are quite active and we involved around 60 organizations across the Europe from the nuclear NGOs. I was also involved in many international projects, and I'm also contributing to the scientific area in the field. But what I think I need to share with you is that the reason why I changed my perspective, I was really a hard researcher doing the research in nuclear, and I was very proud of being able to comprehend difficult ideas and concepts on how nuclear is working. But later I started to be involved in the site selection for repository. And we needed to use a better approach as it was used during the repository first site selection because of the failure in the 90s. And we started to collaborate with the social science and humanities professor, expert. We studied different other approaches and also worked with civil society, citizens. And then my perception shifted because I started to realize that what is their understanding, how they perceive, how they feel, and that there are many others positioned as it were in the beginning. So I had contacts with many different representatives, besides nuclear sectors, also NGOs, politicians, lobbyists, mayors, citizens, and media representatives. So I was really at the Agency for Advanced Management leading the siting of the repository, and we were successful with the site selection in 2010. So I would just pose two things. Next slide, please. I think that nuclear facilities are perceived as risky by civil society. Therefore, the involvement of public should be implemented to obtain necessary public trust and social agreement. Can you change the slide, please? You can do it yourself. Oh, me? Okay. Thank you. There are continuous. This requires continuous, transparent, and inclusive involvement with different actors, in particular with local communities, citizens, and NGOs. The methods there exist with experience from past projects, so the best approach should be used for each particular case to address needs, expectations, and concerns. Also, regarding the future generation, many different domains and sectors are competing for new staff. Therefore, some basic conditions should be established to attract, educate, and retain new personnel. So with this, I finish my first intervention.
Thank you, Nadia, and thank you to all of our panelists for their introduction. Now I propose we proceed to the next part of our session, which would be organized as a structured discussion between our panelists. So the first question directed towards all of them is something that Stefan already tackled a bit in his introduction, and it is: how do we make nuclear sector more appealing to young talent, and how we ensure that we use the brilliant minds to shape its future?
If I may, very quickly, before I give the floor to our panelists, I did hear some of the feedback I heard from yesterday and this morning. We want this to be more interactive, so please do engage with us in the Q&A, with the audience, with the panelists and everything. So this is also for you to react on. We will give the floor to our panelists, but if you wish to raise an issue or a question or comment to our panelists, please do so. Yeah, please. Sorry about that.
So once more, the question is: how can we make sure the nuclear sector more? How do we make nuclear sector more appealing to young talent and ensure we attract the brilliant minds who will shape its future? It is directed towards all of you.
Francisco, can you tell us more about? This is basically your job, actually. Yeah.
Let's start. So, from our position, I think that to answer this question, we need to consider the specific characteristic of each generation. The answer is complex and relates precisely to these specific characteristics. Some generations aspire to high salaries, others to flexible working hours, some to visibility in their bubble of friends, and others are concerned with the earth and the environment. So each generation has its own characteristics, but for us, the most important task is to present all the benefits that the nuclear energy brings to the world and to the society in a general way. So what is important is to make clear in a very transparent way to the new generation what are the benefits, what are also the drawbacks, but what are the possibilities that could the nuclear energy and in general the nuclear sector to bring for the energy transition, for example, but also in other fields as health sector or in other applications. So this is very important. So not to be always talking about nuclear energy and nuclear power plants. We need really to open the discussion to other applications. And like this, I think that we are going to be much more attractive, and we are going to have much more people with us. In the particular case, for example, of my university, we were working with a nuclear master, nuclear science and technology master from many years ago. And 5 or 6 years ago, we had in between 5 and 8 students each year. And one day we decided to open a new branch, a new track for nuclear waste. And we proposed with other universities a track on nuclear waste management. It was inside the Erasmus Mundus Arena. And doing only this thing, we have passed from 80 students to 40 students in our master. So we need really to give more possibilities to the students. We need to open the windows and to show what are all the benefits. In this, from 2 days ago, I am always looking this image in the back of ourselves. It remembers to me the Titanic, Pesio. So it's not this one. Sorry, this image behind us. It remembers to me the Titanic. So it's some kind of a disaster.
Yeah, I haven't thought of that.
I will change it immediately. It's not attracting anybody. We are always here convinced, but we need to open the doors and to give more flower of our sector. Not only this, not so easy to the vendor side.
Yeah, well, you're actually right. I don't like the idea of sugarcoating what nuclear is, but indeed, I think the biggest question of this first question is, what are the drivers that would motivate the young ones to get in the nuclear sector? Well, there are many issues in that, because there is a competitivity between the different sectors when we start looking into our first jobs and everything. For you, Nadia, for example, what are the most important drivers for the young ones to get on the labor market?
Yeah, thank you.
Yeah.
I was just investigating a bit about that, and I found several. So, job security and stability, then including working condition, then meaning and purpose of the work, that they have a meaning, that they make a difference, a motivation, a kind of high-level goal, and the fourth one is the new major projects. So something which they would be activated with, and they could compete, for example, with a topic which is our team, which is now on the highest position, like genetics, things like that. So this is very difficult, in fact, because I have my son is in genetics, and there, research is going very fast and very intensive, and it's very difficult to compete with such areas. But nuclear has a future, and I think it's possible.
So,
yeah, please.
Yeah, no, but I just wanted to link myself to the fact that nuclear has a future. For sure, it has a future in Asia and other parts of the world. We would like clear message from the politicians that nuclear energy has a future also in Europe, in our region. So, further to the elaborations that I did at the beginning, that we have to listen to the needs and goals of our youth, there is a point that is very important to me, and I was surprised that it was not included, that the nuclear sector should be more reliable and consistent. There is a work to be done both by politicians and also by the nuclear sector. First of all, the politicians at the European and national level, they have to send clear message that nuclear is part of the transition, is part of our future in Europe. In my view, too many times the youth, they receive ambiguous message. On one side, they say there is someone, even in Brussels, say, oh no, we can make this transition only with the renewables, 100% renewables, and then we have blackout in Spain, by the way. And then others, they say, oh no, but there is no solution for the nuclear waste, or nuclear is not safe. How to make appealing this sector with this kind of message if we wanted to engage also with people which are not already in our sector. And also the nuclear industry should be, in my view, a little bit more consistent and attractive. Look at the reality, okay? We talk, every time we have this conference, we talk about new projects, new initiative, etc. But it's a matter of fact that in the last 25 years, only 6 reactors were built in Europe, okay? is the reality, instead of thinking about a very ambitious future. So we lack a consistency, we lack attractiveness. I understand that the researcher who is involved, I don't know, in neutronics or simulation of minor actinides in a fast reactor, he can go ahead with this calculation also forever. But let's talk about an engineer. Okay, I'm an engineer, 25 years old. I mean, just looking back to me. Okay, I entered the nuclear sector, but I have no assurance that at the end of my professional life, I will see a reactor working. I'm an engineer. I wanted to see something working, in operation, okay? Yeah. So here, we have to think about that and increase attractiveness through deployment. We cannot, I've been working in R&D field for all my professional life. But I understand that now the priority is deployment, deployment, deployment. If we are not able to deploy whatever we have now and then in the next future, it will be very challenging to attract the best mind to our sector, because it is a very competitive arena, even in the energy sector, without talking about the other technologies.
Okay, so just to sum it up, Francesco told us that opening opportunities for the young ones is a big driver. Nadia told us you have to afford them good conditions, good jobs. They have to get there to get the actual jobs in good condition, no precarity, these kind of things. Listening to you, the first message was clear communication. So we need to tell them that it is a good thing to go in the nuclear sector. But more importantly, we need to deploy concrete projects so that they have a concrete job, an actual job to do. Theodora, Jana, do you have anything to add to that? Because I know I already had discussions with you.
Yeah, I can maybe shortly say a little bit connected to what I am doing, because I think that is important as a teacher and as a former of future people working in this industry, to look at your class and say, okay, the future is today in my class. That means that you have to teach good and reliable information, and also to try to form the critical thinking, because once you have the critical thinking, you are capable to comprehend how complex nuclear field is. And yes, I totally agree that it's good to do things and to start building reactors, but we also have to remember that we need to have responsible people which are taking care of all the fuel cycle, all the way to disposing the waste, because that's a great responsibility. And when I say that part, then I'm also going towards the most important part, is that the power of example, it's tremendous. So when you have the students put together with somebody which has a career in this field, regardless on which part of the fuel cycle, you already have an example. You already have somebody which is by the student, and they can share the experience, and they can see the career path, and they can see the development. And what I'm trying to say is that it's very important that we do have industry, all industry, closely related to universities and schools, and involved in all that education part. Because when you have the power, for example, it's going always to work. You have a role model, you have somebody which has been and is involved in this area, and I think then it's easier to say, well, actually it's possible, I'm going to have a career. Oh, even if I have to put down a reactor, and I have to scrape the last part of radiation which is still left in their place, that's actually a cool stuff to do, because it's so important. They cannot build a new one if I don't put the old one down and clean the site. So, you know, it is easier to tell them, yeah, you have a career all the way to your pension, even by taking care of the leftovers of a reactor. So, yeah, I think that the power of information and the power of how should I say, example.
Yeah.
It's something which we can always work with. Yeah. So that's from my point of view.
I strongly agree with that. With both of you, actually, the deployment is would be the strongest motivation. And before we are there, another thing could be the more involved the industry, as you said, into the even teaching. But for example, if I look back, what was interesting for me that time were the internships, some international travels with possibility to do the research in another organization or even in industry on the side, to have possibility to work with unique experimental facilities. So to somehow involve the industry, but also large infrastructures for the nuclear, and in this respect to how to say, combine for a new generation, to prepare them for before the nuclear power plants will be built. Yeah. Okay.
Thank you.
Yeah.
So speaking about the power of example and how important it is for for young generation to have some practical experience, Philip, what do you think might be some opportunities or aspects that nuclear workers can bring to the youth?
We're always in the same question.
Yes.
Yes. So for me, what's important, the first thing is to project a positive and inspiring public image of the nuclear sector. It's more important for young people. We can. I agree with all what was said before, but we must highlight some advantages. For example, the decarbonization for the climate change, it's a good example. The affordable and stable energy source, it's another good example. The question of sovereignty, of security, of energy, it's another. We can do more. You know, nuclear is probably, it could be proved, I suppose, it's probably the energy that has a less impact on environment, because there is no renewable. Renewable is without raw material, but what we call renewable use a huge amount of raw materials, of concrete and so on. So many things. But what perhaps is more important is to say it's a sector for the future. You told that, but for example, in France, for the next 6 years that are planned, for build them and run them, we need 30,000 recruitment, 30,000 new jobs in nuclear. In the next 10 years, for the whole nuclear sector in France, we need 100,000 new jobs. It's huge. It's something we can say to young people. You can build your career, your future in this sector. It's something I suppose enthusiastic. But because I'm a unionist, I will not forget something important. The problem, for example, we have wages in nuclear sector that are less than in oil sector. That's a problem. How can we say, oh, we need to decarbonize to replace oil, fossil new energy by decarbonized energy, and have wages in nuclear sector not so important. So it's another example. But the first point, the most important, is to say it's something for the future. It's something good. It's something with a medical aspect. It's something we can improve the world with nuclear sectors. That's the most important.
Thank you, Philippe. I do want to take the opportunity to take a question from the audience, if there are any. So just to remind you, the question is, how can we make the nuclear sector more attractive to the young ones? And maybe myself, I can react to that as well. Back then, when I was looking for my first job, and the number of HR tests I had to do just to identify what's my driver to go to work every day. And I had that conversation, I think, on Monday, and I want to give him credit for the conversation. If Hamid is around, I don't see Hamid. But anyway, so he said something that I completely agreed with. We are so focused on, yes, we need to sell nuclear to the young ones. Yes, we need nuclear, we need the young ones. But I think we need also to make a reality check. Work is by essence unpleasant. That's why we're paid for it. There is no nice work. Work is always unpleasant. The idea of going into the first job and having a salary by the end of the month for doing nothing, that will never exist. So I think we need to remind the young ones that work is hard, work is suffering, work is there, and in any case, you will not immediately like what you're doing. And it's important to remember that. But nuclear sector can afford other opportunities and other dimensions that the other sectors cannot. And in my personal case, for example, when I went into waste management, well, this is maybe a personal opinion, but I wasn't ready to work to make more money for a person, the CEO of the corporate business or whatever. So I needed something more than that. And working on waste, for me, transcended completely life expectancies of one person. I was working on a system that would last for hundreds of thousands of years. That's completely nuts. I mean, it doesn't fit in any brain. And just philosophically, the idea of that was very appealing to me. That's why I went into that. But anyway, that's my story, and that's not the idea of the panel today. But I would like pretty much to hear from the young ones, even in the chat, what made you go in the nuclear sector, and what would make you go in the nuclear sector? You don't have to reply now. I'm running out of time. So I'm going to go to the second question, though. One of the biggest issues we have today is that we have a gap in the workforce. We have many workers going into retirement and not enough young ones replacing them. So we have to understand how to retain knowledge and how to maintain it. So the question is, what would be an effective and forward-looking policy or strategy to develop skills, build competences, and preserve institutional knowledge? So maybe first I'm going to turn to Theodora, because you might not know it, but we had this open call recently about skills and competences, co-funded by the EC. And maybe, Theodora, you can tell us a little bit more about that.
Thank you. Now you all know that we are starting, and we started the kickoff, has been in April, of a project which is called Skills for Nuclear. The project is called exactly like that, and it means exactly like that. We are looking for harmonizing the skills for nuclear. We want to know the needs, we want to know the numbers, we want to know the sectors, and what we can say is that basically it's not only nuclear engineers we are looking at, but we are looking at all the jobs which can be so-called nuclearized, meaning that we have welders, which are extremely sought after in nuclear field. We have builders, which can build and they know structures and they know quality of cement, and they know all the materials which is needed, and that job can be nuclearized. We need people which are working with piping. How about piping in a reactor? If that is not good, nothing is good. Of course, these people can be so easily nuclearized. But then there is another big question, is that, you know what? We are competing with other fields. We are stealing these people from other fields. How can we do that? And that's the big question. Everyone needs this kind of skills. We need also our nuclear engineers, which we know and we are training, but then you need to reach the point where you have to give all these other jobs the possibility to see the opportunity, to retain and train them, and actually to have them there when you need them. And that is something which is not easy, and this is what we are trying to do in this short time we have. But this is only the beginning of a huge endeavor, I would say, from the Commission. So yeah, I don't know how much I answered to your question, but this is how we are trying to do. We try to identify and show the need. And I think that that's also going to contribute to attracting people in the field. We want to train and retrain people. We want to move them from one sector to another. We want to give them the guts and the will to move from one field to another and retrain, even maybe at an older age. Because those people have skills, huge skills. So we need them. That's it.
Stefano, please, if you want to take the floor.
Yeah, well, actually, Teresa stolen my arguments. But so elaborating on that, in my view, in Europe, we are very good in developing skills and competence. Our people are very well recognized also outside Europe, which means that the level of education, above all high-level education, is really at the top. I think that we are really very good already in that. The problem is, I mean, exactly what Teresa was saying. First is that we don't need only super expert in nuclear sector. We need to nuclearize these, for instance, civil engineers or chemical engineers or mechanical engineers, etc. We have to remember that for a nuclear project deployment, I'm talking about deployment, we need only 15% of nuclear engineers. The rest are people that they should know how to work in the nuclear sector. Even a civil engineer, I mean a civil building, it's also a shielding, this one. So I should know that there is radiation, neutron, gamma, and so on and so forth. So they don't need a very comprehensive understanding. But if we wanted to engage with the non-nuclear expert or non-nuclear young people, we have to be attractive, again, appealing. Otherwise, they have alternatives. Maybe a nuclear engineers have a few alternatives, but a civil engineers have many different options. And again, I come back to my previous point of consistency and reliability when we launch a project, and then also to retain the competencies. It's not only about to acquire new competencies, it's to retain. And retain, it means that, for instance, when we launch a project, a very long-lasting project of 10 years, and then we close that project, you know in my professional life, how many people, non-nuclear engineer working very effectively in a nuclear project, of course, at the second project abandoned the second, we say, well, you're not serious, okay? We have been working on that for 10 years, and then the project is cancelled for political reason or for commercial reason, and so on and so forth. If we wanted to embark people, above all people, outside the nuclear sector, and we do need very much for the things that Teresa was saying, we have to be consistent and reliable. It cannot happen that just for let's say, technical consideration, we close projects, we change our mind, say, oh, this was important, ADS was important, now it's no more important. Now move to fast reactor. Oh, fast reactor is the future of the nuclear sector. But no, now we move fast reactor to the second century because no, it's not very urgent now. These are very bad messages to involve young people and to retain the big competence, above all the non-nuclear skills. I mean, they're not completely expert of nuclear.
Okay. Francisco, for example, as the president of the NN Network Association, maybe you have some experience with this subject, I believe.
Okay, thank you very much. Our position to develop skills, build competencies, and preserve institutional knowledge is mainly for the university level is to develop job training with mixed teams, students, trainees. Knowledge can be shared through multiple mechanisms, but it's essential to build these teams also with industrial organization and also with other academia and research institutes. So for us, the main way to do this more attractive, to involve the best students and to compete with others industrial sectors, is to establish programs of mentorships, internships, mobility and other things that could attract the students to our sector. This is very important, and this is the NN position. In fact, inside the NN2+, we have developed a big effort to increase the mobility, to increase the access to the different research centers, and to try to allow the students, the new students, to know better what are the possibilities that they have in the sector. So this is a very useful way to develop that. Also, from the point of view of to preserve institutional knowledge, this morning was also mentioned in the previous panel. I think that now with the artificial intelligence and with the ontology methodologies, we can really try to improve the knowledge maintenance. There are now techniques that could be used to preserve the knowledge. I have been involved in the commissioning of the Sorita nuclear power plant from more than 30 years from now. At the beginning, it was not on the decommissioning state, but we have started to work with them. And for that, we have created a big database that now is going to be also dig with artificial intelligence tools that could help the new workers, the new people that arrives to the problem to know how the things were made many years ago. So, and this at the same time is another way to make more attractive our sector. Sometimes we are too traditional. Also, we need to preserve also the regulatory things, as you mentioned before. But at the same time, we have, in some cases, some possibilities that we need to increase. This is important.
Okay.
Yeah, sorry. Yeah, go on, please, if you have a question. Yeah. You can take one of the mics, yeah. I also have some questions online, but I will address them.
Thank you, Chairman, for giving a chance. And the facilitate ask to knowledge transfer. Somebody leaving, senior leaving soon, and how can knowledge transfer to the young people? His questions. Talking about university all kinds of written books, you can learn from written books. He mentioned about AI coming from written technology, not heuristic technology. We are talking about the critical knowledge and heuristic knowledge, on-the-table knowledge. If we have so many procedures in nuclear power plant, we learn from procedure. But this, we are not talking about this one. We are talking about the brain, heuristic knowledge. How can transfer heuristic knowledge? In my country, I am coming from Korea. We have a retirement age of 60. And the new people coming. We have 1,300 people working, and then maybe 500 or 600 people leaving soon. How can transfer last 30 years his knowledge? Okay, we have tons of books, reading books. This is the transfer? We don't think about that. And we hired for mentor. We give a special incentive, and you can teaching to mentee. And then I'm leaving next week, leaving from company, and then company asks to me, you are teaching from young people. I'm leaving next month. I'm very hurry to my life. How can I teaching people? Yep. This is really just for talking. If you want to really practically, as I mentioned before in our previous colleagues, you need for practical ones. I'm leaving next month in the company, and the company asks to me, oh, you are teaching young people. Did you accept? Everybody accept? Because I have a 20-year life, I'm thinking about after retire, I'm living 20 years. But the company asked to me, you are teaching young people. No, never done. Never done. Therefore, we give the special money, and I give the money to you are teaching young people.
That's interesting, because indeed, I think it's...
We have talking about the critical knowledge and the heuristic knowledge, not written knowledge. AI is good, but AI is only using for written knowledge.
Yep.
How can they take out my knowledge?
Transfer of knowledge it's interesting to see that transfer of knowledge is a big issue for everyone.
Yeah, I think I fully agree what has been said here, because I wanted to continue with that. For me, one thing is the repository and the data storage and so on, and AI and so. But what is important is actually sensible building of teams, where the young researcher can learn from experts and also from each other. I wanted to say the example from CVR, what we are doing also, that we are, for example, offering some financial reward for consultants who assist the students to finalize or successfully complete their thesis, So in this respect, there are teams which are helping each other and even they are encouraged, for example, financially. But definitely sensible building teams is essential for preserving the institutional knowledge.
Okay.
Thank you, Anna. We have a question?
Yeah, Tanya, please. Yeah.
Yes, I would like to ask panelists if they can say how many open positions you have at your institutes where the young careers they can apply. Please don't say I and Anna, just give me the number one by one, please. I can also say I'm social scientist. And we need social science also with CY because I must say that we are speaking now about the socio-technical aspects, and you have only one panelist with social science background who also provided a really competent answers. All the rest are from the personal experiences. And in social science, there is 0 position, even at our institute, 0 positions for young people that they would like to get employed in the nuclear, but 0 positions. So please give me the number, just the number. Thank you.
Nadia.
I can say we have 1 position open, and we had a student, a very brilliant girl, now just finishing a master's degree, but she decided that this is not for her, and she will go somewhere else. And we are very pity because we would need her. And I must say that I'm so happy that I can say that in September I got a new colleague, a lady one, a very hardworking physicist as well, and she's learning so fast you cannot believe it. She's in the middle of age, so she's not very young any longer, but at least I can transfer my knowledge to her, so I will be able to retire with relief. But it's very difficult really to find people to work in nuclear sector. Yeah.
What about the other panelists? Do you know how many positions you have? You have no idea. 0. Okay. Yeah.
No, I can give some data about that because I am also involved in the mining industry that has exactly the same problem that we have here in the nuclear sector. So now in Europe we have a big problem with the critical raw materials, and so for that, to increase our sovereignty and to increase our independence, we will need to reopen mines. And in this field, we have exactly the same problem that we had in the nuclear thing. So now we are looking after social specialists that could could make our activity much more transparent, much more easy to understand for the general society. So I think that in the case of a university as us, we don't have open position for that. Perhaps we could have open position for the people who is trying to attract more engineers or more scientists or more STEM careers to the university, but in general, the nuclear and also the mining industry is trying to employ new experts in these areas because it's critical. If not, we are not going to be able to convince the society, the general society, to the importance of our activity.
I'm really sorry, Francesco, but I'm going to echo Tanya's question. How many, give us a number, how many positions you have today?
In the university, we have around each year 5 or 6 positions. But,
okay.
But yeah. It's a big university, so it's not representative.
Yeah, so I can say in our group, which is a total of 32 people, since the beginning of the year until now, we have had 6 position openings, and we closed the last one yesterday, or was last week. Not yesterday, it was last week. And we are very happy that actually we managed to employ very young people, postdocs and PhD students, but we also have now coming a fresh number of trainees from programs in France, for instance, which are coming and being guest visitors in our group. So I can say that in Sweden we have had a clear rebirth of interest in nuclear sciences, and we also got a lot of projects. So yeah, that's the number from the beginning of the year until last week, 6.
Okay, I just quickly checked what the UJV group, where also Research Center Rzesz belongs to. So it's surprising, more than 20 positions there. I hope that they will not stone me, but it was just a quick look now on the internet. But I am aware that we are hiring, so you are very welcome all to come to Czech Republic and join the UJV group. And another thing, yeah, I can also say that in my new occupation, my new job, I will looking for colleagues, at least 3 to 4, so you are welcome to join the Ministry of Industry and Trade in Czech Republic.
Thank you, Jana.
Yeah, no.
Now I propose that we move a bit towards the other social aspects of reaching the youth, and not only the youth, but all of the stakeholders. So one of the factors that is often underestimated is communication and social engagement. And one thing that I've heard for the third day being here, every day we heard the people talking about gaining public trust. And my question to the panelists would be, what are your key recommendations to increase public engagement and foster trust and transparency in the nuclear sector?
Before I give you the floor, I just wanted to tell you about some of the questions that are completely related to this question. For example, one of the first questions we got is, as pointed out by your panelists, a career in nuclear field can... No, wait, sorry, that's not that one. What is it? Yeah. So, okay, I completely agree with the point that the new technologies are still mostly, despite the... Okay, it's not exactly well written. So basically, how can we make people be more interested in the nuclear, in a career into the nuclear sector, if most of these citizens are a little bit suspicious when it comes to the safety of nuclear facilities, especially in the context of wars and armed conflicts, for example. So basically, isn't it not the job of the political side to make it more attractive rather than the corporate world? And also this goes back then to the public trust. How can we engage with civil society groups, and how can we make them more trusty of what the nuclear sector can provide them with? Yeah, sorry, I'm just trying to... One last comment before giving you the floor, because I think we won't have enough time to tackle the last question. All of the questions you write in the chat, I will do my best to draft answers with the panelists and put them in the app so that they can be seen by everyone. I cannot make any promises because I have not discussed this with anyone yet. But I will do my best to do it that way. Please, if you have, so just to Lida, can you remind the questions, please? Yeah.
The question is, what are your key recommendations to increase public engagement and foster trust and transparency in the nuclear sector?
I guess
so, yes, you can
it's
start.
Me to answer this one. I think the most important is that recognition that responsible institution has to engage public and in this key starting points for nuclear projects. The transparency and openness has to be in place. The early and genuine public participation has to take floor. And that's the conditions to build and maintain trust. Without this, there is no possibility to start any new project, nuclear project, I say. So, why people are skeptical about that? It's because usually institutions do not follow this main, very basic principle. It's not a big science. It's just to have everything in place from very early, to stick on that and to follow it constantly and look at it, modify it, measure how it impacts, what kind of changes has to be implemented, and you do it from zero again. So this is very simple step. And I really believe that if any new project would follow this, they would be successful. By the way, I was involved in the site selection for repository, which is in fact a more difficult project than the MPP site selection. Yeah. And it took us around 15 years in total to get the site. And now the repository is in construction and it's not finished. But you know, we also learned that you need to stick to your word. You have to involve people. You have to provide the responses, and then you need to keep the promises, for example. These are some of the preconditions as well.
I have a little bit of a personal touch here because I live as I preach. I live 17 kilometers from one nuclear power plant. It's the biggest one in Sweden. And I'm also in the first exclusion zone, and I can tell you that we got so much information, and we have a tiny little machine at home which tells us every time when there is a drill. So it sounds in all the house. My daughter is looking around, and we know that it's a drill from the power plant, and this is going 50 kilometers around the nuclear power plant, and there are many villages there. And even if half of these villages are full with nuclear engineers because they work in the site, I mean, it is something which gives the people around the nuclear power plant the knowledge. We know what is happening. They tell us why it's happening, and the ones which we work in the sector, we can always answer anyone else which asks, what is this about? Why do we have to do that? They even had a drill with the kids in school, and they wanted to see how long time it takes to get 300 kids out from the school area. And they realized it was more than 1.5 hours. It was too long. And what happened was that we had an engineer, which was actually a civil engineer, and they realized that the parking place of the school was too narrow. The buses couldn't turn. So they had to modify the parking of the school so the buses could turn and get the kids out. So you see, this is real action. This is how you gain trust. And anyone, any country can do these small things, like to do a real stuff. And then just going back a little bit to the repository and apropos the humanistic sciences, how can you tell people in 500 years that this is a dangerous place? How can you tell? Because if I see a sign, which for us is clear, it's a symbol, I have no idea in 500 years that the little flower put there, which is also colored in nice colors, is not the sun sign, but it's a danger. Yeah. So that's the job of the humanists, to tell us how people can think in this long time. Yeah. My contribution to the question.
Stefano, I know that you will have to leave us in 7 minutes sharp, so I'm going to give you the floor.
Yeah, very quickly.
If you have to leave, feel free. I understand.
Yeah,
you have
yeah, thank you very much. Well, I'm not an expert, but we have been working on that, of course, now in our country, is that we are reconsidering, hopefully, the nuclear option. And of course, this is obviously in the critical path. As I would say that public engagement, communication, stakeholder engagement should be really the step zero of any nuclear program. It's not even worth to launch a nuclear program if this program will not be accepted by the public, because you risk even to invest a lot for nothing, and we have seen this issue. So the first of all, the first consideration is, again, I don't go into the core of discussion because I'm not an expert. But in my view, the perception of people is very different depending on who is delivering the message. There are stakeholders, okay, that they have a vested interest to sell a nuclear power plant or to operate the nuclear power plant. They have to make their part, but of course they have an interest. Okay, so in my view, we have to distinguish between the communication and the stakeholder engagement provided by these industrial stakeholders and what can be done at institutional level. in my view, the credibility is higher. For instance, the safety authority should be credible because they have an independent body. They don't have as a mission the fact to go nuclear for decarbonization or security of energy supply. It's not their stuff. They have to ensure that they have to supervise the safety of the reactor. So they should gain trust even with the public. And finally, I would say the nuclear societies should play a role because we are an unbiased and scientifically based organization. We don't have our stake. And I think that with this approach, we can really gain credibility vis-a-vis of the population and the different people involved. Very important, the local action, the ones mentioned by Teresa. And I would say, and this is a message to the European Commission, to collect systematically the lessons learned. In the north of Europe, we have a fantastic example, in Sweden, in Finland, very successful for very challenging project. So let's collect the lesson and let's try to replicate the successful cases that we have also in Europe.
Yeah. Philippe, this is something I think the committee plays a big role in. Basically, how can we make sure that, how can we build up public trust, or not confidence, trust in the institution and everything when it comes to nuclear? You, as someone who works with the trade unions and with the social and economic committee.
Yes, so it's a problem of trust, but trust, how to build trust? Trust by transparency, but so by participation. The key word is participation for me. So in addition to all what was said, and I agree, we can imagine what is doing in some countries, in France, but not perfectly, but it's done. It's to build councils of society, civil organizations at the national and local level. So we have a permanent institution for participation, like we have at the European level with the ESC. It's important because at this level, every stakeholder can participate and can debate, but what's necessary after that is that what they say has to be taken in account. It's not always the case. Sometimes the authorities say, okay, we want to hear you. They hear, but they not take in account. That's a problem. And at the last, don't forget union from nuclear sector and workers from nuclear sector are very good ambassadors of the sector. We have to mobilize them, to use them. They are voluntary to come and to explain what it is, what the reality is. It's not the devil, nuclear sector. It's something we can work in, we can live in. It's not a problem. So again and again, use the unions. Thank you.
Yeah, indeed. I think it's important to remind everyone that when you work in the nuclear sector, you actually trust the nuclear sector. But when you have never interacted with it, you are a little bit more afraid of it. So yeah, there's something there. Yeah, Francesco, can you tell us more about that, actually? Yeah.
I concede much with the things that has been said. I think that one of the most important things is to get involved with the local stakeholders and the local association from the beginning of any project in the nuclear sector. This is very important. We have learned that in the south part of Europe. We have learned a lot from the northern part, and we now are doing that. But it's very important to be transparent and to involve the people from the beginning.
Yeah. Okay. We don't have a lot of time, but still, I would like to ask my last question, and if the panelists could react to it, because this one is a concluding question. What would be, we had two big parts in our panel, on our topics. We had the skills and competences, the workforce, the young ones, how we attract them, how we afford opportunities for them, how we deal with the age gap and the transition between those who go on pension and those who are coming in. And the other part is public engagement, civil society. How can we engage with civil society groups and interact with them, because scientists and researchers do not exist outside of civil societies. So what would be your recommendations to international organizations and EC, for the European Commission, for example? What would be your key recommendations to be able to be more efficient on these two topics? And if you could just give me one recommendation per panelist, because I really don't have a lot of time. Yeah. Please, Philippe, you can start. Yeah.
I'm not sure I understand exactly the question.
One recommendation to us as
yes,
international organization.
my first recommendation for the Commission, what I would like is to the Commission say, okay, we intend to go over a single nuclear market. It needs a huge action in many, many directions. It's something very difficult because we are very far away from this situation. But I'm sure, I'm convinced we need that in the future. So the Commission has to work with this mind now to prepare the future. How can we build a single nuclear market?
Yeah.
How can we build it?
Yeah. One recommendation? Yeah.
I would say that one thing which is important is for EC is to embed transparency, stakeholder inclusion, and accountability in EU nuclear policy processes. So this is for me one of the most important things. You could also request the kind of citizen observatory or advisory group on nuclear to ensure that civil society perspective is implemented.
Just think that I really ran away. I make a general consideration. The European Commission in the recent, in the last 1-2 decades was very good in supporting and funding R&D activities. Okay, we have heard the results, magnificent results also in this conference. It was less active in what the nuclear sector needs for deployment. Come back again on this point. For instance, in Europe now we are discussing, we need harmonization among the safety regulators in order to harmonize the safety approach, the story of the common certification and so on and so forth. This is a very practical thing which needs money and real support, because the safety authority have something else to do. Okay, they have their work. If they are not paid, they will not do it. Okay. And then stakeholder engagement and communication. This is really weakly linked to R&D. Is something which is strictly related to deployment. So one of the very trivial recommendation is, first of all, let's collect the good cases and the lesson learned, the cases which were successful, the cases which were less successful. Of course, engaging with people who have these skills, which are not nuclear engineers like me. So the recommendation is to start a new program, also in view of SMR, AMR, which maybe have a different perception from population, etc. But looking at things from a deployment viewpoint instead of only R&D needs.
Okay.
Jana, please. And Stefano, yeah. Please, Stefano, you have to go, so yeah. And one last set of recommendations from our three panelists. Yeah, Jana, please.
From, let's say, more specific point of view, what I would like to stress, what is important for the development students, but also experts, in my view, are research infrastructures that we can actually do the research. And what is good example is the GRC open access infrastructure. So my message for the Commission is to maintain that and even connect with, for example, national programs, because in Czech we have the same. So to maintain the open access to research infrastructures, and what is connected to that from the INN part of view. Part is, for example, the INN mobility. So the students can apply for the mobility program and then visit and have hands-on experimental work in the open access research infrastructure. So this is my message.
Theodora?
Yeah, what I would like to say is that basically Euratom has been in the good and bad times with us. So many times the money coming from the Commission, they saved the research in certain countries where nuclear was not so popular anymore. So I think that one wish would be that you continue this type of work in good and bad places. But also I think that mobility is very important in Europe because we are going to build, we are going to do a lot of projects, but then we need to have the skilled work having the possibility to move around. And I think that we are aiming for this pact for skills, which is one goal, but I think it's also important that we have the stamp of Euratom and maybe European Commission for these people which are skilled, that they are able to move across Europe and help in different projects. So that's what I would like to see.
Facilitating mobility. Francesco, you have the last recommendation.
Okay, thank you. As mobility and access, open access has been already mentioned, I think that for me the only thing that remains is to insist to foster the European dimension from the school at the beginning. Education from the beginning, from the very early age is very important, because if not, when you arrive to be 15 or 16 years old, you are already vaccinated against some particular parts of the energy sector. So yeah, I think that from the beginning we need to work more. We need to work at the school level. Thank you.
Okay. To wrap it up, I think I need also to, because the coffee break already started, but I wanted maybe to remind the audience that we build the plenaries and the parallel in a way that the parallel session that will follow in 20 minutes or so are spin-offs. So the parallel session that will follow here will tackle these social, ethical, and cultural aspects. Then you will have the skills and competences in that room, and the last room will highlight the success stories and what we did best over the last 3 years and even decades in that room. If you need to access the session 3.3, you have to either cross the other one all the way up, or you have to sneak in the other side. So I know it's not easily accessible, but that's the way we did it. Another thing I wanted to tell you before you rush to the coffee break, I should have done that since Monday, but we will be displaying the slides that you have on the app with all of the Euratom projects in all of the screens during the coffee breaks and during the lunch breaks, so that we can promote a little bit more what we did over the last 3 years within Euratom. FISA EURADWASTE is also about highlighting what we did with the contributors' money, with the European citizens' money, because that's actually your money that you invest in our research. So during the coffee breaks and lunch breaks, please have a look at the slide that will roll on the screens, that you might find your projects also highlighted during these coffee breaks. Other than that, as I promised, half promised, I will try to address all of the questions on the chat, and we'll try to compile them and provide you with answers. Thank you again, and hopefully you will enjoy the rest of the events.
Thank you.
And thank you, Lydia, as well.
Thank you
for accommodating with me.
inviting me.
Yeah. And thank you for the panelists.
Thank you.
Yeah.
space. Here are the pioneers seen off by some of the thousands who contributed to the maiden voyage. Man is stepping into the unknown world with caution. Only moments left before the start.
Mirto. Could we please have the cover slide up for this session?
Not cool.
Okay, the audience is not quite easy.
Tu vas être bronzé à la fin.
Okay, so let's make a start, and hopefully more people will gradually come in and join the session as they hear us from out there, so we'll leave the door open. Welcome everyone, and a big thank you to the European Commission and the Polish presidency for organizing this fantastic event. In case you don't know me, my name is Jessica Johnson. I'm the Communications and Advocacy Director at Nuclear Europe, and I'm very delighted to present my co-moderator for this session, Ugo Bernat, who is here representing the Young Generation Network and who is also a mechanical engineer at Tractebel. So as you have probably seen, we have a 2-hour panel, which seems quite long, but the topic is also extremely vast. So we have a lot of things to cover during this session. One point to make, there will be some audience interactions through polls. We will be using the Mentimeter poll. Normally, if you go into the event app and you go into this session, you should be able to access the poll from your mobile phone. If you can't see the poll, refresh the app. It may be a bit of a time delay on that. By addressing social, ethical, and cultural factors, Europe can effectively transition to a carbon-neutral economy that is inclusive, just, and sustainable. Key considerations and strategies must ensure a comprehensive and inclusive approach. If we can quickly put up the next slide. As you can see here on the screen, and it's coming back to the point that I was making earlier about the broadness of this parallel session, SDGs really do cover a wide range of social and societal aspects, several of which nuclear could potentially contribute. And now I'd like to hand over to Ugo so he can present
our distinguished speakers for this session.
Well, thank you, Jessica, for presenting the topic to our attendees as well for the kind introduction. It's my pleasure now to return the favor and introduce our esteemed panelists. Let's start from your left with Tanja Perko, who is a researcher at SCK-CEN, which is the Belgian Nuclear Research Center. She also represents the European Platform for Social Science and Humanities in Ionizing Radiation Research. Next to her, you will find Florian Rauser, who is the Vice President of the Federal Office for Radiation Protection in Germany. Then we'll have Emilia Janisch, who is representing today the Clean Air Task Force, among her other roles. Myrto Tripathi, the President of the Voices of Nuclear, Les Voix du Nucléaire in France. And finally, Elena Mastantuono, who is the Vice President of the Transport, Energy, Infrastructure and the Information Society section, also known as TEN, of the European Economic and Social Committee. And with that, I'm handing it back to you, Jessica.
Thank you, Ugo. And I think this is an opportunity because we do have a young generation representative here on the panel. So before we give the floor to our different panelists, maybe I have a quick question for you. Could you tell us what SDGs are a priority for the young generation today?
Of course, yeah. I put a lot of thoughts into that, Jessica. And of course, they're all important, right? We all dream about a world with zero hunger and zero poverty. But thinking about the young generation, I think we're really worried about the future, and that starts from an early age. So I think the SDG quality education is something that youth are really concerned about. We've been talking at this conference about the growing gap between the industry needs as well as the amount of people graduating, and we really need to increase the amount of people with relevant skills to succeed in that transition. But that goes beyond high skills. There are a lot of people across the world who don't even have access to basic education, and as youth we really support that we should be able to provide it to everyone. But not only that education, but also the safe environment that goes with it for them to succeed. I would also like to add on the question from Tanja during the previous session, is that it's not only about education, but also what goes after. So I don't exactly remember which SDG it is represented by, but I think we also need to develop the amount of jobs that we can give to those young people. And finally, this is a personal reflection, is the SDG partnerships for the goals. We share a lot of ideas during those conferences that are really interesting, and this is a really safe place to share them. I had the chance to attend COP29 in Baku, Azerbaijan, and it was mentioned as a disappointing COP because it didn't find the ways to finance the solutions, the agreements that were signed in Dubai at the previous COP. So yeah, as youth, I'm really concerned about how do we implement all those things we're talking about right now. So I'm really looking forward for new partnerships to achieve the goals.
Thank you. Indeed, I was not in Baku, but I was in Dubai, and I have to say there was an awful lot of enthusiasm around changing things. Let's now head over to our different panelists, and we'd like to invite you to give a short introductory statement around, I think, more or less 5 minutes. Audience, please be prepared to ask any questions. We're going to make sure there's plenty of time for you to ask questions to our different panelists. But maybe, Tanja, let's kick off with you.
With a great pleasure. Thank you so much. Good afternoon. Are you okay? Yeah, okay. I will try to entertain you a bit. So, in general, it's a real pleasure that I'm here and that I can speak about the topic which is really close to me. Not only professionally, but it's also in my heart. Societal, ethical, and cultural aspects of the nuclear technology and how these aspects are connected with sustainability development goals. Why is this so close to me? Because we believe that there is no only technical subject, but everything is socio-technical. And how SDGs are achieved and how they are connected is these are human topics, and they don't ask us only what we do, but also how we do it and why we do it. And this is SDGs. So let's take just a moment together to reflect what the SDGs means for us. So I would like to ask you to join me in this short exercise, so be ready to listen me really carefully. So I would like that those people in the audience, but also on the stage, because we are so few here inside, that you stand up if your organization has made any public commitment or statement related to Sustainable Development Goals, any kind of statement. Can you stand up? Those people that any kind of statement that your organization has. Okay, nice. Please stay up. Nadia, stay up. Because I would like to see one effect now. So now I would like that you keep standing up if you think that your colleagues in your organization know exactly what kind of tasks, what kind of activities your organization is, wants to do to achieve the Sustainable Development Goals. If you don't think that your colleagues, they don't know, please sit down. Okay. And now, those things that you are still up, or again up, I would like that you stay up if you know how your organization is tracking, measure, and report about the Sustainable Development Goals. Okay. So this is, this was not a test. Thank you so much. You can sit down, those two people that they kept standing. But this was not a test. This was just a small reflection about the Sustainable Development Goals. Why I did it? Because Sustainable Development Goals and sustainability is constantly present in our language. They appear in our reports. They appear in our mission statements and also on slides. But when we look into the clear actions, real responsibility and also personal engagement into the Sustainable Development Goals, the picture is less strong as we would expect. And this session today, we were invited to contribute to this session today to look what is going on with this gap between our attitudes, our expectations, our desires, and the real behavior towards the Sustainable Development Goals in practice. So these Sustainable Development Goals and sustainability includes how we speak, how we listen, how we decide, and how we understand value and responsibility of nuclear technology, especially in development of nuclear technologies. Sustainability is not only about low CO2 emission that nuclear technology is promising, but it's also about every big and small actions that we do during the day, during our activities. Big actions, for instance, like building renewable energy infrastructure, for example, or small actions, for instance, but still important choices. How did we travel here to Warsaw? Also the small action, for instance, what kind of food are we going to eat this evening? All this contributes to sustainability and to Sustainable Development Goals. Sustainability is not just about changing a slogan to say nuclear is low CO2. It's about changing our mindset. And this session will speak today about this, I hope. And why I was invited here, I believe, is because I come from SHARE. This is a social science and humanities platform for research on ionizing radiation. And I also work at Belgium Nuclear Research Center. And in these two organizations, we study how the nuclear community is adapting economic, social, and also environmental sustainability. I showed the economic, social, and environmental sustainability. So we studied this with the support of European Commission. Today, for instance, I'm here under, is Saif here, on the budget of HARPES project. where we studied how the sustainability is connected to circular economy, but I also work in the EcoSense, in Catapult, and some other projects. So what did we find? What did we find in these projects is that the positive attitudes towards sustainability in nuclear community are really present. We found out that there are also quite some good practices related to sustainability in nuclear field. But we also found a huge gap between the awareness, attitude, and the behavior. For instance, what does it mean? Attitude, awareness means that you know and the people know what sustainability is, being aware of it. That attitude is, for instance, that your organization supports sustainability, but real behavior is action, that you do something about this. And positive attitudes towards sustainability in the nuclear field and also in other fields doesn't mean necessary that people will also apply, that they will behave sustainable. So this gap is well known in social psychology and in psychology, and it doesn't appear only in the nuclear field, but it's widely outside there, in Europe, in world, but also among your customers. So the people, they may know also about the nuclear technology, they may agree that nuclear technology helps in the sustainable development goals or sustainability, but will they support nuclear build, for instance, in their village or in their home? Will they take action? So this is why it's so important that we allow social sciences to study these things. Experts in psychology, ethnography, political science, and sociology, and so on, we provide theory-based and evidence-based insights also for Euratom. And there are a lot of results that they are already available, but we need to start using them. So we found out that the key to close the gap between the awareness, attitudes, and the behavior is really simple. It's one, collaboration, working together. The solution is not to promote or to advocate for the nuclear, but to collaborate. The solution is honest and transparent engagement. Nuclear community must move from the managing stakeholders or educating stakeholders to partnership approach with the stakeholders. And partnering with stakeholders, the nuclear is not only accustomed to also to those that the nuclear is not accustomed to them. So those that they maybe will have critical and opposing positions. Ethical use of nuclear science in SDG, related to SDG involves transparency, public participation, and constant aligning with goals around inclusive institutions, reduced inequalities, and intergenerational equality. Technological solutions might be guided by values of justice, sustainability, and the right of communities to shape their own future. Only then, but only then, we can truly collaboratively meet the goals of the sustainability, especially SDG 17. Do you know what is SDG 17? Somebody knows? Which is partnership for the goals. So thank you so much.
Thank you very much. And yes, very useful insight. As you said, we need to walk the talk, not just as organizations, but also individuals. And particularly in Europe, we have a tendency to focus on the environmental aspects of sustainability, but the economic and the social are equally important. So great kickoff to this session. Maybe now we can come to you, Florian, if you could make a short, max 7 minutes introduction. Thanks.
Yeah, I will try. Hi, everyone, and a personal high five to everyone who joins us in this session, actually, because we are not so many people. I wanted just to get my notes going. So I'm really happy to be here today, as well as Tanya said, because I think the topic is really important and it's also very broad. It actually encompasses everything that has been talked in this room in the last 2 days already, because it bridges everything from social to ethics to economic to environmental to energy. And for me personally, that is also, it's it's something of a, human achievement that we are able to show these 17 goals on that slide. Because in 2015, when the SDGs as part of the Agenda 2030 were published or decided upon in the General Assembly, that was the first time that all countries agreed upon these 17 goal dimensions, even if we didn't agree on concrete indicators for all 17 dimensions with all the countries, obviously. We agreed that a solution space for sustainable development has to think about all of these 17 dimensions at the same time. And so this means for the SDGs that they are as individual as all our countries are. It's not like we don't have a specific SDG or an SDG priority which every country or person in this room will agree upon. It's national and it reflects national status quo and national ambitions and national reflections on the importance of those topics. But all countries agreed about the overall importance to talk about this. And it was the first time actually in the UN context that also the developed countries, the Western world, decided that we are not finished. It's a continuous improvement process towards sustainability. It's not something where we can just say poorer countries have to look at ABC, no poverty, no hunger. But it's also up to us in the global north or west, or however you want to call it, to actually talk and think about sustainable development. So this means three things. A, as I said, they are individual per country. It's not something all of us can agree upon, and also the national indicators and action plans are individual. B, there are conflict of goals. It's easy to say we want to fight hunger, we want to have zero hunger, but then it might collide with life below water or life on land in specific countries. Or you say it's easy that we want to have clean energy for climate action, but it might collide with the no poverty or the industry aspects in specific countries. So it's not an easy check-by-check, step-by-step process that we as humanity, as the world, can achieve the SDGs. It's a framework where every step, every progress that we want to make, we have to check if this is also sustainable with respect to the other dimensions. And this is like a quality management kind of perspective. It's a continuous process. Every country agreed upon targets for 2030, the Agenda 2030. So now we're 10 years in. I don't know if you all know your nationality indicator progress runs. Some of those have been unfortunately very much reversed through the corona pandemic across the world. But still we progressed a lot with respect to 2015, and we are now in the progress to actually think about the goal or the goal system that will follow in the future. What does this mean for nuclear? So just a few words on my role here, or my perspective on this is I'm, as the moderator so kindly introduced, I'm the Vice President or Deputy General Director of the Federal Agency for Radiation Protection, where we do lots of stuff radiation protection related, from emergency preparedness to natural radiation to medical exposure to UV to EMF to blue light. So it's a wide range of topics, and many of them interact with different sets of SDGs. So for example, I think the health and, I don't see it right now, but the health SDG is something that's very close to our heart as well, not only the energy or climate action SDG. And it's important for us in the radiation protection community to see our impacts on competitiveness, on industry, on medical, besides the energy sector, which is obviously the most important focus of this conference. I'm also the head of the work package on stakeholder engagement and Pianoforte, which has been so kindly mentioned by Domenico in the opening yesterday, which is the Partnership for Radiation Protection Research, and which is historically not so deeply embedded in these FISA, EURADWASTE, SNETP conferences, but where we try to actually integrate the Euratom research a bit more, because we think that all the ambitious and necessary goals of this community here in Warsaw and of the last couple of years can only be sustainably achieved if we go hand in hand with radiation protection aspects. And so we are very thankful that in this conference the radiation protection aspects have been mentioned as well. And I personally, I'm a physicist and did my PhD in climate science, and I worked 15 years around the creation of the SDGs with respect to SDG 13, the climate action and clean energy aspects. So I'm very happy to see now the other side of it. I just want to highlight two things for our discussion today. Is the first thing, it's not just a label. We should not think of SDGs as a greenwashing, something we can just stamp on our ongoing activities like nuclear energy or radiation protection and say, now you see it's sustainable development. That's not true. It should be a thinking framework for ourselves to think about the consequences that our progress has in the other dimensions of sustainable development. And some of this has been ongoing in the nuclear community for years, you know. The aspect of clean energy production in nuclear with respect to circular economy and long-term storage, for example, is some discussion that has been ongoing for decades, longer than the SDGs exist. So it's not something we have to tell people, it's something we do now new as part of the SDGs, but we have to explain that this community has lots of experience in connecting those conflicting goals in this dimension or this silo of energy production, and that we can teach other communities to actually do this connection and learn from the nuclear energy community. So I'm genuinely looking forward to the discussion with you and the distinguished podium today, and I hope that we can enhance our understanding of what the SDGs mean for nuclear in Europe, in our countries, across our countries, and that I can personally underscore a bit the radiation protection dimension of the SDGs that, as we think, helps to connect nuclear with a few more of the SDGs than just energy alone. And I finished with what I started. The SDGs are individual, they are national indicators as unique as our countries are, but I think we can find strength in this diversity and create sustainable progress in nuclear for all of us. Thank you.
Thank you very much, Florian. And it's also good to hear you start with that positive message to say, yes, they have the targets, they've got the SDGs, not everybody can achieve everything straight away, but positive progress is being made. So I think it's a great message to be hearing. We are taking steps in the right direction, but also the fact that you've mentioned this, you really need to engage with such a broad range of stakeholders. Probably today, not all of us are aware of where nuclear contributes to this and the different actors that are involved. So I think that's also a really great message that you've put forward on that. May we head now over to you, Emilia?
Yes, hello everyone. My name is Emilia Janisz. I'm from Poland, so I'm super excited that we meet in Warsaw. The FISA conference brings really a lot of familiar faces together to discuss a lot of important things, including SDGs and how nuclear contributes to it. I spent 12 years in Brussels as an active advocate for nuclear at the European Nuclear Society. Then I jumped out for 1 year and I'm back in nuclear business with Clean Air Task Force. With the pleasure, I listened to also the previous panelists about sustainable goals, that they are not really only labels. And this is what I see also observe at the Polish ground after 21 years being abroad, coming back to my home country, discovering how many companies are really involving SDGs actively in their strategies, and also the ministries of Poland talking aloud about the decarbonization of the country. Why many of you think that Poland is really based on coal, it is still true, but it's reducing the electricity run by coal every year. So we are really phasing out of coal. And I see really the huge progress happening over the last 10 years towards decarbonized energy mix with nuclear as well. So what Clean Air Task Force is doing, also my affiliation that I'm linked with, maybe I will tell you a few words if you are not familiar with. So Clean Air Task Force was founded in 1996, and this is an international organization hiring 130 people, experts, scientists, those who really focus and run scientific analysis on how to decarbonize the energy mix globally. I'm focusing on Central and Eastern part of Europe, obviously. And so it's really one of the important strategy that we are focusing is really to see the social impact by fossil fuels. And this was really always at the core of the Clean Air Task Force actions. Access to clean air is a fundamental right for every person from Europe, from Asia, from America, from all continents. And this is obviously in line with the SDGs. So in line with the SDGs, we enact emission limits on power plants, whether fired by natural gas or coal. We press for intensives for commercial deployment of technologies that can eliminate carbon emissions from energy sector, attack greenhouse gas emission and climate damaging emissions. We are also focusing on reducing health impacting pollution by strengthening air quality and emission standards. And this is what we see, that the high energy demand that is increasing every year is possible to reach at an affordable cost. So all the low carbon technologies can be introduced on the affordable way if we really change a bit the mechanism and incentives for the low carbon technologies. Thank you.
Thank you very much, Emilia. And indeed, the name of the organisation representing it is very clear. It's linked to that clean air SDG. It's also linked to the health SDG as well. So, Mirto, let's head to you next.
Thank you very much, Jessica and Hugo. Thank you, all of you, to be here, and to the European Commission and Polish presidency. It's a great event, and we're very happy to be on this side of the European Union continent. Just a very rapid few words on what the voices of nuclear are, and I'm going to take this away because I think it prevents you from understanding better. It's a European NGO, a citizens organization that I founded and preside since 2018. And it's actually all volunteers, including myself here today. So we're citizens, and the way we see ourselves, in a sense, is as a consumer organizations. We are citizens that want to benefit from nuclear energy. We actually demand to benefit from nuclear energy. And there's two ways in which we do that. The first one is that we act as to ensure the project environment is favorable to the nuclear industry and the nuclear project. It has all the means and ways to perform at its best. The second way we do it is to make sure it does perform at its best. So we are a counterpart that's expert, that's independent, that's benevolent and constructive, but that's demanding as well. That puts us aside the more traditional environmental NGOs that generally tend to want to kill the industry, which we don't find it very constructive and probably not the best way to make sure it performs as it should. So that was for the very quick introduction, but that's important because considering we take this topic from the benefits side, by definition, we take the topic from the SDGs side. We want to know at every single one of those 17 SDGs how nuclear contribute to it, how it should contribute to it, how we can help it contribute to it. So my statement is going to be on sharing with you my experience feedback from those past 7 to 10 years, being in the advocate part of the nuclear field and ecosystem. My experience feedback is firstly that if we do not account in our actions for simultaneously environment, climate, and humanity, being well-being and prosperity of the people, we fail. If one of those dimensions is not taken into account, then it bites us back. It inevitably, whatever technology we pursue, whatever objective we pursue as individuals or as states or as the international community as a whole, if we forget one of those three dimensions, it's going to fail. So we have to make sure we pursue those 3 dimensions simultaneously and do not tend to follow one while forgetting the others. The second very important experience feedback is we hear a whole lot about collective responsibility. Everyone is looking at what our responsibilities altogether are. What I find is that we tend to forget about our individual responsibilities, looking at other ones and what they should do and what we expect them to do and what we call for them to do, and forgetting to present and propose and contribute ourselves to what is our contribution to this. So that leads to a lot of finger-pointing, defiance in society, scapegoating, which is very much helped, I agree, with the newfound ways the social networks and the media and the influence are having in our lives and in our ways of communicating are influencing that a lot, I agree. But still, despite that, there is a responsibility that we have ourselves as individuals. And that responsibility I can deliver in a couple sub-points. The first one, and that's how I address the people external from the nuclear industry, to which I advocate for nuclear. The first one, our first responsibility, is to get our facts straight. We have to fight our own cognitive bias. Nuclear and the environment and the energy transition are topics relating to physics and biology. Those are sciences that are rather easy to confirm facts with. Not always easy, but certainly much easier than everything that's social, cultural, or economic. So we should hold it as a responsibility for us to at least make sure that in those domains, whatever we pursue as opinions are based on actual facts, and we should put that forward to the people as well. The second point is that we need to remember, even as the nuclear industry or ecosystem, that all low-carbon energies are necessary. I live in a field and I work in a field of advocacy for energy transition where either people are pro-renewable, anti-nuclear, or people are pro-nuclear and anti-nuclear, pro-renewables, and when you scratch a little bit the surface, you find one of those profiles. So we need collectively to remember that all low-carbon technologies are absolutely required because of the scale of the change and because of the speed required to make that change. The second one is that we need, so not only to think about everything, but we need to have everything come as soon as possible. We need it now. And now is the only way to treat the long term. We have to remember that because of the climate tipping points, a gram of CO2 avoided today is more important than a gram of CO2 avoided tomorrow, which makes nuclear very important because we don't have time to change society before avoiding to change the climate. If we want the possibility left to fight all fights, all those SDG fights, we have to fight this fight first. And nuclear is the only, and we'll say that again over the panel, I'm sure, it's today the only form of energy that can actually and effectively and everywhere displace fossil fuels. It's something that physics tell us. It's not my opinion, it's not political, it's not economics, it's physics. We only have nuclear to displace fossil fuels everywhere. And that's our, for once, collective and individual responsibility in this room. And the last point I want to make is we need it everywhere. And this will also, I tell you now, my last statement when I'll be asked for one, it will be this one again. It is needed everywhere, which means that countries that are capable of doing nuclear and hydro and geothermal, although it's less available and abundant, have a responsibility to deploy it. I don't care if they prefer to go more intermittent renewables or if they have preferences, cultural preferences. The reality is the industrial capacities to go low carbon worldwide are not so much. So the countries that have the topography to, I'm sorry to say it so bluntly, but to drown valleys have to do it for the sake of the others. The countries that have or adapted to and have the capacity of go nuclear have to go nuclear as a responsibility to others, so we can free wind and solar capacities that are needed everywhere where nuclear and hydro are not so easily and readily available. It is not a question of choosing one over the other, it's a question of sharing the resource of low carbon energy capacities. And I will end on this, because I really think it's one of the most important messages we need to hear ourselves and then carry over. Thank you.
Thank you very much, Mirto, and thank you for repeating that we need to include all the low carbon energy sources together with nuclear if we want to face the challenge of tomorrow. And I will use this opportunity to quote Nuclear for Climate that you know very well, that says, together is better. Okay, Alena, would you like to continue the introduction statements before we dive into our first conversation?
So good afternoon to everyone. Happy to see you. You're still here. You have a lot of energy on the third day in the afternoon. And it's not certainly easy for me to speak after so many speakers. So I will have to pick up what hasn't been said till now yet. But first of all, thanks to the Polish presidency and to the European Commission for the invitation. I'm a member of the European Economic Social Committee, which is an advisory body to the EU institutions, the Commission, Council and the Parliament. And our role is to comment on EU initiatives and also to say what kind of topics could be addressed at EU level. So my role today is also to listen to the speakers, but also to you, to the participants, and bring it back to Brussels in order to see where this could fit in EU legislative process. So, of course, we have heard a lot. There is no doubt we need to reach the SDGs. We need to adapt to climate change. But the question is not whether, but how, and how to do it in an inclusive way. And we have heard many times sustainability. Sustainability walks on three legs: economic, social, and environmental. These three are certainly vital, but I think the most critical today is just security. And this, we haven't mentioned it very much, but I think it really deserves to speak about in this unpredictable and unstable world. And we can also mention the blackout in Spain, but also the fact that the energy can become a weapon, and I think Mr. Putin reminded us. So yes, we live in these times, and I think the resilience must become a top priority. So we have the SDGs, but we also have to know what is the reality in order to reach them. We are becoming interconnected, and we have to be prepared because we might be more vulnerable than before. So, as I mentioned, the security, we also tackled this topic in the ESC opinion several times, and I think we can even develop a bit on that further. And the second topic we stressed in the ESC as a civil society is definitely, yes, we need stable, low carbon energy, but at affordable prices. So we really need the energy which will ensure that everyone has the access to energy. And still today we have 2 or 3 times higher energy prices in Europe than our competitors in the whole world. So it's not only a challenge for businesses, but certainly for households on this continent. And this year the energy remains one of the top 3 drivers of inflation in the euro area. So the cost of energy combined with the pressure of the green transition can have serious consequences for energy-intensive sectors and specific regions. And delocalization and industrial shutdowns can result in massive job losses, and we have talked about this as well. So that's why it's essential to ensure that each step in the transition is taken only when alternatives are in place, and that we look for solutions that safeguard local economies and foster continued growth. And I'm happy we are in Poland, and it has been already mentioned, Poland plans to build a nuclear power station in coal regions. Myself, I'm also coming from a coal region from the Czech Republic. And I remember when I was a child, I had to wear a mask during the winter because we could not breathe. And I think for local communities living in these regions, it's really necessary to transit to clean energies. And how also to ensure that these jobs are not lost, because we have to be aware of that the entire region sometimes is really built on such industry or on mining or on heavy industry such as steel industry which needs coal. And how do you explain to people whose fathers, grandfathers used to be in such a sector, you know, for 100 years. They were also recognized, and I think especially in Poland, they also have a recognized role because they were fighting against communist regime. So how do you tell them that now they have to switch to something else? So I really much welcome the decision. Poland, the way it wants to go is that it wants to build the nuclear power plants in these regions in order to allow people to switch from one industry to another. And as it has been mentioned several times, it's not only about the engineers, nuclear engineers, but you have a lot of professions around that for construction, logistics, but also cleaning, catering, etc. So when we are reaching these SDGs, it has been mentioned several times, we also need to involve the people, the stakeholders, because we need to ensure that this transition is well understood and that no one is left behind. So equally important is public consultation, so we need local buy-in to ensure acceptance of new projects. And this applies not only for nuclear, but also for renewables. I can see that there is a certain resistance for these new technologies. I remember the case in the Czech Republic, but also in France, that the Belgian coast, the Belgian citizens were critical to the projects of building offshores in France. So you see the resistance of people to something what is new, and we definitely need to explain why we do it and explain also the pros and cons. So involving a broad spectrum of civil society in decisions about siting, technology or waste management helps ensure that diverse views are taken into account, and this leads to more balanced, transparent and accepted outcomes. And I will leave you with this, and I'm looking forward to the discussion.
Oh, Mirto, you want to say something maybe? Oh no, you forgot something. Well, thank you very much, Alena, for this statement. We really understand that the ESC work is really closely related to the SDGs with what you mentioned, for instance, affordable energy, low carbon, so it really takes into account all of these topics. Now, thank you very much, dear panelists, for those meaningful statements. I propose to dive into our first discussion, which will be dedicated to the environmental and economic perspective. So it will especially focus on circular economy, as well as tackling climate change, affordability and access to energy, and carbon pricing and tax incentives. So my first question will actually be directed to Tanya, but feel free to comment, other panelists, if you have ideas along the way. So, Tanya, in what ways can nuclear technologies be designed or adapted to align more closely with circular economy principles?
Okay. I will here refer most of the discussion to the one wonderful project, HARPES, which is also Euratom project, where we investigated circular economy in relation to sustainability, but more closely for the decommissioning and waste management. However, what it comes out, but what we also know from the other activities, is that in the nuclear field, through the whole fuel cycle, there is still too much or mostly dominant linear economy, and the circular economy is not applied yet as much as it could be. Of course, there are good practices, there are good examples where they do this, but mostly not. And what we found out is also that the biggest obstacle sometimes are legal obstacles. Because the laws, they don't allow to reuse the things that they have been before applied in the nuclear field. But let's go step by step. So in the HARPES project, where we also have here coordinator, Silke is there, and Reka, and people that they know more than I do about these things, we investigated what the circular economy means in the nuclear field. We found out, social scientists again, that everybody has something different in their head. And we needed to do quite a lot of workshops and Delphi studies to arrive to the agreed definition of circular economy. So now we have it, and it relates to the thing in the nuclear are built so that they can be at some point refurbished, reused, repurposed, or shared. So, and then it depends on which aspect, which installation, and so on. But really, we need to think before we build we often refer to from the cradle to grave. We should not use this anymore, because it's not the purpose that it goes to the grave something, but the purpose is that it can be reused or repurposed or shared or refurbished. And in the HARPES project, we identified which domains the circular economy needs to be considered when we do a new build or when we do the decommissioning or whatever. And these domains are societal, environmental, safety domain, economic, and the legal. And for each domain, we develop the indicators and the measurements that we can say, okay, this is a circular economy or is it not? And for instance, for social dimension, we have, for instance, the measurement is the shifts in the infrastructure, whether the infrastructure has been planned so that at some point can be shifted to something else. Library, I don't know, a sports center, a factory, whatever. Then the impact on the landscape, participation in decision making. For instance, do we give the opportunities to express different views? Do we include diversity? Who did we exclude? Why did we exclude? And so on. For instance, the impact on local knowledge and skills. We discussed about this today. Impact on traffic, impact of local values and cultural practices. Really important. Restriction on the future land use. So all this is only one dimension, but there are for each of these dimensions we develop in HARPES the indicators which we need to have in our head when we are citing, developing a new installation. Especially this is now relevant for the SMRs, for instance. Thank you.
Yes, Emilia, you want to comment, but thank you, Tanya, for those words, and we really understand that circular economy needs a lot of thinking ahead, and we need to include it in the future constructions. Emilia, yeah, a comment.
Yes, thank you, Tanya, for this definition. Indeed, I think it's everybody has its own definition, and the definition of circular economy from CATF point of view is it's really to minimize the waste and maximize resource use efficiency. So I think this is what we propose to the stakeholders, really looking at especially in the SMR's case, to plan better how the design will be developed, so to minimize really especially later the large components what will be ordered, that's to make it more in efficient way. So for example, building the SMRs in a fleet mode where we know exactly what the design will be developed, and where a couple of investors are coming together and order a similar SMRs designs and order together the big components, it will already minimize the costs and also maximize the efficiency. I mentioned also the careful design and processes, and also we know that up to 90% of non-radioactive materials, concrete and also work clothing, could be actually reused. So this reuse purpose, I think, in the nuclear context is very important.
Okay, thank you, Emilia. Myrto, I see that you might want to add something. Maybe we can go real quick. Otherwise, we'll continue on the circular economy with the next question. So yeah, please feel free to share first.
I will be very quick. I wanted to emphasize that there's two aspects to this question. The first aspect is how nuclear contributes to circular economy, and the second aspect is how it is circular itself. So how it contributes to the circular economy is that we have to remember that having a circular economy, mining the urban mine, as we often say, recycling, reusing, repurposing, requires a lot of energy. Just fabricating e-fuels requires carbon capture, carbon storage, fabrication of hydrogen, and then into e-fuels. And this is very, very energy intensive. So nuclear is the one way with minimal environmental externalities and climate change impact to provide the energy that the overall circular economy needs. That's the first thing. And the second thing, which is nuclear circular itself, it's not quite there yet, but it has all the potentiality to do it. First, because it's super dense. So it's the definition of doing more with less, right? The density of nuclear is let's do more with as little as possible because of the density of the uranium. But then we have in front of us a sequence of technologies. They're going to be Gen 2 today. We tend to forget. Gen 2 is very well functioning. Gen 3 coming up, Gen 4, fusion at the end. We have a perspective into the future of nuclear becoming more and more included within the overall natural ecosystem because it has the physics potentiality to do it. And just to finalize on it, the last way that nuclear as such is contributing to circular economy and to overall reducing the environmental externality, which was a part of your question. It's, of course, in this room, you all know that nuclear has the less environmental impacts of all other energy available sources. I know it was a potentiality question at the earlier panel. It's actually a fact. And it's interesting because it's in all aspects of environmental impact. So we know about climate, we know about consumption of water, we know about land use, which are very important angles, but we also have human toxicity, abiotic depletion, ozone layer depletion, terrestrial and marine aquatic toxicity, eutrophication, acidification, photochemical oxidation. That last one, I don't even know what it is. To tell you the truth. So it is impressive, the contribution of nuclear to preservation of the environment and to leading to the circular future. Thank you.
Yeah, thank you very much, Myrto, and thank you also for remembering us that circular economy is not free, as you said. It requires a lot of energy, and that's where nuclear, I think, has a key role to play. Elena, you wanted maybe to add something, but maybe real quick so we can go also to the other questions after that. And we would like to give the opportunity to the audience to also participate a lot on this session.
Yeah, just to small things, and I agree we have to look at the carbon print. So it's not only we can reprocess, but at what costs? I mean, what kind of energy we produce at the same time. But has been said there are some legal challenges, but there are technical challenges, but also financial. I remember when I was in Finland, I visited the deep geological repository, and then I asked why you do not reprocess, and they said because it's more expensive. It's more expensive than to dig down to have a deep geological repository. So we have scientists, physicists, I'm economists, so I rather look at the price, and it really was striking to hear that. But I completely agree, we really have to look of how to reduce the waste, but we could also look at it from another point of view, how other sectors can benefit from it. There are also byproducts, like the heating. It hasn't been mentioned, but I think it's part of it, how to use the heat from the nuclear industry. And what we also have recommended when we were working on an opinion on the radioactive waste management, we also said that also look at what the member states are doing. If everyone has to have a deep geological repository, it doesn't make sense. I mean, yes, not all the member states produce the energy from nuclear. However, all the member states of the EU generate radioactive waste. But it doesn't mean that they need to have a geological repository. We said work together, work on a shared solution, because in this respect you can also reduce the material that you want to use. So I think we have to have a more global approach to this, to look on how we can cooperate, how we can have shared solutions, but also how other sectors can benefit from this. Thank you.
Thank you, Alena. And Florian, I see that you also have something to say. I'm really happy that this question brings a lot of discussion between our panelists. We will leave you the floor. I'll just use that moment to ask, please, if we can go to the next slide. It will show a QR code that you can scan. It's the Menti, and it will bring you to poll questions. Sorry? And it's on the app as well, and so you can also participate. And Florian, please go ahead.
So I'm sorry to completely botch your timeline, but I think it's good
okay.
if we have discussion on that question already, because for me, coming from radiation protection, I mentioned earlier that we also do emergency preparedness. It's sometimes hard to see the big benefit of nuclear with respect to circular economy when, you know, I don't know who was at Fukushima and saw that thing and thinks about circular. It's a bit difficult, but I don't want to. I think that the main point is a single technology doesn't have to be best in all the dimensions of the SDGs, you know? I mean, it's fair to say that it's a very space-conserving energy production type, and it has advantages in many of the dimensions. I think it's not the strongest in circular economy. And I would actually say that for the credibility of the SDGs, you know, in our discussion about sustainable development, it's also fair to acknowledge that there are some aspects of nuclear which are difficult to reconcile with some aspects of the SDGs, while still there are strong advantages with many others. So
as any other sources of energy.
Yeah, as any other source. I know. I don't want.
Which is not what I said. Which is not what I said. I didn't say it was the strongest on all the SDGs. I said it was the strongest on the environmental impacts angles, which is only some of the SDGs.
Yeah, okay. Then we agree. I just want to make sure that
yes. We agree.
Yeah. Thank you very much, everyone. Maybe can we show the next slide some results of the polls that we've shared with the audience, and by letting you time to analyze them, I will ask another question maybe before we leave you completely the floor. So I will start with you, Alena, I think on this one. What role does nuclear play in phasing out of fossil fuel? But to narrow it down, for example, what does a realistic coal to nuclear transition look like on socio-economic impacts, for instance?
Can I start?
Alena, will you give the floor to Emilia? Okay.
No, I feel that I want to start because we are in Poland and I'm Polish and we really want to phase out nuclear. So this is very also a recent topic in our discussions.
Phase out coal.
Phase out coal, so yes, phase out coal, thank you very much. Phase out coal by nuclear, exactly. Our the Polish government prognostic is very optimistic, but it's also settled in reality. So I think this is a very complex and transformational process, but this is also within the plans of Poland to have really phased out by 2050 fully of coal. It will impact a lot of aspects in Poland. We have for the moment 57% of in energy mix based on coal. It is decreasing, as I mentioned, every year. The renewables are going up, especially the wind power, inland wind power, but also offshore. There are also a lot of projects happening now on the north part of Poland. However, the coal regions are very strong, and in the recent ministry's plans, this looks really optimistic that the current, and this is what we see also from the CATF perspective, from coal to nuclear phase out is possible, is realistic, especially if we focus on the small modular reactors. Why is that? Because especially from the capacity point of view and also the size of the current coal electricity power generations, I think this is also very comparable from the size and from the intensity of energy we can get. And the existing infrastructure is there. It is connected to the grid. It is also linked to the social impact of the workers. You know, the regions are depending which are depending on coal. They have a lot of workforces, knowledgeable workforces, trained on different jobs. These jobs can be repurposed, and the skills can be repurposed for the nuclear sector. There are a lot of plans, and this is what is also active now on the Polish ministry side to prepare the workforce. The coal regions see this as the only option from coal to nuclear to sustain their jobs, but also to cover their energy demand and really to revitalize the entire region. So it's not really abandoned, but the optimism in there and the wave of new jobs, new skills, and vocational trainings schemes are already in place. There is one big project with 5 stakeholders. It's called the Desire, where coal power plant Bełchatów is already announcing that it's ready for being repurposed for the sites of nuclear build. So I think this is happening, and we will see in the next 10-15 years the new repurpose especially of the south path of Poland.
All right, thank you very much, Emilia. Alena, maybe if you have a quick comment in 1 minute before we give the floor to the audience, and at the same time, can I ask please to change slides to see the results of the second poll so you can also analyze it? Sorry?
Yeah, so sorry, can you go back to the previous slide so we can just show you, obviously you've all responded to the poll. I mean, as you can see here, public health is really seen as the top priority. Energy affordability, climate change, just transition, and circular economy comes down towards at the end of that list, surprisingly enough, given that we've had such a conversation on that. So, but yeah, let's now go to the second poll, but then in the meantime, I think it'd be good to take some questions from the audience.
All right, does someone have a question in the audience then? Yeah, please go ahead, come to the front, and we invite you to one of the microphones so you can ask your questions. And please, if you can designate one of our panelists to answer, or many of our panelists. Thank you.
Okay, I don't have a certain panelist for this, but given the actual increase of the nuclear energy around the globe, and the fuel demand will also increasing as well the mining and its low efficiency, taking into account that we only take around 1% of the uranium that we are mining, mainly. Also, one of the main strengths is the little space that the nuclear power plants use, but this may be affected by the cogeneration and the different modules that will be constructed in the new builds. So, how is the nuclear field planning to address the problems of mining and the space for cogeneration?
Someone want to take this one? Sorry? Yeah, can you please maybe rephrase the question in short for our panelists? I will also go, yeah, but I also want him to rephrase it because this is not a question that comes from me. So maybe if you can rephrase your question in a few words to make it concise for our panelists, please.
Well, the mining is a problem and will increase because of the environmental damage it causes. And the nuclear energy is also increasing around the world, increasing the mining. So how can we address the society to reduce the damage, the environmental damage that the mining causes?
Mirto, you want to go for this one?
Yes, I can give a quick shot. Thank you for your question. It's a very important question that a lot of people have. There are several answers to that. The first one is there's no human activity with no impact. So everything we do has at some point some mining consequences. The advantage, if I may say, of nuclear has because of the density of uranium, requires very little mining. And there's different technologies like in situ leaching, for example, that are ways to get uranium out of the ground without having to mine per se. But that being said, there is mining involved, indeed. The increasing share that we, at least I hope for, of nuclear in the world energy mix may lead to additional mining at the beginning, but doesn't have to, because first there's very important resources of depleted uranium or potential to go to mixed oxides, fuels, and so on in the future. So using things we have already mined that are considered like reusable waste or used fuel that can be reused in the reactors, the current generation of reactors. And there's the follow-up, the next generations that, as we said earlier, generation 4, the rapid neutrons, the molten salt, and then we hope in 2100s and so fusion will require less and less and less mining. So yes, it is an issue. It is an issue that has to be addressed. It's much lower impact than the alternatives of energy production. And hopefully we are on the right track to make it even less of a problem.
And I'm looking at Hamid, who will probably want to also comment on this, how to minimize the mining within the certain technologies.
I think this is really, if we are talking about circular economy for nuclear, the circularity is first of all in the fuel. One core of 1,000 megawatt electric nuclear power plant, you need to go to get 50,000 tons of uranium ore. That's what you need. This is the most polluting and environment impacting part of the fuel cycle. Therefore, recycling and the fuel that we are burying and people that are telling it's expensive to recycle, they look this just from the purely economic part. If they have to pay their impact on the environment, they will change their mind. But 96% of that fuel we are just burying is still capable to make energy that the Young was telling us. And we recycling the plutonium in today's reactor is just a nonsense, because you are worsening the problem, which is the next one, which is the minor actinide, that makes your geological disposal radiotoxic for 300,000 years, And if you are not just worsening by doing that, you are not solving the problem. So we need a full recycling, and this is also something that the society has to ask. If I am asking just economists that are making money with energy, the cheaper, the less they spend, the better it is. But it's not, they are not making mistakes. They are making the most efficient way the business. But the society is the one that has to ask why we are investing so much in renewable. We know they are very costly, creating difficulties, but because the society asks for it. So I think the role of the society in this issue is very important, and in particular, maybe the youth, you have to ask for it. But to my opinion, this idea of saying that the generation 4, when they will come, will do the job for us, at a certain moment it will be too late. There is a time to introduce this kind of reactors if we want to make use of them. And to my opinion, today we have really to do something. The society has to ask for it, not only the industry. Industry will respond because there is a demand. Thank you.
Just a very quick comment on that, because we intended to talk about carbon tax or carbon price as well, where there's the idea to include some externalities in price, actually, and we see here another externality which is not included currently in the price. And so if you optimize only price, like one dimension, the affordable aspect of it, you have to look at the other dimensions of the SDGs as well. So just to connect this very well-made point, and I support it very much, we as a society have to think about how to integrate the different dimensions into a decision system, and if the decision system is only euros or zloty or money, then it has all to be integrated into the price.
Just really briefly, so this discussion, thank you Hamid to contribute to it, shows that the sustainability and circularity are not always aligned, and the circular economy also is quite often more expensive, economically more expensive than you would not do it. So we need exactly what Hamid said. We need political pressure, we need societal pressure to allow harmonized approach. How do we treat these things in the nuclear field in Europe?
Well, thank you very much, and thank you very much for the question, and I'm really happy that also Hamid could comment on this one together with our panelists. Just to comment on the result of the polls this time, we're really happy to see that for you, nuclear...
Yeah, I wanted to add something that is, what are the actions, the plans that are that we are taking into account now that we are doing, because one of the biggest projects for the spent fuel was not reprocessing, which is the Oncalo. What are the actions that the member states are doing now in order to change this, in order to close the cycle?
I don't know if someone has any answer to what are the current actions for this. Mirto, maybe?
Well, again, there's many ways to answer that question. So I think personally, and to jump on what has been said, the most efficient way to close the cycle is to have the right technologies that will reuse the fuel as best and to as much potential as there is still in the fuel once it went through the current generation of reactors. So the first thing is to accelerate as much as we can the deployment and advancement of Generation 4 reactors. The second thing is obviously to provide a regulatory and project environment that allows that, which means support to R&D, that is what we call the desert curve between TRL 3 and TRL 5-6, where no one wants to finance the projects, and you have to help that passage. We do have to harmonize a little bit more safety authorities' regulations if we want those technologies to be able to be deployed as much as possible, as fast as possible, in as many places as possible. So all of those are very practical ways to close the fuel cycles. And states have to want to close the fuel cycles. In all states worldwide, it's not the policy. The policy is still open cycle. So there has to be expected and asked for by the citizens, I agree, that closed cycle at least is a target. And then we'll align everything towards it. I hope so. I'm working on it anyway.
Thank you, Myrto. So we have to go on with our discussion because there is a second one that goes after, and we would like to give it as much time as this one. Please, if you have any additional question, use the break or the gala tonight to ask them. We also invite you to use the application and ask your questions on the chat. Our panelists for sure will have a look at the end of the session. Just to comment quickly on the results of the poll, we can see that the audience agrees that nuclear can support all of the SDGs, with a majority of you that said that affordable and clean energy or decent work and economical growth, industry, innovation, and infrastructures are the main one that nuclear can support. I'm really happy that this first discussion brought so many questions, so many insights, but we will conclude on this, and I will now give the floor to Jessica for the second discussion. Jessica.
Thank you very much, Ugo. And as we said earlier, obviously, sustainability, it's not just about the environmental aspects. So we've had this first session really focusing on circular economy and the more environmental elements of sustainability. But now we're going to be heading over to tackle that social dimension. And this discussion is really going to focus on topics such as public health, ranging from medical, the treatments, but also the impacts of pollution. Radiation protection, climate justice, and the just transition. And for this, I think I'd like to kick off with you, Elena, really looking at the just transition aspects. And we did touch upon it before. I mean, the transition is expected to bring a lot of benefits. I think we all agree, you know, it's going to be better for the environment, it's going to be better for our health. But of course, there are a lot of concerns around its potential impact on employment, potential job losses in some regions in Europe. How great do you think this impact could be? And do you think that technologies such as nuclear can be part of the solution in terms of ensuring a just transition?
Thank you very much. So when you use the word just transition, we actually have the fund for just transition for the coal regions, actually, on their way to the decarbonization. But of course, it has been already said, and I said it in my speech, there is an opportunity. But if I may, I wanted also to comment the previous question on the transiting from coal to nuclear, which is actually the similar one. But I just wanted to highlight one thing is on the coal, because when we speak to transiting from coal and nuclear, I understand that we speak about the production of energy. But coal is important also for producing steel. And steel, we needed to produce also clean technologies. We need to produce it, the windmills. We need it also for nuclear sector, for other sectors. So we cannot phase out completely because of this crucial role. So I think it can't miss in the discussion that there is a crucial role of the coal in the steel industry. But going back to the just transition, as it has been mentioned also several times, it has a potential to create jobs. I think Nuclear Europe made these analyses about how to achieve the 2050 goal by 150 megawatts with, what, 1 million, 1.5 million jobs? It's impressive. At the same time, I'm coming from a country which has the lowest unemployment rate in the EU, and we are desperately looking for people. So outside of Europe, because it's almost impossible also to find them in the EU. So we will really have to look into it. And I think that, of course, the human being is very important, but we will also have to look how to accompany with the digitalization and robotization, because we will not be able to satisfy such a high demand for jobs.
Thank you very much, Helena, and also thank you very much for pitching our study. The final results will be published on the 5th of June, so I do just take a quick moment and say, watch this space. But yeah, I mean, I'd like to turn to you now, Florian, from the kind of the medical, the radiation aspects. And can you say a few words in terms of how important nuclear is from a broader health perspective? I mean, first of all, from that perspective of reducing pollution and providing medical treatments, but also at the same time ensuring radiation protection.
Yeah, I mean, it's probably my recurring theme this afternoon is about this conflict of goals, because we are heavily connected to the full nuclear community by expertise, by technology. You know, we need radionuclides for specific medical applications. We need the same kind of scientific literacy and understanding in society that people are able and willing to take radiation-related risks that nuclear energy needs to have a rational discourse on different energy production options. And you even have some, conflict of goals within radiation protection. For example, if probably everybody knows in this group because they're experts, but not many people know that women are in general more radiation sensitive than men. So if you would try for or aim for a equally distributed risk in the workspace, in medical, in somewhere else, then you would probably hinder the gender equality thing, because then you would stop some jobs for women that you would allow for men. So for example, this type of discussion has been ongoing in radiation protection for decades to balance these different needs in a rational and risk-acceptable way. So I think to conclude this very short bit is radiation protection tries to connect the different risks in a rational way, but the main point is people have to be literate enough to understand that life is not without risk. No energy production method, no medical application, no life circumstance is, UV in the sun, radon at home. You always have some radiation-related risks, and it's fair enough. You just have to make people able to understand them and judge them and put them into their life perspective on how to deal with things. And I know in the preparation we talked a lot about emergency preparedness and catastrophes and stuff like this, but I think more important is actually the day-to-day life, so that people can actually understand what an additional risk for a screening method in medical applications is compared to some things they might just do, like fly to the US, for example. So I think coming back to the session before us, where it was about education and training and younger generations, I think we have a task in the shared and overall community of nuclear and radiation protection to make people aware that radiation has lots and lots of potential, but there are also some specific risks, and people should understand to be able to decide for themselves what kind of risks they want to take.
Thank you. And it's the first time I've actually heard about the kind of the counterbalance between the radiation and gender. I don't know, maybe others had heard of this, but it's the first time that I've heard that mentioned.
It's a very common example for female astronauts, because if you would have a very risk-adjusted dose limit for astronauts, you would not have female astronauts. But
it's also interesting. I mean, I'll give you my personal experience. I joined the nuclear industry, and literally by chance, the week I joined, or the month I joined, I found out I was pregnant. And I was due to visit all these nuclear sites because I'm a non-nuclear person. And actually, one of the questions I asked to my gynecologist, I said to him, well, I'm due to visit all these nuclear power plants. Is it okay for me to go as I'm pregnant? And he just turned to me and went, well, yes, you're going to be coming to hospital visits, and you're going to be much more exposed to radiation coming to the hospital visits. So, of course, there's no problem at all. So I went and I said, it's not a problem. And I was then informed that because I was pregnant, I couldn't visit a nuclear power plant. But it's very interesting how you learn these things, and probably better communication, better engagement on it is a way of handling that. But does anyone else want to comment on this point, on the... Yes, please, Myrto.
Yes, thank you very much. So first, I'm very happy of how you complemented your answer by quoting the astronaut's job, because when you mentioned that it could have an impact on gender equality of accessing jobs, I thought you meant in the nuclear industry, which hopefully it's not, and the nuclear industry does have protection of its employees and workers good enough so that anyone can go without being exposed at all to dangerous or risky levels of radioactivity. And you got me worried at some point. But what I wanted to say more than, or specifically, is that is very striking in my practice of talking to regular citizens, is that yes, there is risks relating to radiations, but there's benefits. One of the most controversial, the best understood sentence we've been putting forward in the public debate was nuclear saves lives. And I've just checked before the panel. In general, in developed countries, 40 to 60% of all cancers go through radiotherapy at some point. And it goes from 40% to 60%, a lot of, there's alternates. And so the WHO goes very safely around 50%. That's a lot. That's a lot of life-threatening diseases, very widespread, that we've all come across in our lives, in one of the persons around us or ourselves, that is actually half of it is treated thanks to radiation. Yeah. And I think it's important that we stress this fact first before we remind everyone that, like all medications and all interventions on the human body, be it for medical or health related issues, can meet with some risks, but that's not what we go for to them first, and that's certainly not what we should highlight first.
There will be a session tomorrow on the medical aspect as well, but I just want to make sure that the connection again. I mean, for example, for radionuclide therapy, you need working reactors because they have a very short half-life, and so you have to get the nuclides from the reactor to the patient in 2 days. And this is it's a high-tech supply line in Europe, which is very important for citizens and for modern applications, and it's directly connected to the good health and well-being and the industry in Europe, and it is a direct combination of radiation protection and nuclear industries in a way that should be integrated also in the Euratom research funding and thinking of the different communities.
Thank you, Florian. So I think that's a pitch for the session tomorrow. If you haven't seen it in the program and you're interested, check it out. Yes, please, Elena.
Yeah, I just wanted to add, it's really about raising awareness, because people right away think about the electricity coming from nuclear energy, but then they don't think about other sectors like space, agriculture, or medical sector. So in Europe, almost 10 million patients benefit from nuclear medicine every year. 10 million people. So I think we really have to raise the awareness. With Philippe, we were in Geneva. We saw how quickly you need to bring these radioisotopes to the patient, 15 minutes. Some have a very short life. So it's very important, and we work on the supply, the security of the supply of these radioisotopes. But what we've seen as well is when we talk to the doctors, they said that not every doctor knows about such a medicine. And so this is important. So not only the civil society, but also those professionals working in that they should know what are different treatments for the patients. So I think really educating people and talking about it, it's very important.
Thank you, Elena. Maybe a final comment from you, Tanya, whilst the audience starts to prepare their questions to you all.
I just wanted to say that I don't find really comfortable to compare medical use of ionizing radiation with ionizing radiation that we use to produce the nuclear energy. These are two completely different things that we should not put in the same basket. It's not ethical and it's not morally right. From a radiation protection point of view, we would all agree, I believe, that we believe in linear threshold model, so every additional radiation is additional risk. And we are scientists, we have to stick to it, and just to speak also about the benefits, it depends, I mean, we need to be aware of these 3 pillars that radiation protection has, and we need to think into from this point of view, so justification and so on.
Thank you, Tana. Yes, indeed, a very valid point. And if we can switch to the next slide so we can bring up our next poll, whilst I look to the audience to see if you have any questions. So if we can go to the next slide. Okay, so we should have the next poll on screen. Does anyone in the audience have a question for the panel? Okay, but maybe I come back to you then, because I still have plenty of questions for you. And it's coming to this point on climate justice. I think you all saw in the briefing there's a lot of different things that we were looking to touch upon in this panel. One of them was climate justice. So I'd actually like to hear from you, what does climate justice mean to you? And do you think nuclear plays a role in this debate or not? If you don't need to say anything. But I'd also like to hear from you what you understand from climate justice. And I don't know who'd like to kick this one off.
Yeah, I could, because I have a question actually to the audience, but I will start with the climate justice aspect. For me, it means that those areas who are most affected by climate change usually are the least responsible for climate change, and therefore they should also have to contribute less to the solution of the climate problem. That's the overall dimension of the climate justice problem, and this means that some of the historically very coal-reliant countries like Germany or Poland might have to be more involved in the solution of the climate problem than other countries that bystep this step. But we had 8% of people in the last poll saying that nuclear helps to reduce inequalities. And for me, this climate justice inequality is something you can look within a country, but you also can look across the globe. So maybe the persons who mentioned these inequality stuff might mention how they make that connection from nuclear to reduce inequalities to climate justice, if they're interested. So,
thank you. And maybe Elena or someone else, do you want to go ahead, Mirto?
I'm happy to take all questions. No, but climate justice is very important and particularly dear to my heart, maybe because of my personal background as well. I have one foot in the developed world and one foot in what is the developing world, let's say, as far as my family heritage is concerned. And I think we often get it wrong. When I see the environmental movement, the youth advocacy activists on climate, talking about climate justice, I personally feel they sometimes get it wrong. Because they forget that it is a tension between mitigation measures and adaptation. For the developing world, climate justice means, should we save the children of today? That's adaptation to climate impacts and extreme weather events and so on. And mitigation, which is saving the children of tomorrow. Well, a lot of countries have an issue is saving their children of today. And we tend to forget, and it's a little selfish, if I may say, and we tend to be shy on admitting that there is somehow of a direct connection between climate justice and prosperity. We need to share prosperity, the prosperity we did enjoy in the past, the prosperity that people need to enjoy today, and the prosperity that's required to take the adaptation and mitigation measures that everyone needs at the local and at the global level. So I think we need to remember that climate justice is most essentially about not depriving others of the benefits of development we enjoyed and we enjoy today.
Thank you very much, Mirta. Would anyone else like to comment on this one? If not, I turn also to the audience, please. If you have a question, come up to one of the two mics here at the front. But maybe we go to the results of this poll, because it's quite interesting. I mean, if you're wondering where this list came from, we didn't just make it up. It is actually a list from the World Economic Forum, so just to clarify on that point. So what do you think are the three greatest social risks today where you live? And of course, we know that depending on where you're from, the issues for you can differ. But what I find very interesting is two which I think personally are very closely linked. So the top one is misinformation and disinformation. And the second one is societal polarization, which perhaps in a way is linked to the misinformation, the disinformation. And they really come up top on this. Then next to that, we have extreme weather events. So we do see that climate change is still an issue for some people, and they really feel that we need to tackle it. State-based armed conflict, probably being in Europe, it's normal for it to be on that list. So, I mean, I don't know, do any of you have any comments on the results of this poll? Does it surprise you? Is it in line with your country or what you see around you?
I think the polls would not answer with misinformation, disinformation is the biggest threat. Probably you can guess what would be the first answer regarding the threats and the social risk. And I think this is impacting very much also the perception or the worry about the climate change issues in Poland is decreasing, in my opinion. This is from what I observe. Another way, the energy security and being independent is what helps to increase deploy the low carbon technologies in the same time. So even if the social worries is not on focusing on the climate change, and so we worry about the kids of today because of the war next door. It is really in line with the energy security and being independent. So I think this is the same goal, but with different means and with different pathways. I wanted also to talk about the societal, maybe not polarization, because this is really a big also topic now at the moment. We are just on Sunday, we have the presidential elections on Poland, so you can imagine how polarized the Polish society is at the moment. But I wanted to also talk about the trust in the sources of information and where we tend to look for information. I'm living 50 kilometers away from the first nuclear power plant localization, and since 15 years on site already there are contact points for the local communities to be informed what will happen, what will be built there, how does it impact the tourism, because this is a seaside localization, how does it impact their health, how does it impact their work life, the social life, and so on. So the Polish energy group takes it very seriously, and since many years they are already having the offices to answer all possible questions that people are coming with and asking the questions. So I think it's important, the communications and building the trust in the reliable sources.
Yes, we were investigating also in Euratom projects misinformation and disinformation. We included also rumors and manipulation. And so what is the difference? So misinformation is when people, we are somehow misinformed, we unintentionally, and then we speak about these things and they are not correct, they are false. Disinformation is something which is done by purpose. So with some motivation behind that something would be achieved if you spread something that it's not correct, but it's by purpose. And then also manipulation, for instance, is the communicating only partial truth, that you don't present a full picture, but you present only positive or only negative about particular issues. We investigated this in nuclear field, and we found in all these three types a lot of examples that they are going on. What is the common for all this is that all of them, they include some piece of the truth, and all of them, they are believable, they could be plausible. So it's really difficult with this, but also in the nuclear community, we need to be really careful when we communicate, because people, they can recognize when we manipulate, when we misinform or disinform in whatever field. What I wanted to also say related to these findings is that in another project, Euratom project, EcoSense, we conducted research, qualitative and quantitative, so surveys and the focus groups in 6 countries, in Belgium, Spain, Czech Republic, Slovakia, Slovenia, and UK. And we investigated about the energy mix. And so the most favorable solar, wind energy, other resources, nuclear, the coal is the least, it's really rejected. But we also asked them investigated what people see in the small modular reactors, for instance. And what it surprised us, that they, rather than beating the climate crisis and the environmental crisis, people saw in the new nuclear technology contribution to the long-term security. And this relates to these armed, state-based armed conflicts, I believe. But what we also found out is that people in all those countries, they really struggle to recognize the advantage of SMRs, which are still considered as, now I use their word, unproven technology. So the SMRs is something which is really far in the mindset of the people.
Yes, thank you, Tanya. Just to say, we do still have maybe 5-7 more minutes for questions from the audience. So if you do have a question, raise your hand. But let's head over to you, Florian, because I think there's probably an element of trust in all of this as well.
Yeah, it brings us back to the first circle that we had on screen today, the SDG circle. If you think about this as a complementary circles, you see the risks and the SDG goals as a way to reduce risks, essentially. And I forgot who brought up the picture of the 3-legged sustainability alien in my head with the social, economic, and environmental dimension. You see those 3 legs as well in the risks. But as you said, and I guess you guys are experts to identify the greatest social risk of your respective countries. So the greatest risk is about trust. And how can we actually, if we map it on the SDGs, what does that mean with respect to focus on a specific SDG? And I think what Tanya started today is about these partnership aspects and the strong institutions where people of different communities tell the same story. They accept that other people /groups /countries have different opinions, but make their point so to have a civilized and rational discourse on risks and chances of goals. I think this is the only way that we can actually address this, because I think there are policy systems which actively use those aspects as a chance to bring disorder and insecurity into our society. So I think we in Europe, we have to use the institutions that we have. We have strong institutions in the nuclear fields. We have lots of exchange. We have conferences like this, but we also have permanent institutions where this exchange happens all the time. And I think we should use it to have the same messages across borders, across different priorities in energy systems with regard to the really important aspects of risks and scientific truth and the way forward towards sustainable development.
Yes, thank you for that. And maybe if we can bring up the next slide, because we have the final poll of this session. But in the meantime, whilst they're bringing up the slide and you're answering that question, I mean, Mirto, Elena, do you have anything that you'd like to comment on this? I don't know, Elena, do you want to go first, or Mirto?
Always. Yes, indeed, because I think this question of the polarization of society and having our facts right is something immensely important in all fields now and across the planet and across the social and economic spectrum. And it was one of my first point at the beginning, at the introduction, which was it is also at the individual level that their responsibility has to be held. It's get your facts straight. So that's something we're all responsible for, and they have to be as rational as possible, especially in science fields. It's kind of easier. But it's also coming back to something that was said in the previous panel, that as far as nuclear industry in particular is concerned, the workers and employees of that industry have a personal responsibility to share their knowledge and their personal experience with everyone else around, so that we leave the field of pop culture and fantasy and imagination and fear that has been developed and deployed, as we all know, for the past 30 years in particular, because that field had been left empty. And one thing I've been saying for a long time to employees of the nuclear industry is, yes, you will be accused of being the lobby, but just remember that you being in the nuclear industry doesn't make you untrustworthy. On the contrary, it makes you knowledgeable. It makes that you have something to share that you've experienced firsthand, and that's very different from the word of a word that has been transmitted. And that is, there is a personal responsibility of workers of the nuclear industry to go out and take the risk of being challenged, of maybe being wrong, of trying to dig deeper into your own understanding of what you're doing, so that you can share that knowledge with others and contribute to this.
Thank you, Mirto. And now looking at these results, I mean, these are quite well balanced out, I would say. None of them selected the top results from the previous one to do with misinformation and disinformation. But as you can see, there's a lot of focus on that economics. So nuclear could bring solutions in terms of the economic downturn. It could bring solutions in terms of economic opportunity and jobs. We have also at 25, the top one here is extreme weather events. So again, a solution in terms of tackling climate change, and then geo-economic confrontation. So I think, broadly speaking, climate change, economic opportunities, and employment seem to be the top ones that there's consensus in this room that nuclear can bring solutions towards. And so maybe here, Elena, I mean, we do have, I would say, a couple of minutes left before Ugo gives us a few concluding remarks. But coming from the Economic and Social Committee, do you agree with this?
With the results?
Yes.
I mean, the room is a bit emptying, so yes. Maybe the biggest supporters remained in the room. But, I mean, I would just want to say that what's also happening in Brussels at the EU level, it certainly differs a bit from what we see as a result here. All of us, we know the story of Christian Andersen, the ugly duckling. And I have the impression that how the nuclear energy is tackled at the moment within the EU institutions as the ugly duckling. And I think it has changed. It has to change. While the energy mix definition is in the competence of member states, still we hear the instructions of what the proportion should be of renewables and that we need to phase out from fossil, but still nuclear remains a bit aside, something that nobody wants to touch. And I think it has to change, because today we've seen how it can contribute to the SDGs. Of course, it has its pros and cons, but it should not remain like a topic that is hidden and nobody wants to tackle, because we have a big proportion of member states that actually have the electricity produced from nuclear energy. And as we've seen, all of them actually produce the waste and use also the nuclear energy in their medical sector. So stop with this ugly duckling story in Brussels. That's my conclusion.
Okay, thank you very much, Elena. And I think this marks the end of our... maybe Mirto, no, you want to add something?
Yes, this one I ask to answer the question, because I actually quite disagree with those results, and especially with one of them, which is a 0% that consider that it was could bring solutions to state-based armed conflict. And that's something that I kind of feel strongly about, which is, to me, nuclear is an instrument of peace. It's geopolitically sound. The uranium doesn't have conflicts of use. There's nothing else you can do with it. It's rather well spread. It's not going to be in use forever. The next generations of reactors are going to need less and less of it. But mostly, you cannot displace a nuclear power plant. And a nuclear power plant, when it's in a country, it serves the people around, the communities around. It involves the communities around. It requires a lot of collaboration and coordination between the different countries that have been involved, between the different levels of authorities, from local authorities to state authorities. It requires continuous cooperation between the people, lots of people on site, academia, science. You cannot, like you would do maybe with a can of oil or a canister of gas, you cannot take it and run around with it. And run away with it. You cannot steal it from one country to bring it to the other. I mean, it has that particularity of functioning, that it is complex and long, yes, and it's not available everywhere today, but it kind of grounds the energy benefits to the ones that are procuring it and providing it. Without even getting to the fact that since it brings energy and fights energy scarcity and poverty, by definition, it tends to reduce reasons of conflicts and chaos and stuff like that, because we see that roughly development supports orientation through more peaceful exchanges and interactions between people and states.
Thank you, Myrto. I think, Tanya, you have a reaction. May I ask you to do it in a couple sentences, please, given the time we have?
Okay, I just want to say that we should not close our eyes from being nuclear power plants used as a weapon. Just this. And also in psychological operations and in the practices that they are going now, at this moment on, and also we were witnessing in the past. So nuclear power plants are used as a weapon and psychological operations.
Well, thank you very much, Tanya, for replying to Myrto. That was a broad discussion, I think, that will spark a lot of discussions during breaks and tonight. I would like to give a heartfelt thank you to all our panelists for taking part in this panel, as well as thanking Jessica for co-moderating with me. Sorry? And I would like also to thank our little audience that was there and for their question as well. I will also finally thank the European Commission and the Polish presidency for the organization of this conference. And with that, I wish you a good end of the day. Thank you very much.